Welcome to ViteConf 24. We made it. Hi, Matthias.
Hey, Sarah. Welcome, everybody. It's so amazing to be here with you and with everybody else from our communities in this third ViteConf. It's going to be an amazing party. All the frameworks and tools in the Vite ecosystem are represented. So, yeah, buckle up. This is going to be really interesting. And yeah, what do you think? Like, first, what I wanted to do is to thank everybody that made this conference possible, because there is a lot of people involved. First of all, the speakers that put so much work into the talks. Same, like we are going to enjoy it together. Thanks a lot, Sarah, that you are also a speaker, not only here with me presenting things. And yeah, like the speakers is what really make this special. So thanks. And also, I wanted to thank the communities that, like, this is a community conference. Like, we all our communities from our different projects get together this day to enjoy and to, like, let's say, celebrate that we all collaborate together. And two extra things is that thanks a lot to StackGrid for once more organizing and sponsoring the event, and for all the community partners that really helped us spread the word and invite people to the conference today. So we have a good show, and we are going to be all in the chat together. This year we have more than 30K registered. So yeah, like the conference and the ecosystem keeps growing.
So everyone's in good company. Thank you again to the 30,000 people who grabbed your free ticket, who are tuning in to watch us. And the first thing we'd like to do is point out the conference's code of conduct. So please take a moment to go to viteconf.org/COC and check it out. There are so many people here. There are so many speakers, so many topics. There's going to be a live chat going the whole time, and lots of opportunity to engage with the speakers and with your fellow attendees. And we just want a super chill time. We want everyone to feel comfortable, included, and welcome. So please do check out the COC. There's a lot of frameworks here. There's a lot of libraries. You might have your favorites. But today we are all together under the ViteConf umbrella. And there's going to be so much room and space to interact with everyone else. We just want it all to go smoothly. And in that chat, which Matthias and I are going to be in for as much of the time as possible, there will be moderators. We will both be moderating. If anything happens, please do report it to us. We don't expect many problems, but do check out the code of conduct. Do treat your fellow attendees and speakers with respect so we can have a great time. And once you've looked at the code of conduct and you're ready to go, where should they go, Matthias? What's the big link? What are we doing here?
Okay, so like everybody, after that, very important what Sarah just said, go then to viteconf.org/live. This will be the main link that if you want to invite anybody else to join us today, send it to this address /live. And here you're going to see the player. There in the right side, you're going to have the Discord chat, and this is connected to our own Discord in ViteLand. So where Sarah just said that we are going to be chatting, you can go to chat.vitejs.dev if you are not there already, or press the button in the player. The idea is that you can invite all your other communities in Discord, and let's come all together here to this particular Discord to chat and to collaborate. And a little bit about the format of the conference. This is the start of a very long marathon. It's like 24 hours ahead of us. And there is going to be 12 hours of content, more or less like 45, 46 talks. And yeah, the idea is that after that first 12 hours, the same content will be repeated in the stream, but in the chat, we are all going to still be there. It's all going to be still like that live. And we do this because we want to include everybody around the world. Wherever they are going to wake up, they can start watching the talks and watch all the content of the conference. So yeah, during the next 24 hours, please join us. And also look out in the ViteConf.org. There are some workshops this time that are going to happen too on the 4th after the conference is finished. So like you can also register for that. And yeah.
So get yourself ready for 12 hours, settle in. There will be breaks. We have learned from past conferences that we need a few minutes every now and then. So there'll be plenty of time to take a small break, to ingest what you've just learned, to have a quick chat with someone in the chat stream about what you just saw, without worrying that no, you gotta now pay attention to the next talk. So we're happy for that as well.
Yeah, that's a good point. And also, like, what is important is that all these talks are going to be in YouTube afterwards. So like if you miss one now, like it's not the end of the world, so don't worry. And also we can have async interactions. Think of the talks about sparking further discussion. Like if you like some project that you are seeing, go later on, like talk with that speaker, go to the repo in GitHub, like play with them, like start to collaborate. This is a celebration of what we do in the ecosystem and in open source in general. Let's collaborate together during this time.
And we will have individual channels for each talk as well on the Vite Discord for that more async conversation. Speakers, as much as possible, will be live and in the chat during their talk. But they might not be able to attend both of their talks because of time zones. So we will also make sure you can find your way to that special talk channel so you can leave comments and questions there and keep the discussion going after the conference.
Yeah, that's great. And you may remember also that part of the interaction that we will have also with the talks, with the chat, there is also this button below the player that is called run the talks code. And while you are seeing an example shown by the speaker, you can press that button and you can actually play with the example that the speaker is showing. So like this, we try to make this as interactive as possible. So if you also like have these examples, you can like change it, remix them, and like also share it with us in the chat. And yeah, so I think that we should go for it, no?
I think so, because I think there's so much content to go. I've been told that there will be some surprises, but they wouldn't even tell me what the surprises are. So I'm ready to get going.
Yeah, I don't want to spoil things for you. Like it's going to be really interesting. Yeah, like right after us, Eric is coming now, like with also to kick off the conference, and then Evan, you the keynote about Vite. Really like enjoy that one, and like all the talks that are coming. There's going to be also a very interesting keynote with Eric and Alex from Anthropic, like about web container and AI. So like watch out for that one. And actually, like, yeah, I think that I will just start mentioning all the talks because they are all amazing. Go to viteconf.org/schedule, and there you can watch everything. So yeah, let's start. Let's go with it. So welcome, Eric, and welcome everybody. Let's have a great time.
Hi, everyone. I'm Eric. I'm the co-founder and CEO of StackBlitz, and it is so great to host ViteConf again, already in our 3rd edition. Can't believe it's been 3 years. And wow, we've already had over 30,000 developers register for this. So I'm really excited for you all to be tuning in. We have some amazing announcements happening today that I think you're going to be really excited about. And I know Evan actually has something very important to announce. So why don't we go ahead and give him the stage and enjoy the rest of the talks today. I'm going to see you in about 2 hours, I think, at 9 o'clock Pacific time. As in previous years, I think you're going to love what the StackBlitz team has been cooking for you all. So without further ado, I want to go ahead and hand it over to Evan for the announcement he's got.
Hello everyone and welcome back to another ViteConf. I'm Evan Yu, creator of Vite, and I'm really excited to have you here with us online again. And I've got some big news to share with you, and it's about Vite and the future of JavaScript tooling. So let's get right into it. First of all, a customary look at the NPM downloads. We've passed 15 million weekly downloads. That's more than double compared to last year's ViteConf. And just a few days ago, we had a single day with more than 3 million downloads. Pretty amazing. On the other hand, Vitest is quickly replacing Jest as the go-to JavaScript test runner, crossing 6 million weekly downloads of its own. In the latest State of JS survey, Vite and Vitest topped the charts in almost every applicable category. Most adopted, highest retention, highest interest, and most loved library overall. I was really pleasantly surprised when the results came out, so thank you to all Vite users for the love. And we have a vast ecosystem that keeps growing. Vite is now the default tooling for most frameworks when building an SPA, and powers almost every JavaScript meta framework except Next.js. Vite-based frameworks are now powering some of the most high-profile applications and websites in the world, ranging from OpenAI's ChatGPT to Shopify, Reddit, Porsche, Linear, and many more. It also has first-class integration with tools like Storybook and backend frameworks like Laravel. The significance of this convergence, in my opinion, is that frameworks building together on top of Vite can share a strong interop story. Not only can they avoid reinventing the wheels assembling a custom build stack, they can also share plugins, test runners, and even deployment adapters, allowing each framework to focus on innovation in areas that really matter. Saying this last year might have been a bit premature, but today I think it is fair to claim that Vite has become the shared infrastructure layer for the next generation of web applications. With all that said, I would be the first one to acknowledge that Vite isn't perfect. The trust that the JavaScript community has placed on Vite has pushed me to think deeply about its flaws, its future, and what we should do about it. I came to a pretty ambitious conclusion, and I want to go through my thought process with you today. Let's start with why people love Vite. People love Vite because it makes web development feel simple again. Note that this implies at one point, everyone felt web development was becoming too complicated. And it's true. Vite is hiding a lot of complexity from its end users under the hood. Internally, there are many things we wish we could simplify, change, or improve. We're only able to handle all that complexity thanks to the underlying tools that Vite is built on top of. Mostly ESBuild, Rollup, and SWC. ESBuild is used for dependency bundling, transforming TypeScript, JSX. It's also used for target lowering, syntax lowering transforms, and minification in the production builds by default. Now, Rollup is used for production bundling, and we use Rollup, a Rollup-compatible plugin system. SWC is not really needed by default, but if you're building a React app and want faster React refresh transforms than Babel's, you should be using the SWC-based React plugin that we provide. So when you're using that, you're effectively going to be using all 3 of these dependencies through Vite in one single application. Now, this architecture works, right? It's been working pretty well for a lot of you, and we are grateful that these tools allow me to delegate all these hard problems to them. But it has very glaring problems, and let's go through them one by one. First, I need to explain why we need 2 bundlers in the first place. We use ESBuild, which is blazing fast, but its tree shaking and code splitting are not as complete and configurable as rollups. And its plugin system is a bit too rigid compared to rollups. So we only use it to bundle dependencies during development. This is called the dep pre-bundling or the dep optimizer as we know it. By default, we also use ESBuild as a transformer to transform TypeScript, perform syntax lowering as I just mentioned, and minify chunks during production. We use Rollup for the production build because it is better suited for bundling applications compared to ESBuild, given that it has better chunky control and a bit more flexibility in configuring the tree shaking behavior. However, Rollup is written in JavaScript. While the bundling performance is better than Webpacks, it is much slower compared to bundlers written in a native language. For example, ESBuild. And for SWC, one of the reasons we don't really include SWC in Vite by default is because it's heavy binary size. On macOS, the binary is 37 megabytes, and that's more than twice the size of Vite and all these dependencies combined. And while SWC has comprehensive transforms and a high-quality minifier, it doesn't really offer a usable bundler. So even if we include SWC, we still need to use another bundler to cover the other parts. So we are unfortunately stuck with this multi-dependency scenario. The first problem that this leads to is behavior inconsistency. There can be difference in the ways ESBuild and Rollup handle mixed ESM and CJS module graphs. And sometimes this can lead to subtle bugs that can only be discovered after production build goes live. Not good. Second is the massive inefficiency in the build pipeline. The same piece of source code in a Vite production build gets repeatedly parsed into AST, transformed, and serialized back into strings by these different tools. And worse, they're often passed back and forth between native side, for example, the Go process, and JavaScript main thread, and then passed to Rust, and then passed back to JavaScript. So all these passing these large chunks of data across processes also has a lot of overhead. And it gets even worse when source maps are enabled because every individual step between these tools requires remapping of the source maps and merging them. Finally, the unbundled native ESM dev server works great, but only up to a certain threshold. The network overhead when you need to load tens of thousands of unbundled modules over HTTP really adds up. And it can take seconds for a page to load during development. While probably 90% of apps we're building are not this big, but the development experience for that other 10% becomes problematic compared to a fully bundled approach. Unfortunately, in the current model, we don't have a good solution for this. We wish we could use a bundler to do full bundling during development too, but ESBuild is incompatible with our plugin system and will result in even more development production inconsistencies, while using Rollup will just simply make it too slow. So, sounds like we need to unify the bundler used in Vite by building one ourselves. And that is exactly why we started Rolldown. But before we dig into Rolldown, I thought a bit more. As we worked on Rolldown, I dig deeper into the idea. I found that even the abstractions below the bundler layer have similar problems. So why do we stop at the bundler? I realized that the challenge Vite is facing is really a reflection of the JavaScript ecosystem at large. JavaScript grew from a simple scripting language to literally the most widely used language in the world today. During this process, the JavaScript community created many different tools to bridge the gap Between its lack of official tooling and the rapid growth in the scale and complexity of its use cases, we're building more and more ambitious applications, and we had to create all these tools just to scramble to keep up with the demand of all these engineering best practices and newfound complexity and the requirement to have types, the requirement to bundle, minify, and everything. We discovered these problems along the way and created tools to solve them along the way. This is a blessing and a curse, because the JavaScript ecosystem is probably the most vibrant community out there. There are so many innovations, so many great tools that came out. It did give us all the tools we needed, but it also gave us a new set of problems. That is fragmentation, incompatibilities, inefficiencies, and in many cases, frustration. My conclusion is that to eliminate the inconsistency and inefficiency issues, a unified toolchain for JavaScript is needed. It starts at the parser and includes semantic analysis, transformer, linter, formatter, minifier, bundler, all the way up to the common layer of abstraction that supports the final frameworks. And that common layer is Vite. And this is also what I believe this toolchain should be: unified, high performance, composable, and runtime agnostic. First, unified. All the different tasks involved in the process of turning source code into final build artifacts should be performed by the same set of tools using the same AST, with the same consistent rules for configuration, module format interop, and path resolution. Second, high performance. For well-defined tasks like transforming TypeScript or bundling code, the tool should be written in a compiled to native language with an obsession for performance at every possible chance. Given JavaScript scale today, performance improvements in our tooling is a huge leverage that speeds up not only dev cycles, CI builds, product delivery, and ultimately saves money for everyone. Third, composable. The toolchain should be composable. Each component of the toolchain should be individually consumable as a dependency. For example, the parser, the resolver, and the transformer should all be usable as Rust crates or NPM packages. There should be efficient Rust.js interop so that users, while leveraging these native tooling, can still write JavaScript plugins to fit their needs. And finally, the core of the toolchain should be runtime agnostic. Developers trying to leverage these tools, or just a part of the toolchain, should not be forced to lock themselves into a specific JavaScript runtime. We want the same development experience no matter what runtime or target environment you are targeting, as long as you're writing JavaScript. Now, you might be thinking, isn't this just way too ambitious? Well, I used to think so too. Some other folks have even tried and failed. But think about it. 4 years ago, who would have believed that Vite would become the convergence point for JavaScript frameworks as it is today? Well, I believe if we have the right people, the right execution, the right leverage, and enough resources, this goal, despite it being very ambitious, is indeed possible. So this is why I started a company called Void0, a company building the next generation of JavaScript tooling. We have raised 4.6 million seed funding, led by Excel, with participation from Amplify partners and many experienced founders in the DevTools space. We have built a full-time team that is working hard to realize this vision. Now, here is a big picture overview of what we are building at Void0. Oxc will be the foundational language toolchain that supports everything. It includes the parser, semantic analysis, transformer, minifier, resolver, linter, and formatter. Rolldown is the bundler built on top of Oxc and will be the unified bundler powering a future version of Vite. Through Vite and Vitest, we will be moving all frameworks and tooling depending on them to a unified foundation. So, let's talk about the progress so far. This is the progress chart for Oxc. For Oxc, we have already completed the parser, linter, and resolver. Borschen, Oxc's project lead, will actually talk about this in more details, so I'll be a bit brief here. For the transformer, we've already completed TypeScript, JSX, React Refresh transforms, and isolated declarations for TypeScript DTS emit. Our current focus is on finishing the transformer with syntax lowering transforms. The minifier and formatter are in working prototype state and will be worked on after the transformer is done. And now, how fast is Oxc? This is the meaty part. To the best of our knowledge, we're proud to say that it's probably the fastest in every comparable category out there so far. It has the fastest parser, the fastest linter, the fastest resolver, and the fastest transformer, or up to 3 times faster than other Rust-written solutions. I have linked the benchmarks, and you can check them out yourself after the talk via my shared slides. There are some other often overlooked metrics I'd also like to mention about Oxc. First of all, it uses much less memory than, for example, Babel. It also uses less memory than SWC. And it also ships significantly smaller binaries compared to other solutions. Remember I mentioned the reason we didn't want to include SWC by default in Vite was because of the binary size. So Oxc transform, when used as a npm dependency, downloads the respective binary for the target platform, and on macOS, the size is only 1.95 megabytes, less than 2 megabytes, and that is, well, almost 20 times smaller than SWC size, right? And if you use Oxc as a Rust dependency, as a Rust crate, it also compiles much faster because it doesn't rely heavily on macros. So that also improves your development experience if you're using Oxc as a Rust developer. Now, on to Rolldown. For Rolldown, we have already completed most of the features you'd expect from a bundler. Notably, CJS and ESM interop, source maps, output formats, basic code splitting, CLI, config file support, and all that. Typical things you'd expect from a bundler. But on top of that, we also have Oxc integration, which means Rolldown actually ships with built-in TypeScript and JSX transforms, built-in Node-compatible resolving, built-in alias handling, and everything that you expect from a fully featured resolver. And it also has finished some advanced features such as production quality tree shaking, advanced chunk splitting options, which is actually more powerful than rollups already. And we have reached 90% compatibility with rollup plugins. Only some niche options and properties are not supported, and it can already run a good chunk of official rollup plugins, unless it relies on some specific properties that we do not support. So right now, we are focusing on 2 things for Rolldown. The first is making Rolldown a general-purpose bundler that has first-class support for CSS, HTML, and assets. And the other is testing its integrations into Vite, replacing ESBL Rollup and porting some of the Vite internal plugins over to Rust to reduce overhead. This work-in-progress Rolldown Power Vite, which we currently just call it Rolldown Vite, currently passes 98% of dev tests and 82% of build tests. So we're on a very good trajectory to complete the test coverage and then start releasing it in alpha state. Once we finish these 2, it will be some more behavior alignment, performance tuning, and code quality polish before we release Rolldown as a 1.0 beta. To get an idea of the performance of Rolldown, we used a benchmark forked from another bundler, and we increased the number of components the benchmark contains. So in our version of the benchmark, we're bundling 19,000 modules, where 10,000 of them are React JSX components and 9,000 are Iconify.js files. Now, Rolldown completes the bundle in 0.63 seconds. That is almost 2 times faster than ESBuild, and 3 times faster than Farm, and 5 times faster than RSBuild. Note that we don't even include JavaScript bundlers in this benchmark anymore because the bar would literally go out of the screen. And if we try to bundle this application with the current Rollup-powered Vite, it actually just runs out of memory and never finishes. Another case study that is a bit more real world is using Rolldown and Oxc to bundle Vue. Now, Vue's codebase is a pretty non-trivial codebase. It's a TypeScript monorepo with 11 packages and 62 dist bundles. There are cross-dependencies between these packages. We use TypeScript everywhere, and there are a pretty complicated cross-package dependency graph and some pretty custom pre-built steps that we have. So we actually, being able to migrate over from our previous Rollup-based build setup over to Rolldown, actually simplified the config by quite a bit because there are multiple plugins we were able to remove that are supported just as built-in features by Rolldown. Now, notably, the bundle packages and TypeScript declaration now using Rolldown and Oxc's isolated declarations DTS emit transform are passing not only Vue's own tests, but also Vue's ecosystem CI tests, where the build artifacts are tested in the real build and test flows of a dozen downstream Vue ecosystem projects. So this is a good testament for the production readiness of Rolldown and Oxc in general. Although we don't really consider them production ready yet, we consider being able to pass Vue ecosystem tests a very, very good milestone that we can use to verify how ready it is. Now, because successfully passing all these tests required correctness in every aspect of the pipeline, including transforms, platform and format output, plugin compatibility. Also, the pre-minified bundle size are matching that of the output of Rollup, which means there is comparable tree shaking and dead code elimination quality. And of course, the performance. Here we are comparing 3 versions of Vue, three commits at different times. 3.2 were about 19 months ago when all the tooling that we used were written in JavaScript. And it was also inefficient because we were essentially generating DTS for each package individually. Now, in 3.5, the current main branch, actually probably in 3.4, we did a major build refactor. We migrated over to ESBuild, using Rollup plugin ESBuild to do the TypeScript transforms. We are using SWC for minification, and we moved over to Rollup plugin DTS for DTS bundling. So that was actually a big round of optimization, but the main bundling was still using Rollup because it was the only one that was able to retain the same bundle size in the production builds due to the tree shaking requirements. So in Vue 3.5 main branch, the current full build time including types, is 5.5 seconds. Sorry, compared to the 3.2, close to 2 minutes. That's already a pretty big improvement. But now, after migrating to Rolldown and Oxc transform for the DTS emit, the whole build takes a little bit more than 1 second. And this is not even the most optimal form yet, because right now we are doing the DTS emit and bundling in a separate process in the second step. In the future, Rolldown will include the DTS emit and bundling as a built-in feature that's going to be performed in parallel to the source code bundling. So when that happens, the whole build process for Vue will be well below 1 second. So that is the progress so far, and what's next? So first of all, let's take a look at Vite today. This is Vite today. This is showing the architecture of the upcoming V6 with the environment API merged. It still relies on ESBuild, it still relies on Rollup, and if you're using React, you want fast, refresh, transform, and you don't want to use Babel, you will still be using SWC, right? So this is Vite today, and in the worst case scenario, you'll be using 3 different tools that's wrapped inside Vite. This is the next evolution of Vite, and its current work in progress as will be known as Rolldown Vite. It is powered by Rolldown and Oxc internally. It will greatly improve the dev product consistency because now there's just one toolchain that handles both development and production bundling. It will reduce the internal overhead because there's just less code passing between different tools. And it will greatly improve the production build performance because Rolldown is written in Rust and it's blazing fast. So this is going to be the version that we'll be focusing on right now, and we hope to get it into your hands early next year. And in the longer future, we will likely ship a version of Vite that delegates even more to Rolldown. And we use the same bundling capabilities of Rolldown for development, environment module runner, and production. So this allows us to get rid of the unbundled network bottleneck for extremely large applications. It will also ensure maximum consistency across browser environment, simulated Node.js server rendering or worker environments, and also for production builds. It will provide the best possible performance in all of these scenarios, and also gives you a consistent toolchain that handles all the tasks together. And this is our long-term goal. Currently, it's in prototype stage because the first thing we want to do is to make sure that the full bundle mode can actually work, and we can actually also have HMR on top of a full bundle emitted by Rolldown. And the full bundle mode performance prototype is, again, very promising. From the benchmark, using the same React JSX-based mock application, we can see that the page load is more than 5 times faster compared to today's Vite, compared to the unbundled version of Vite. And the HMR is also close to instant with some optimizations on the watcher side. So that said, this is still early. Our current priority is to ensure the existing Vite ecosystem can smoothly start benefiting from our work on Rolldown and Oxc. And this process is going to take some time. We'll be working on this future version of Vite in parallel, and we hope to also be able to show you a more stable version of it later next year. Well, that's it. I hope this gets you excited about the future of Vite and JavaScript. We wouldn't have had the courage to take on this challenge without the trust and support from the Vite community, and we hope this work will make us all more productive and result in more great apps being built faster. Thank you.
Hello everyone. Today I'm going to talk about the JavaScript oxidation compiler, Rolldown, and the future of Vite. In this talk, I'll introduce you the Oxc project, a little bit of Oxc's performance, an introduction to the Rolldown bundler, and finally our roadmap. To start things off, my name is Boshen. For the last decade, my job has been a front-end configuration engineer. I configure things like Grunt, Gulp, and Webpack. I also worked at startups and large companies that have super large monorepos and web apps. As part of my interest in experimenting with new programming languages, I started working closely with JavaScript tools written in Rust. They are Rolldown, ISPack, Biome, SWC, and NaPRS. In the meantime, I initiated the Oxc project and also became the member of the Rolldown project. Here's an overview of the Oxc project. We are ambitious to build a fully integrated JavaScript toolchain. There are binary applications, NPM packages, and Rust crates. It is a collection of JavaScript tools written in Rust. We have completed the parser, which is currently 3 times faster than SWC, and it passed all test262 stage 4 tests and the regular expressions, and also Babel and TypeScript, most of the Babel and TypeScript tests. We have a linter, which is 50 to 100 times faster than ESLint and has more than 400 rules from popular ESLint plugins. We have a module resolution resolver, which is 28 times faster than Webpack's enhanced resolve. Currently, we are working on the transformer, which is going to be Babel compatible, and at present, TypeScript and React.js transforms are complete, and we also implemented the latest TypeScript isolated declarations DTS emit. In the future, we are going to work on the formatter, which is going to be prettier compatible, and also a minifier that is going to be faster and better at compression size. Oxc also supports the upcoming Rising Stars projects such as Rolldown and the Nova JavaScript engine. So how did it all get started? It started as a learning project for Rust, writing a parser, and also performance engineering. I wrote a JavaScript and TypeScript parser from scratch, began more than 2 years ago. And once that was completed, I started writing a linter as an experiment, and I just kept going. Eventually, I released a tool called OXLint. It is designed to catch erroneous or useless code without requiring any configurations by default. It is 50 to 100 times faster than ESLint and scales with the number of CPU cores. There are over 400 rules with growing lists from popular ESLint plugins. It supports ESLint ignore, ESLint comment space disabling, and partial ESLint RZ JSON support. You can already try it in your own project by calling npx oxlint. At my previous job, I had to work with super large code bases, and I often find the tools written in JavaScript to be struggling with such enormous amount of time. So I stress test OXLint in one of the largest monorepos in our company, which hosts all of TikTok's code for the web. It completed 120K files in 3.4 seconds. Once OXLint was released, Jason Miller from Shopify tried OXLint in one of their large monorepos, and here's what he said. OXLint has been a massive win for us at Shopify. Our previous linting setup took 75 minutes to run, so we were fanning it out across 40 past workers in CI. By comparison, OXLint takes around 10 seconds to lint the same codebase on a single worker, and the output is easier to interpret. We even caught a few bugs that were hidden or skipped by our old setup when we migrated, and we probably have saved millions of dollars on infrastructure. In the meantime, Evan Yu showed interest after I tweeted a lot about Oxc and OXLint. He was amazed by OXLint performance when he ran in the Vue 3 repo. And eventually, we got talking to each other, and one thing led to another. It was evident that a new bundler is needed for Vite. So Rolldown was an experiment project by the author of NAPIS and a few friends. It got later picked up by Evan, and all the stakeholders got started talking to each other. It was eventually decided that Rolldown and Oxc is going to be the future of bundler for Vite. It aims to remove the DevPro consistent issue. It has a Rust core but allows JavaScript plugins. It aims to align with Rollup's API as much as possible, and it is going to have a lot of performance budget for new features. So why was Oxc picked for Rolldown? It boils down to 3 key factors: performance, correctness, and simplicity. For runtime performance, Oxc, the whole project takes performance very seriously. We think of it as as a budget for buying more features down the road and for our downstream tools. It uses continuous benchmarking methodology with code speed. And at the time, Rolldown was using SWC and then started experimenting with Oxc as well. Once switched, the parser and transformer made Rolldown faster, and it was 3 times faster than SWC. Because there is a AST allocated in a memory allocator in Oxc. It consumes lower memory and is faster at dropping memory. And not just runtime, for compilation speed, we know that Rust is notorious about its compilation speed, and Oxc tries to minimize it. Rolldown's DX improved when they switched from SWC, so the save compile cycle increased by a lot. CI ran faster, and this is proved by Oxc CI, which runs under 3 minutes. For correctness and reliability, we have layers of test infrastructure. We have conformance suite on test262, Babel, and TypeScript. We have lots of fuzzing, and there are people who fuzzes our projects and creates issues in our projects to this day. We have linter snapshot diagnostics for checking the correctness of our diagnostics. We have OXLint ecosystem CI, where we gather a lot of projects that use OXLint to check regressions. We have idempotency testing, and we have a lot of code coverage. And we also have a end-to-end test where we use the top 3,000 NPM packages and test various things. And you can read more about our correctness and reliability approaches on our website. So now here's a quick Rolldown demo. In the previous setup, I said the end-to-end setup, there's a repo called monitor Oxc. There are 3,000 most popular NPM packages from NPM high impact. So download counts of 1 million or more per week, and dependent on by 500 or more other packages. And with Rolldown, it's a really simple config, and with just an input and the platform configuration. So when I imported all 3,000 packages statically into a single file, so there's a single file chunk with lots of code, it processed 46K files and generated 809 files with a 200 megabyte entry file. And the maximum memory usage was just only 7 megabytes. And the runtime completed in 3.26 seconds on my Mac M3. And to test chunking, I also imported 3,000 packages dynamically, and so it creates 3,000 chunks, processed 46K files, and generated almost 66K files together. And the memory consumption and runtime speed are the same. And here's a quick run in our setup. It only took like 3 seconds. Here's we can watch it again. So all node run, Rolldown, and then 3,000 packages were completed in less than 3 seconds. So for the future, for the past and future roadmap, Rolldown's basic bundling is done, and code splitting is done. CJS ESM interrupt is finished, and basic bundling support are all complete. For milestone 2, tree shaking, CLI, source map, chunk hashing, advanced chunk splitting are all done, and rollup plugin compatibility are at 90%. There are only many edge cases that haven't been implemented yet. For Oxc, we finished TypeScript and JSX transform, and we are currently working on syntax lowering to ES6, and a built-in modification should be done with a prototype by the end of the year. And by the end of the year, we also seek for deeper Vite integration, where running all starter templates are already finished. And Vite and will try Rolldown as a dependency and try to pass all ecosystem CIs. And possibly we are going to try and have a full bundle mode as well. To learn more, you can visit oxc.rs and rolldown.rs. We appreciate any kind of contribution. Thank you.
Hello ViteConf. We're going to talk about Environment API and how we intend to make Vite even more flexible. I'm Matías Capelletto, also known as Patak. I'm part of the Vite core team and I work at the StackBridge, where I focus on the Vite ecosystem. And he is Zorro, one of our 3 cats. It is incredible that we are already on the 3rd edition of ViteConf. Evan paired Rolldown with ESBuild to create an amazing piece of shared infrastructure. And that was just the start. Vitest, Volar, Nitro, the whole Node.js umbrella. Now the meta frameworks have like a whole toolkit to build themselves. In the first edition of ViteConf 2 years ago, most of the meta frameworks that choose Vite and were working together were in their beta stage. Even Storybook was just showing how it could run without Webpack. In the second version of ViteConf, we welcome to the stage Angular and Redwood. And Evan, you mentioned that Remix was joining the ecosystem too. And not only did it join, like we are going to see a talk from Pedro and Mark this year, but also Tanestack Start, Waku, even Ember and Meteor join. And we just keep expanding and improving our shared commons. And now with Rolldown and Oxc, Vite is also going to reinvent itself from the inside and get native speed where it really matters. And I want to congratulate Evan and the whole team behind Voice Zero. It is just incredible now to count with so many amazing developers working on our shared tooling. And I think more than ever, we are now ready to cope with the ecosystem growth. And it will keep growing. The story that we're going to see today about Environment API is also a story of collaboration between a lot of these different teams. And you can see that collaboration in the Vite core repo. Like we crossed 1K contributors. That is incredible. And we also passed 15 million npm weekly downloads. And this is just an aggregation of all our projects doing better together. So how we got here? We got the right design, an ESM-based bundle-less dev server with the speed of ESBuild where it matters and the flexibility and maturity of Rollup during build. And it was at the right time. A new generation of Frontend tooling was serving an explosion in meta framework exploration. And the ecosystem really needed a new shared layer. And there were 2 very key features that I think helping Vite spread. One was using the Rollup plugin API for a powerful abstraction that worked in build and dev. And the other one was an idea from the Svelte team that Evan adapted into Vite that was the unbundled SSR dev shim. We got in our hooks, you could get the SSR boolean and decide to do a different transformation or resolving in SSR compared to the client. And using the built-in SSR low module, you could get HMR-like caching of the modules imported for your server. And just with a few lines of code, you could create a middleware to serve your SSR during dev. For building an SSR app for production, Vite has to do 2 steps. Like you first Vite build the client, and then Vite build SSR to get the server. And using the SSR manifest flag, you could have information communicated between the client and the separate SSR build. The Svelte team and others using the framework as a plugin strategy, so using Vite as their CLI, have long requested a build app command that with a single command you could build both things. We in the Vite team always recommended users to create their own CLIs for these cases, but this idea of using the Vite CLI really resonated with a lot of frameworks, like Remix also tried to do the same. And they actually, how they managed to do it is that in the client build, in the right bundle hook, that is the last hook, they will hook up their SSR build. So they start with a single Vite build command, they go their way. But it was not a first-class citizen. The story continues with the Nuxt-Dev SSR. Nuxt 3 is powered by Nitro, a toolkit to create web servers and deploy them everywhere. And they created with Node to improve Nuxt-Dev SSR, using transform request, like lower level primitive compared to SSR load module, and a Node VM-based module runner. And they got HMR and source map support in SSR dev environments, and also allows them to run the code in another thread or process, not in the same process where Vite was transforming the modules. This was created by Anthony Fu based on an idea from Puya Parsa. And Vite Node later on went to power Vitest. And from then on, it moved to the Vitest monorepo and was maintained by Anthony Fu and Vladimir. And it powers many other projects in the ecosystem. So at the beginning of last year, we started exploring moving Vite Node into Vite Core. The idea was to have SSR load module equivalent with proper HMR support. And also the module runners, a couple from the Vite server, could give us a lot of extra flexibility. So a revamped Vite Node version was upstream as Vite Runtime API in Vite 5.1. We got very interesting feedback from Cloudflare, Remix, Hydrogen actually used it in production. So shout out to Vladimir for this work. But we could make Vite even more flexible. After receiving this feedback, we started to see that we could use these APIs to actually remove difference between dev and build. First, modern apps are starting to use more environments, client, Node, Edge at the same time. And they also will like to integrate during dev with their local tooling, for example, Miniflare for Workerd. There were other applications like Nuxt and Vinci apps that also started to use several Vite dev servers to cope with the lack of flexibility of a single one. And there was also limitation with this API, the runtime API, after the positive feedback that we received. First, the runtime API was added as an extension and was not deeply integrated with the rest of the APIs. And the Vite dev server had a single module graph during dev with mixed modules for both client and SSR environment. We had props like transform result and SSR transform results, client imported modules and SSR imported modules. And this was making it challenge to support proper HMR. And also, how do we configure different environments? For example, like if we want to set result conditions for different, or how we add more environments than just client and SSR. So the first thing that we did is to get back to an idea that we had long ago about we need to separate the module graphs. Instead of having client and SSR mix, we want to have the client module graph, the SSR module graph separated. And if we have that, then we could have more module graph, different environments. And this is where we went back to the drawing board. And at the beginning of this year, we said, okay, what if we could actually redesign the API that we have? Instead of having just an SSR Boolean, starting to have a proper environment abstraction during dev. We could share in the single Vite dev server, keep the HTTP server on middlewares and the plugins pipeline that will be shared by all environments, but then we will let users create different environments for browser, for Node, for Workerd, and each of these environments could be connected to a module runner that is sometimes is in the browser, sometimes it could be in the same process, for example, like our typical Node SSR environment, but it could also be run outside in another process, for example, in Miniflare. So this is how we got to Environment API. The benefits of Vite Node Runtime API, but with the ability of create as many environments as a framework needs, with a way to configure them declaratively in a single config, having per environment module graph and plugins, and a consistent API to further align between build and dev. Also, the idea that we can build the entire app with a single build command and make framework as a plugin first-class citizen in Vite. So how do you configure an environment? Before, when we had only client and SSR, we had the root configure, for example, here result conditions that will configure the browser. And if you wanted to have something different for SSR, you need to directly say SSR with this fixed option. Now we're going to have an environments option that directly will declare all the environments that the app will use. Client and SSR are there by default, but you can explicitly configure them separately now. If you add something at the root level, it will apply to all environments. And we can define a new edge environment, for example, with a different result conditions. And environment provider like Workerd could expose in a library a function to directly configure everything that that particular environment needs. So getting back to our example with passing the SSR Boolean to plugin hooks, you can see that before we need to pass the SSR Boolean to functions like getModule by URL from the module graph. This was error prone as the SSR was optional there. And also, if you wanted to access the configuration, you needed to branch. If it is SSR, you need to access it through a particular path. And if not, you need to access through directly config result conditions in this case. And now with environments, we can have the current environment that for that plugin hook directly in the context. So you can access this.environment module graph get module by URL, and you don't need to care about the SSR Boolean flag. And also for access configuration, there is no branch needed. You can directly say this.environment config .result condition, and that will be the result condition of the current environment. We also want to allow, as we say, building all the environments in a single command. So we have this Vite build app to build the entire app. And we also have a new abstraction, a Vite builder that is equivalent to the Vite server. So in the config, if you say builder build app, you're going to get a builder where you have all the environments, and this will take over the normal process that Vite uses. And you can actually say, for example, yes, I want to first build the client, and then when that is done, I will build the SSR and RSC in this particular framework together in parallel. And in the middle, you can also do other kind of things in the same process. So if you see how the Vite server and the different environments like APIs are changing, you will see that before we had a lot of things exposed from the Vite dev server, and this needed you needed to pass the SSR Boolean everywhere. Or if you access in a single module, for example, you will say like module.ssr imported modules. Now with Environment API, some things remain in the same like HTTP, .server.http, .middlewares. These will stay in the same way as before. This is shared for all environments. But then we are moving transform request from the server plus the SSR Boolean to the current environment. Also the same with the plugin containers, or if you access a module, you are directly going to say module.transform, module.imported modules, because that module is only for one particular environment. And the same thing that we saw before with environment.config, instead of having, as before, having to access through a particular path for SSR or for the client. So getting back to our typical SSR setup, we have an Express app and a Vite dev server in middleware mode, and we connected all the middlewares from Vite to the Express app, and we have the typical middleware from our documentation where we grab our raw template, we use transform index HTML to have the HTML template, and we're going to use the Vite dev server SSR load module with the entry point of the server, and this will give us HMR-like caching of all the imported modules. And using the render function, we can render a particular root, the component for that root, in a string and inject it in the template. And if we see how this will change with dev environment and module runner, first we need to see that even if it's not explicit, we have here a default client environment and an SSR environment. And the SSR environment will have a default runnable dev environment, how it's called, that already creates a module runner in the same process. This is how SSR load module always work it. So if we actually explicitly define a new environment, let's say the client is already there, but we have a new one called server, in this case, that is distinct from the SSR one, we can get the same that we had before using the server, the environment server.import with the entry point of the server. And the difference now is that instead of like just HMR like caching, we are going to have full HMR. We can use import meta hot and all the APIs that we know. And this is, again, the default way to create an environment. When you don't specify this create environment, it lets you modify the environment instance. And the default one is using create runnable dev environment. All these APIs are still in flux. So came discussed with us. And so if you check, you can actually define other kind of environments. Let's say that your environment provider can give you a create edge dev environment that will later on need to be paired with a module runner. This time the module runner in a different process or like thread. And there are some APIs that we are still discussing with the ecosystem, but it's probably the environment will have some kind of way to dispatch a fetch, and then we can do SSR in a standard way across environments. And this could sound a little bit complex, but first of all, this is going to affect mainly framework and environment provider authors. So it's not something that final users will need to worry about. What we get with these new APIs is that now the Vite dev server can be running in Node, but then the module runner can be created in another process or thread. For example, let's say that we create it inside of Miniflare, so we emulate workerd during dev, and this runner import is going to directly run inside Miniflare, and all your application code that normally will run during already in production in workerd is a lot closer now, because it's not running in Node and then connecting to Miniflare from some APIs. It's all running inside of Miniflare here. Let's check a quick example. This is from Hiroshi, that he gave us tons of feedback, so thanks a lot to him. And this is doing SSR on the edge, running in Miniflare. So we have here our environments. There is going to be a client environment and a workerd environment, and we are going to configure it using a plugin in this particular case that he created. We are still working with frameworks and environment providers to see what is the right abstraction here. And yeah, this is going to set up the module runner inside Miniflare, and is going to connect it to our Vite dev server. And if you check, for example, you have here builder, build app, and it first building the client and then building the workerd server. If you see in entry server, we have the code that we checked before. So here we are going to do a render to a string from ragdom server to get the SSR HTML, and that we are going to inject it and do the response in our template and answer. And if let's go to here and then do a pm run build of app, and then we are going to see that not only the client was built, but also the SSR in the same process. And we have our dev server already started. So if we go here, we can see that it has already been iterated. We can play with the counter. This is a diagram from Igor, so thanks to him. The dev server, the dev browser is doing a request to the Vite dev server, and not only the Vite dev server, and in this process we were transforming code, but also before in Vite 5, the SSR code that was rendering was also rendering in Node. And with a platform proxy that was created by Cloudflare, you could communicate and use different services inside Miniflare. But your application code was running in a different environment. And the idea is that in Vite 6, we could move that application code that was doing SSR, that server, we could move it to run directly inside Miniflare during dev. And the code will still be transformed in Node by the Vite dev server, but now your application code is running in the correct place. And if we see the Vite plugin inspect, this is an alpha version of it that already supports environment API, so make sure to install that one. And you can see that now we have this client environment here, and this is like our entry client that has like the page and some styles. And you have also the workerd model graph. And now this workerd, it is a different model graph. These model graphs are separate now. So let's look at some use cases. As we said before, one of the main drivers is to make the code that we have in production be as close as possible to our dev story. So we expect that not only for Cloudflare, but for other environment providers, this is going to be important. Mainly using Cloudflare here as an example, because we got a lot of involvement for them and really great feedback, so shout out to them. We could explore also going back to a single dev server in some of the cases that currently require several. React Server Components is a good example, and Vinci apps that also use different Vite servers for each router. And yeah, like shout out to Vinci first, that is powering now Solid Start and TanStack Start. And yeah, maybe the environment API could help like simplify some of the things that at the same time were inspired by the needs Vinci have. And also maybe framework like Nux could explore in the faraway future, also going back to a single dev server. There could be also interesting use cases for React Native, and maybe the ability to have more flexibility in how environments are configured could help there. And in the same line, we always said that Vite was browser only. Still, Tori and Electron, they all had plugins to make it work, but maybe we can help with that cases and make this more as a first class citizen. And also isolated web apps are a good example, or web extension. Maybe we can have these libraries that provide these environments to simplify their use. Vitest is another interesting use case, because what came from Vitest as Vite Node to runtime API to environment API, and now like dev environment module runner could get back and simplify the implementation of Vitest later on, making it more maintainable, and we will see if a little bit faster too. So we are very excited about what the ecosystem is going to build on top of Environment API. And yeah, it's going to be experimental at first. It's going to be released in Vite 6, but you can already try it in the beta. And we really need more feedback and experimentation. So check out for, if you are a plugin, a framework, or a tool author, check out if this API is flexible enough for your use cases. Create new environments, and please check backward compatibility issues. Like Vite 6 is going to be backward compatible with Vite 5. Even the module graph, for example, the mixed module graph is still there with the same API. So the idea for now is that we want people to move from Vite 5 to Vite 6 without any problems, while we keep iterating a little bit more, so we get more feedback and we get this that is going to be one of the biggest API changes in Vite history. Like, we have to get it right together. So you have a pinned discussion in our GitHub repo, or you can use the contribute channel. And yeah, we wait for your feedback. Thanks a lot, ViteConf, and thanks again to every speaker, all the community, to Established and the community partners to make it possible. Again, it is amazing that we are in the third ViteConf. Enjoy the rest of the talks.
Hello everyone, good to see you again. I hope you're enjoying the conference so far. First, let me introduce myself. My name is Anthony Fu, and hi. You will see some cute illustration like this avatar drawn by my girlfriend Ines, so thanks to her. So, my name is Anthony Fu, and I'm a core team member of Vite, Vue, and Oxc, and also the creator of Vitest, Slide Div, Uno CSS, and so on. I'm also the maintainer of ESLint Stylistic, Shiki 2/. I'm currently working at Oxc Lab on the framework team, so you can find me with the links below. So, as you might know some facts about me, I'm really appreciate the chance that I got to allow me to work on open source full time, especially around this great community around Vite ecosystem. Thank you for everyone that's give the support and opportunity to make this possible to me. I believe that many of you like me are interested in doing open source. So following the topic I gave on last year's ViteConf, today I would like to continue sharing my thoughts and experience as I got around doing open source. So this will be the part 2 of this series. I call it the progressive path. So for the other parts, the first one is called the set theory that I gave the last year. And also I got a third one recently on some other conferences called Yak Shaving. The topics are not interconnect with each other, but if you're interested, you can find the slides and the recordings on my website. Or maybe I will do them again in some future conference that I might meet you in person also. So first, before we dive into today's topic, let's discuss a bit about what we expect when working in open source. We know that most of the open source projects we use daily are tools, but have you ever think about the question that what defines a tool? The definition can be pretty straightforward, and maybe you already have the answer in your mind. In my interpretations, a tool should help you to get things done faster or easier, at least one of them. I guess no one wants to use a tool that makes things slower or more complicated, right? So, assume we want to build an open source project, a tool for people to use. what would you consider to justify if the tool you're going to build is a good one or not? Well, my answer is no. You couldn't really tell without being verified by the community. Because there are so many factors that can affect if an open source project would work out or not. But also, I want to emphasize that in this context, good is a relative term, depends on your expectation. It's totally okay to build a tool that solves your own problem and call it a day. It's a great tool that's worked for you anyway. Actually, I have plenty of such tools and I'm happy about them, even no one else is using them. But at the end of the day, I got my job done, right? So let's revise our goal. Let's say we want to build a tool that can be benefit to not only ourselves, but also more people. And probably the community could also help us to make the tools better for everyone. So the question becomes, how can we make a tool that's general and useful for people to use? I'd say every decision comes with a trade-off. And when users consider if they want to use a tool, they would justify the cost and the benefit they can get from it. So here we have a balance. And if I'm going to put two most important factors on the balance, I would pick the cost of learning and using the tools versus the cost of doing something oneself. In order to make users willing to use our tool, I'd say the cost of learning should be much less than the cost of doing. This has been my little go-to formula to pre-evaluate if an idea is worthwhile. For example, let's say we want to get a summary of 10 numbers. Would you looking for a library to that? Maybe not, because we could do it with a single loop of 2 lines of code. The cost of doing ourselves is too low that we don't even consider to looking for a tool. But if we're going to do some like a calculus, I'm certainly going to find a library to do that for me because I basically forgot everything I learned in my college. So, however, on the other hand, if the library we pick requires us to understand like 100 different configurations before able to use them, we're probably going to find another library that might be easier for us. Thus, we know when we are making tools, we have to think about those cases and find a good balance to make a tool worthwhile. So we know that we should probably reduce the cost of using a tool to make it easier for people to pick up. And from my point of view, the cost of a tool is composed by the following factors. The first one is the cost of discovering. It's about how common people would realize they need a tool for certain tasks. And it means a tool should be well described so that people can easily get what the tool is for with 1 or 2 sentences. And then we have the cost of learning. This is a particularly important one in my opinion. It's about how easy people can understand and get started with the tool. As a tool is supposed to be used and make the actual work easier, we certainly don't want users to struggle on learning it too long before they can be benefit from it. And then we have the price, the cost of the tool itself. We're lucky that in open source, the majority of tools are free to use, thanks to every maintainers and contributors behind the scene, and make it so much awesome tools that everyone can use. And of course, on the other hand, if the tool is not free, it's definitely one of the factors that the user would consider on choosing. And then the last one is the cost of adoption, like how to install and integrate into one project, and how extensible the tool is to potential for future needs, and how the migration would cost, etc. And all these factors are introduced because of the use of an external tool. In the end, we want to see the cost of the tools being paid off by the benefit it provides. We know that the complexity of things might transfer from one to the others, but not going to magically disappear. If we're going to solve a complex problem, it'll be honestly hard to prevent the tools from getting complex too. For that, I learned that from the popular open source tool out is something called progressive. So after this long intro, finally we are back to our topic today. What is progressive? I think progressive itself is pretty self-explaining, but let's take a quick example with illustrations. So this is me, and I'm trying to get from the first flow to the second, but unfortunately I hit a wall. The only way to get there is to jump through the wall. However, I couldn't jump that high. In this case, I might end giving up and turning back around. It's such a shame because I failed to accomplish what I'm aiming for just because it's too hard. So, from a progressive perspective, I think that's why stairs has been invented. It allows me to take multiple smaller steps to going upward and eventually achieve a certain goal that I'm not being able to do without it. So here, my interpretations to progressive is the stairs to make things easier to approach. Let's take some real-world example of how progressive would work in our daily tools. If you go to the official Vue documentation, vue.js.org, you will see the headline describe itself as the progressive JavaScript framework. Inside the docs, there is a statement mentioned that Vue is a framework that can grow with you and adapt with your needs. I have heard people saying that one of the main selling points of Vue is that Vue is very easy to learn and get started. And more than that, I also see Vue is awesome because it can be used basically everywhere thanks to its progressive approach it takes. Vue is progressive on integrations. Vue provides multiple builds and offers many ways to use in different scenarios. Like you can use Vue in a single line of CDN import and enhance the web application even in static HTML without any build tool. You can also use Vue components as web components so that you can coexist with the other framework. Vice versa, you can also import web components within Vue applications. And when we have the build tool set up, we can build Vue application with Vue single file components that co-locate necessary context inside a single file to build an interactive single page application with ease. With tools like VitePress, it allows you to have an efficient static site generation that ships minimum JavaScript and while retains a great developer experience. With tools like Nuxt, we can do server-side rendering with Vue to maximize the end user experience as well as the better SEO result. And then we have the upcoming Vapor mode, which allows components to opt in more performance Vino-less render engine to optimize even further for performance critical scenarios. Vue's approach provides the progressive on the level of integrations, allows it to cover the needs for different scenarios or even coexist with the other technologies. This means even you have a large code base, use the other stack, but want to use Vue, you can still adopt some part of your app to use the Vue first and gradually migrate each part slowly. In the end, the goal is to make our tools easy to adopt for different levels of needs so we can serve a wider range of users. And then let's talk about Nuxt. If you go to nuxt.com, you will see it's titled as the Intuitive Vue Framework. As in the docs, it mentions Nuxt's goal is to make web development intuitive and performant with a great developer experience. And that's bringing us to the next session, progressive on onboarding. If you have ever tried Nuxt starter templates, you'll find it surprisingly easy to start with a Nuxt app. And all you'll need is to have a Nuxt installed as your dev dependencies and create a simple Vue components at app.vue. And that's it. That's all you'll need to get started with Nuxt. Even to someone who never tried Vue or Nuxt, it's probably not too hard to tell what it will render or how to modify it towards your need, as long as they got the basic idea of what is HTML. I think Nuxt intuitive here means that you can get started with a very minimal knowledge. And also, it could be fairly easy to enable more features as needed. So that brings us to progressive on features. We know that Nuxt works with the bare minimum starters, but also we know that a real-world application won't be that simple. We need a lot of capability to accomplish various needs and also a way for us to organize the code base in a manageable way. So Nuxt is a framework that can grow with your needs. To say, if you want to have some components to separate you and reuse the logic, Nuxt, you can create components folders under the components directory, and it will be auto-discovered across your project. And then if your app needs the capability to serve multiple pages to do the navigation, you can create a pages directory. The components under it will be registered automatically based on their file name. One of the great part is like, until you do this, view routers and the related codes are never shipped to a production before you're actually using them. Say our app now is ready to go. We want to deploy it to the site to somewhere. There are quite many deploy platforms you can choose from, and usually you will need to learn a little bit more about like how to develop X frameworks on the Y platform, etc. But with Nuxt, they will just work with all major hosting service with zero config, thanks to the automatically deployed presets powered by Nitro. And it's common for a web app to have some server logic and API endpoint. In Nuxt, you can simply create function modules under server API directory, which will be very similar convention as pages for routing. Nitro will deploy them to a serverless function based on the hosting service, and we have end-to-end type safety on them. And talking about type safety, later if you learn TypeScript and you want to use it in Nuxt, no problem. You can directly use them already thanks to Vite and ESBuild. For the other features like progressive web apps, search engine optimization, internationalization, etc., Nuxt provides a rich module ecosystem that you can integrate them with a few clicks or one command. And finally, in case you are interested in more features in Nuxt provide, we also build Nuxt DevTools that you can inspect internals or analyze your app. All those features are opt-in, meaning that if you don't need a certain feature, you don't need to even learn it. And once you find it useful later, you can always grab it back easily. In short, the point here is that we should grow with the users and not putting too much things up front at once. Make learning easier to start with and expose new concepts and powers progressively along the way. And then it finally comes to Vite. Vite titled itself as the next generation front-end tooling, and I'm pretty sure no one would question that. In the Vite philosophy section, the docs mention that Vite works closely with the projects in the ecosystem to minimize the regressions on each release. And Vite is on major version 5 now, and during the past 4 years, we basically keep the pace of releasing one major version per year to keep up with the JavaScript ecosystem and the evolving standard. Some of you probably have been through that period when we do major releases, and the last one with Vite 5 was released under November last year. This is not a secret that Vite's major release has a very smooth migration path. We received many comments mentioned that about their successful migration cases. And people mentioned that their upgrade from V2 to V3 with only bumping the versions, everything keep working as is. And some even describe Vite as the most painful-less full version upgrade to a build system ever on the release of V5. And many more comments like that. Thank you, and we are very glad to hear those stories. And if you look into Vite plugins you are using, you will find that their package.json follow a pretty similar pattern like this. Vite appears in the peer dependencies with the version range from Vite 5 all the way down to Vite 2. This means that the plugins keep working from Vite 2 to 5 perfectly without the need to drop the support of previous Vite versions. Not mention there is 3 years of times in between, and for such tools like Vite. Vite team has put a lot of cares to make this possible, and we care a lot about every change we made, and even work out the idea of ecosystem CI that runs the test of the major downstream frameworks on each pull request to make sure that we have the minimal impact to the ecosystem. The practice has been later adopted to Vue, Nuxt, and many other frameworks. And that brings up the other aspect of progressive. Progressive on breaking changes. I guess probably no one likes breaking changes. But somehow breaking changes are quite important for the codebase to stay healthy and more maintainable in the long run. It helps us to fix the imperfectness of our previous design with a better context we have today. While it's hard to avoid introducing them, I believe there might be some way to make these transactions smoother and easier for users to adopt. Talking the experience we had in Vue and Vite, I see two major ways to achieve that. Here we bring back the graph that we had before, referring from jumped from major version 1 to 2. And one way to make breaking change progressively is to do forward compatibility, and then the other is backward compatibility. Let me explain. Forward compatibility is about to be compatible with the version in the future. Like to say, if you know there's a new feature you're going to do in the next breaking changes, you can bring the feature back to the current version in a non-breaking way. In practice, we often introduce a flag such as experimentals or futures for users to explicitly opt in those changes if they want to try new stuff, while the mainstream of the user will still on the main version without breakage. Then let's talk about backward compatibility, which you might heard more often. This is about to be compatible with the previous version. A common practice that's we will mark a certain feature as deprecated and then print a warning upon usage and eventually remove them later in the next major version or so. This also means that it's better to do smaller and a bit more frequent major release to make the migration easier. From my understanding, I think progressive or breaking changes are fundamentals allowing coexistence. When you make changes, we should provide the middle stage for people to take a rest on the migrations, allows coexist on both legacy and new, so that the work can be done progressively and they reduce the chance of breakage. Let's take some examples that's happening recently. First, let's check Nuxt 3 to Nuxt 4 migration plan that we have been working on in the recent months. In Nuxt, our philosophy is that we want to get cool, exciting new features to users' hands as soon as possible. So instead of holding features to a big major release, we ship new features monthly in every major versions. In this regard, means that for Nuxt 4, we have no plans for new features. But instead, that Nuxt 4 will be mainly focusing on revising some previous decisions and changing some defaults to make the better default and out-of-box experience. Since there's no features, users on Nuxt 3 today can opt in to the Nuxt 4 behaviors with a single flag if they want to move faster. And on the other hand, even when upgrading to Nuxt 4, user can still update the config to change back to the previous Nuxt 3 behavior if they prefer that, or want to do the migration progressively. With those, it makes Nuxt provide both forward and backward compatibility smoothly for users to migrate painlessly. And let's talk about Vite. I believe that many other talks today must mention a lot about the new upcoming environment API. I'm super excited about it as well. But on my side today, I want to talk about it from the other aspect, the Vite 6 upgrading and rolling plan. As you might know, to make environment API possible, we have done massive refactoring internally towards Vite codebase. For Vite 6.0, we expect there's no user-facing changes, no features, and no even breaking changes. Our goal is to make it fully compatible with V5, so that everybody can upgrade to Vite 6.0 smoothly without any changes, other than just bumping the version, following our great traditions. After everybody is on v 6.0, in 6.1, then we were starting to promoting the usage of environment API across the system, as everybody already have it on their hands. During the entire process, there will be no breaking changes for V core. However, some plugins or frameworks might have breaking changes if they are relying on v6 exclusive API. Only if the path to v6 is smooth as it's almost flat, the plugins author can confidently make plugins require v6. And that's what we are working hard to achieve. So, to recap today's topic, we have talked the progressiveness on different aspects of building a tool. The first is about progressive on onboarding. We should make our tools easy to learn and understand for more people to start benefit from the tools we build. And then we talked about the progressive on integrations for our tool to cover different scenarios and easier to adopt. And then we have progressive on features. It's pretty common that we want our tools to be very powerful, but that could also overwhelming the users to start with. So taking the progressive approach would allow us to start minimum and grow with the users. And finally, we have the progressive on breaking changes to provide middle stages for making migration easier step by step. There's many more aspects about progressiveness that we couldn't have time to talk about today, but my goal today is to bring up the idea of progressive paths to you. It might not seem to be very common or unusual stuff that people would get excited about, but I think this plays a very important role of our daily software development, and we should think more about it when we're building tools, not only for open source project, but probably could also for the products or the other stuff in general. To finish my talk with one sentence, I would say to provide the progressive path is to enable users the capability of divide and conquer towards the goal they have. That's all for my talk. Thank you, and please enjoy the rest of the conference.
Hello, I'm Lucas Taggart-Atkinson, maintainer of Rollup.js. Today I want to give you a brief overview over the major new features released at Rollup in the last year and what we're working on at the moment. First, of course, I want to tell you about the state of the Rust migration. So last year we started introducing a small core of native code that was designed to replace the parsing API and eventually replace more parts of Rollup to finally make it faster. So what did we achieve so far? 20% faster bundling speed without plugins, that is to say, which I think is significant. This is not lightning fast, but it's a little faster, and 5% reduced memory consumption. But of course, we do not want to stop here, so the biggest improvements are definitely yet to come. So what are the next steps here? So first, we want to move the cache to binary format. This will come very soon. If you're wondering, Rollup does have a cache. It's just not active by default. You have to use it via a Rollup configuration. We also want to improve that. So moving the cache to a binary format will allow Rollup to completely skip the parsing step because in the future we can basically just operate on the binary format. Then second, and this is really interesting, we're introducing a new parsing API for plugins, or more specifically, a parsing and syntax tree walking API, because those two actually need to go together. A plugin usually doesn't want to look at the entire syntax tree of a file. The plugin may be interested just in function declarations or in imports. So the new API that we are currently finalizing will allow a plugin to specify specifically which nodes they're interested in. And then the parsing will happen asynchronously in another thread. And then the syntax tree nodes are actually generated lazily as the plugin accesses them. So they will still be able to start walking from a function declaration down to the children, but to speed things up and basically make this really instantaneous, the actual JavaScript objects will only be generated as they're accessed. So keep your eyes peeled for this one. There has already been interest from the Dino people in this API, so let's see if we can get some cooperation going here eventually. And the last thing that we really want to do is migrate the tree shaking. The tree shaking process, the single slowest step we still have in our pipeline, but it's also really complicated to migrate. We have plans for many of the problems we are facing, but expect this to take at least a year until it will be done, but the impact will definitely be massive. So that being said, let's talk about tree shaking. So there have actually been some interesting tree shaking improvements in the last year. Specifically this one, Rollup is now tracking function arguments. So let's assume we have, for instance, this function. It's a function that basically fetches from a target, but it also logs if a certain config value is passed. So in the past, basically this would just be bundled as it was. But as you can see, we are calling the function exactly once and we're saying don't log. So starting with Rollup 4.16, Rollup will know that and it will just optimize the if statement away. And as you can see, it also optimizes the parameter away. So this was for functions that are only called once. If you're calling a function multiple times, then like this, then it cannot be optimized. Why? Because here in this example, we basically would have needed an algorithm that really compares two totally unrelated objects, and this can potentially be expensive. However, if you do it slightly differently, like extract a variable, then Rollup will again see this is the same variable, and it will again optimize. And last, it will also optimize a function call if we are using primitive values. So I think this is a really big improvement. This is already live for some time, and it was based on an external contribution. Thank you very much. The second thing that is not live yet, but it's in the final stages of preparation, is improved tree shaking for dynamic imports. So we already had tree shaking for dynamic imports, but for instance, look at this example. We are dynamically importing module, and then later we are only ever accessing the foo export and not the bar export. Currently, Rollup cannot optimize this, but with the new improvements coming, Rollup will see that the bar property is never accessed, and then it can be optimized away. But you may ask, okay, if I really can track property accesses, can't I do even more cool stuff with this? And yes, of course you can. So this will not be the only feature coming. What will also come is that, for instance, this function is called with an object, but it only ever looks at one of the properties. And Rollup will then be able to see that. And as you can see here, the other property is just optimized away. I call this tree shaking for object properties. We are still making this sound and see that basically we catch every edge case, but I'm pretty confident that this will be finally released sometime this year. Again, also thanks to a contribution that was not from me, but from Chicky Pie, who is also now maintainer and doing a lot of great work at Rollup. And last, I want to talk about new syntax we support. So first, Rollup supports now explicit resource management. So this is basically the using keyword. This is just syntax support. We are not transpiling this. But if, for instance, you're writing a plugin and using Rollup to bundle this, this may be interesting. Of course, with full tree shaking support and side effect detection, at least to a certain degree. So I think we shouldn't mess up here. The second feature is decorators. So for instance, in this example, we're using a decorator to replace a function with another version of the function that logs when the promise returns. Again, this is only syntax support, no transpilation. But there is something really interesting that I actually want to talk about, and this is JSX support. So imagine you have this React component, so kind of hello world component. What Rollup will be able to do, which is also in the stages of finalization, is that you have a new property JSX and it has a mode property. If you set the mode to classic, it will do a classic React transformation, meaning it will replace it with a React create element call like this. Also, you have the automatic mode, which supports the new React transform, which is supposed to be faster, using a JSX or JSXS function, moving the children into a separate property and extracting the key property. But, and this is the most important one and the most I'm most proud about, this one, which looks like nothing is happening. But of course, this is not the case. So what this allows you is basically to bundle JSX to other JSX using tree shaking to remove unused components, as well as deconflicting. So if component names are conflicting, then the names will basically receive suffixes, so no conflict appears. This is really interesting for bundling libraries. And there is actually a reason. You might wonder, Rollup didn't support non-JavaScript syntax in the past. What has changed? First of all, this use case is important in the wild. People are using Acon plugins for this and special plugins to fake the tree shaking, but they have the edge cases that do not work well. The second is that it's no longer possible now to do the syntax extension via plugins. So we are basically breaking this use case for libraries. This was the main motivating factor, but of course there are also some upsides to supporting JSX natively. And one thing is it is already supported by the parser, so we only need to think about the transpilation and the deconflicting and tree shaking logic. And secondly, it will be a big performance improvement over using a plugin to do that. Now, if we're starting with JSX, are we going to stop here? Maybe, but actually we could also go this step. So I don't want to make any promises here, but there is already a branch where I started looking at supporting TypeScript natively. This is also a big thing that can take a year. So no promises on any timeline here. But if we manage to pull this off, it will make using TypeScript and Rollup so much faster and so much smoother. So let's see where we're going. And that was all I wanted to tell you today. Thank you for tuning in and have a great ViteConf.
Hello, ViteConf. I'm excited to be here for the third year of ViteConf. Time flies. I can't believe it's already been 3 years. And you know why we started ViteConf back 3 years ago, and we became the biggest backer financially of Vite 3 years ago. It's just still as true today as it was then. This is a tool, a technology, and more importantly, a community that is building the future. And it's really validating to see Vite being used by over 15 million downloads a month. By some of the world's largest companies. And it's actually expanded beyond just being, the most popular web development tool in the world. It's become the epicenter of how the world is writing software. And right now in the world, there is a huge revolution happening with how software is being written. And that's due to AI. AI has gotten extremely good at writing code over the past couple of months especially. And because of the way that Vite was designed from the get-go as an open source project that can run any type of tool chain that you can configure in any way you want, not some proprietary lockdown thing that's hard to use, these LLMs being produced can write amazing Vite applications. And not only that, the frontier models, the companies making these things themselves are adopting Vite to build their AI applications. Most recently, OpenAI switched from Next.js to Remix, a Vite-powered React framework for ChatGPT.com. And this is just the beginning of what's happening. And today, I'm really excited because we have a really cool update that we're working on for the past couple of months. And it blends the cutting edge of what frontier models in AI are capable of with all of the work that the Vite ecosystem has been doing and with StackBlitz, bringing dev environments into the browser. And before we show you what we've been working on, I actually wanted to invite one of the Frontier AI labs to come and give a quick update on what they've been working on, because that's a really key part of what we're going to show you how it works. And that company is Anthropic. And I'm really excited to welcome Alex Albert here, head of DevRel over at Anthropic, to give us a quick update on what Anthropic has been building and what we can expect next. And then right after that, we'll show you what we've been working on that blends Vite, StackBlitz, and AI in a way that wasn't possible before. So without further ado, Alex Albert.
Hey, I'm Alex Albert. I lead developer relations at Anthropic. Today, I wanted to give a broad overview of Anthropic and Claude and share a few resources to help you get started with building. Anthropic was founded in 2021 by a group of AI researchers. We started with this mission at our core that generative AI is going to be transformative, and we want to ensure that this transition to transformative AI helps people in society flourish. We do this in a few ways. First, we build frontier systems like Claude, our language model. Second, we work responsibly with third parties and ourselves to deploy these systems out into the world. Third, we invest a lot of resources into studying the behaviors of these models and these systems through areas of research like interpretability and alignment. And finally, fourth, we believe that it's important to regularly share our research and our updates with the community in the world at large. And over the course of the past year, we've actually built the best LLM twice. As you can see on this chart, the first time was back in March when we released the Claude 3 family of models. And then most recently in June, when we released our first model in the new Claude 3.5 family, Claude 3.5 Sonnet. You can use and talk to Claude models today at Claude.ai. As you can see here, it's a chat interface This is what it looks like. So you just type into this text box, you hit enter, and you'll get a response from Claude. You can use Claude for a variety of tasks, and in some ways, it's really only limited by the extent of your imagination. This includes things like advanced code generation, so writing and executing code, updating legacy code bases, or performing migrations. Or you can take advantage of Claude's multimodal abilities and ask questions about charts and graphs, or about patterns and image recognition. Or you can even utilize Claude's more advanced reasoning for tasks like answering questions and providing detailed multi-step solutions to problems. With Claude, you can transform your work and your org. We offer 2 products here in addition to those Claude.ai Pro and those Teams plans. You can also get Claude Enterprise, which is this Claude for work, which allows you to actually collaborate with Claude alongside your teammates. Or if you want to actually build something with Claude, you can use the Anthropic API within your products. You can even access Claude through some of the major cloud providers as well, like AWS and Google Cloud. I want to show off a quick demo of one of the cool things that's available right now in the Claude Enterprise plan, which is a GitHub integration, so that you can actually attach your GitHub and feed documents to Claude to use. This is a pretty cool feature, and I actually use it all the time when I'm doing development work. And again, this is available through the Claude Enterprise plan. So if you want to get started building on Claude today, I highly recommend checking out our doc site, docs.anthropic.com. We actually just revamped the entire website so that the entire experience is powered by Claude. So you can ask Claude questions in the search box, and it will return relevant information to you across all the docs and resources that we've created. You can also connect with us across most social media platforms. Here I just put down our Twitters. I am on Twitter at AlexAlbert with 2 underscores, so feel free to DM me if you have any questions. Or you can reach Anthropic at Anthropic AI. Thank you all very much and enjoy the rest of the talk.
Thanks, Alex. We are so excited about what Anthropic has been building because their latest models have been just a game changer for writing code. And Claude Artifacts have just been a huge upgrade on what you can expect out of chat experiences in a browser. And this is something we've been thinking about a lot at StackBlitz because StackBlitz is a web-based IDE. And when we started StackBlitz back in 2017, our goal was always to give developers a place where they could take an idea, get it into their fingertips, and get a response from the computer as fast as possible. And we did a phenomenal job of that with our web container technology that lets you run an instant operating system in your browser. But the promise of AI is that now what one keystroke you could write can now represent thousands of keystrokes that the AI is writing on your behalf. And this is just a completely different world than when we first started building StackBlitz. A couple of months ago, we got a sneak peek of some of the latest stuff that's available now, and we started working on a prototype of a new service that would really blend the cutting edge frontier models of AI with web containers. And today I'm excited to announce this new service. It's called Bolt.new. And simply put, Bolt.new is a dev sandbox in your browser that's powered by AI, built directly in. And you can kind of think of it like if Claude or ChatGPT had a baby with StackBlitz, that's Bolt. And it's an amazing experience because with a lot of these chat tools or other sort of dev tools that are popping up now, powered by AI, typically you have to copy and paste code to a local environment to run it. If they do let you kind of run the code, it's usually just some basic JavaScript or HTML and CSS. You can't really build meaningful full stack applications. And with Bolt, that's not true. You can actually build, debug, edit, and even deploy full stack applications. And this is really because of the magic of web containers. We spent over half a decade building this instant booting WebAssembly based micro operating system that can run the entire ecosystem of Node.js. And it's crazy good at running Vite applications. And so this is why I'm really excited because for years, the Vite ecosystem has been building the best web development tools in the world. StackBlitz has been building the best way to execute those tools in a browser. With the merger of AI, we've got an amazing experience that is like nothing else you've ever seen. enough talking about it. Let's go ahead and see a demo of this. So to get started with bolt.new, it's the easiest thing in the world. You go to bolt.new and you get this website here instantly loaded up. You can log in. Hopefully there's not a bajillion people trying it right now. If you're trying it, you might be on the little wait list, but let me go ahead and show you what this thing can do. So why don't we start with something simple? Let's just build a to-do app. We'll tell it to build a to-do app in React using Tailwind. Okay. And this might look like a normal chat application so far, but this is where it gets a little different. You see, we got a dev environment here that pops out on the right. You can see our file system in here. The AI is actually writing code. It's actually writing these files in. We have access to the terminal here. And it can actually install dependencies from NPM and import them, use them. It's going to go ahead and install those packages and boot up the dev server. It's using Vite to do this. And once it's ready here, we'll see our working to-do application. So do Keynote video. Check. Well, kind of check. Still in the middle of it, but pretty cool. And it's amazing how gorgeous the designs that come out of this thing are. And it can use any type of component library, design system, even a company-specific one you have. It's just insanely good at composing real applications. And again, this is a real dev environment. I don't have to just prompt the AI to do something here. I can go and change the code in here. So let's go ahead and find that the to-do app header, and let's change it to say Eric's to-do app. Go ahead and hit save, and you can see it already hot reloaded for us. Right. So if you want to get your full kind of dev environment side by side here, you can just hide the chat and just be coding. I'm going to go and bring that back. And of course, you got this open in StackBlitz button because every Bolt chat that you have is backed by a StackBlitz project. So you can go ahead and open it up, do your full development here. And it's just a seamless, beautiful integration that you can do with these things. Okay, so let's build like something more real, right? Like an actual beautiful website that's actually full stack and actually, could go into production. So why don't we go ahead and, create a new homepage for StackBlitz, have it include a login and registration system powered by Supabase, use Shad CN for UI with a blue accent for a theme. I'm going to go ahead and hit enter here. And it's going to go ahead and pull in all the stuff we need from Supabase, from Shad CN. It's going to go and boot this up and create all the different files we need. And that's kind of what really makes this magic compared to any other experience out there. It's not just a single file. This is spawning, multiple different files that make a real production grade application here. We can watch the AI pump these out. It even shows us where we need to put in our API keys for Supabase, and then kicks off the dev command to actually run the dev server. Okay, as you can see, it's developed our homepage with the login system and everything. I'm going to make this bigger. And pretty good headline. Let's even got this. Try React on StackBlitz. Really real looking homepage and beautiful one. It's got icons and everything. Even our login system that's got set up. If you pop into your Supabase keys, this would work, I imagine. Whenever we test it, at least it's worked. And it looks pretty darn good. So now, this looks pretty good for prod. Normally I'd have to go and pull this down and push it to a repo or something. It'd be pretty great if the AI could actually just deploy this somewhere for us, right? So let's go ahead and try that and deploy this somewhere. Turns out Bolt has built-in deployment integration with it. You don't have to log in. It does a production build in your browser using the web container and actually uploads that to a Netlify URL that you can add to your account. And so now we have our brand new website on a production URL after just prompting this thing into existence. Honestly, mind-blowing. To go from idea to production in a minute with a beautiful design. it's really something else. And so just end-to-end feels just magic. So we've shown some great use cases here of like starting a new site that you want to be beautifully designed, making a full stack app. But often there's things that as a developer, you might not even know how to do, or you might not want to do, like writing configuration files or getting a certain bundler set up that you might not be familiar with. I know it's ViteConf, but if you work at a day job, you maybe have to touch Webpack configs more than you'd like. And one of the hard things is when you're not familiar with tools, you have to go and ramp up on them. You run into lots of errors. You have to like Google them. And if you're using these AI chatbots to do that, you're like copying and pasting. When errors happen, you're copying and pasting back to them. It's a whole hassle. Normally you just, we'll just go to the docs yourself to try and figure the thing out. The cool thing about Bolt is that we've actually instrumented Web Container at every level, at the process level, at the runtime level, to actually be able to capture errors and pinpoint what's happening with them and have a bi-directional conversation with the AI on your behalf to actually get to the bottom of bugs and fix the bugs for you. And so to kind of show a demo of this, I'm going to create a Webpack config for something reasonably complicated. So create a Webpack config using module federation, vendor, the React and React DOM packages into their own bundle, have a simple hello world app. And so this is going to it's going to go and spin up a Webpack config for us. Again, I don't have to even know how this works, and I don't know how it works under the hood. I'm more familiar with Vite, admittedly. But it's going to go ahead and build this for us. It's going to install the dependencies and boot it up. And what you'll notice here, it doesn't seem to be working. I can look at this error log and see what's going on. Shared modules not available for eager consumption. I don't know what that means. I could probably Google it. The nice thing with Bolt is it caught that error. I can actually just say, go and fix that for us. And it's going to go ahead and figure out what's wrong and take a stab at actually making it work. And now we have working module federation right in our browser. So that's kind of the power of, let's see these errors. Those aren't errors. Those are not errors. And I can say dismiss. That's the power of Bolt and what we're able to do with Web Container here. Have this really integrated debugging experience that allows you to not have to Google around and be copying and pasting things back and forth. So really cool. And this is built into every chat that you're using with Bolt. It can help you debug and, when needed, you can take the wheel. You can go and actually pop open Chrome DevTools yourself, dig in, edit the code, etc. So these are just a couple of the ways that you can use Bolt. We have just been having the most fun playing around with Bolt for the past few months that we've been building it. And we're excited to get it into your hands today for you to be able to try out. You can go over to bolt.new. You can use it for free. We have a free tier. Obviously, AIs cost money, so it's going to be limited. But you can sign up for a StackBlitz subscription and get larger access to Bolt. And if you're an enterprise company, we can actually run Bolt behind a VPN. You can actually run the actual API for the inference yourself, etc. So if you want to use this for your company's design system or any other sort of internal tool, that is something that is also possible with the StackBlitz Enterprise plan. So we're really excited to hear what your thoughts are, and we're excited to see what you build. Whether it's a website, a Chrome extension, an iOS app, you can do a lot of really, really cool things with Bolt, and we can't wait to see what you build. Also, I want to mention that we have open sourced the core components of Bolt because we want to enable you and everyone else to go and build really amazing applications that blend this instant experience that web containers provide with the incredible code generation capabilities of these frontier models. So you can head over to our repo for Bolt, give it a star, give it a fork, and start playing around and putting your own applications like Bolt into production. So excited to see more things like Bolt proliferate across the internet that you might be using on a day-to-day basis pretty soon. So with that, I want to thank you. I'm going to hand it over to the rest of the StackBlitz folks to give updates on the other things that we've been building.
In the JavaScript ecosystem, we have a tool to address almost every kind of problem. But there's still areas so unexplored or difficult to tackle that they're practically in our blind spot. Sometimes we don't even realize that they're missing until someone actually comes up with a way to do it. Today, I want to introduce you to a new kind of tool, a resource for any framework or library, and one that I think will soon become a common element of our JavaScript landscape. Hi, I'm Tomek and I work at StackBlitz. As an engineer, but also just a web enthusiast, I'm always excited to see all the innovation around the capabilities of the tools we build, on their speed and on the overall developer experience. But as an educator, I know that we also recognize the need to innovate on how we communicate about these tools. So let's talk about documentation. What specifically am I talking about when saying documentation? Some of you may have already heard about the 4 quadrants of documentation. These are reference, explanation, how-to guides, and something else that I'll come back to in a second, but you may already have some idea. Today, with frameworks like Starlight, DocuSource, or VitePress, we have a great foundation for the documentation content. The content is generally a static text plus code snippets, although you can also add some interactive elements with live demos using StackBlitz SDK or embeds. But if you want to focus on the learning aspect of the documentation, we'll need to go a step further. We'll want a curated experience that combines a user guide with a battery of logically organized demos, or even better, exercises. After all, the best way of learning is by doing. So let's talk about tutorials. 5 years ago, Rich Harris pioneered an in-browser interactive tutorial experience to help developers get to know Svelte. It was a set of challenges with explanations running in a coding environment, all structured into an ultimate onboarding resource for the framework. When SvelteKit came along, its tutorial needed a backend layer, which was technically way more challenging. But in the meantime, StackBlitz came up with web containers that allow to run backend in the browser. So the Svelte team started working with us to create Web Containers API, specifically so that frontend and backend tools can be run in an in-browser tutorial. And these days you can see it in action with the official SvelteKit, Angular, and soon Next tutorial. And their communities love them. There's just one big problem. Behind this elegant and efficient form factor hides a lot of complexity. Building a tutorial app like this can be prohibitively difficult. Imagine just how much you'd have to code to get to a simple hello world screen in the setup like this. On the other hand, all these tutorials have a very similar structure and functionality. Almost like Storybook projects that all have the same look and feel, because no matter if they use React or Vue components, they're all presented using the same Storybook framework. So we have something that is very useful and repeatable, but also has to be built from scratch. Kind of insane. And that's why, based on the experiences of our friends from SvelteKit, Angular, and Next teams, we've built an open source tool that any team can now use to create interactive tutorials. We call it TutorialKit. Okay, I could tell you more, but just let's see it in action. So we start with the most straightforward command ever by running npm create tutorial. This generates the whole project and the initial content. Here, I've reached the proverbial hello world in well under a minute. So what can this tutorial do? We can see the lesson description and the code and the live preview and even the interactive terminal. If we're stuck on our exercise, we can click to see the solution. And we can navigate through all the topics in the tutorial using the outline in the drop-down menu. The app is available in a dark and light theme, and it supports custom theming as well, so you can align it with your project. All this is configurable. If a student wants to continue playing with a specific exercise, they can open it as a StackBlitz project. By the way, this also makes it a great starting point for all the DevRels and dev advocates out there who want to have a library of demos at hand for live coding and such. So that's the user-facing part. Now, how do we create these lessons? For the description section, I just create and edit Markdown files. These are actually MDX, so there's a lot of flexibility as to what you can put there. I can create reusable components or use some of the built-in ones, like code snippets or this info aside. And the code that runs in the interactive environment is placed in the files and solution folders for the given lesson. When I edit the description or the code, all updates live, as you might expect. At this point, the most common question we get is what type of code bases can run in this interactive environment. And in short, this can be any JavaScript code that can run on web containers. In other words, if it's possible to run it on stackblitz.com, it will also work in TutorialKit. Web containers are actually the secret sauce here. They allow the projects you run in a lesson to utilize any package manager you like, to run monorepos, and even work behind a company VPN or use private packages. Speaking of technical details, under the hood, every TutorialKit project is in fact a static Astro site, so it's really fast and you can deploy it pretty much anywhere. To make working on tutorials as convenient as possible, we've also created a companion VS Code extension. So let's look at what it does. I can easily navigate the tutorial outline without having to traverse the whole project codebase. I can also create new lessons. Just click and all the necessary files are generated. The extension also provides IntelliSense used for the lesson configuration, because there are tons of options here. You can use them to customize the lesson appearance and functionality. So this is TutorialKit. We've only launched it recently, and people who are already building on top of it seem to be as excited as we are. Also, it's an open source project, so it constantly evolves, and we always welcome new contributors. So now, when we have a dedicated tool that deals with this area, I think that interactive tutorials will become a common part of our JavaScript landscape, complementing the great documentation sites that we already have. If you want to learn more, head over to tutorialkit.dev, and don't forget to share with us what you've built.
Hello everyone, I'm going to talk about pkg.pr.new this talk and how it's going to enable faster feedback loops for you as a maintainer and also as a user of NPM libraries. So who are we? I'm Mohammed, I'm one half of pkg.pr.new, and we got the other half too, which is Amir, and we are the maintainers of pkg.pr.new, and it's been the most exciting projects ever for us. So we're really happy to have this talk. Anyway, let's talk about the issue. Well, if you've been a maintainer or maintained any library, one of the hardest things to do is enabling users to try out branches or specific bug fixes or new features before shipping them. So if that's the mainstream thing that all the users do. They would have to clone the project, they would have to check out to that branch, they would have to build the project, and then they would have a local build of that project. For instance, you can see that Alex here and Patak having a discussion of how they can try out Vite before Vite like ships out a specific feature or a specific bug fix. And one of the other solutions that developers came up with is continuous releases. And what that would do is on each commit, they would just release a new version, like a new useless version kinda to the NPM registry. And users would be able to try out that version. But the thing is, most of these commits, no one would try them out, and they would be just a whole amount of junk in the NPM registry, and it would be just some spam over there. So it's a good solution, but not an ideal solution. Here where pkg.pr.new comes. Well, it's a tool to provide instant previews for your NPM libraries which means you can just do npm I a specific URL, and it would have that package at that commit hash or at that PR number or branch name accessible for you. So here you can see we want to try the view package at this commit. You would just put this URL, npm I, and then done. You would have that version accessible for you. And how it works? Well, you just have to install the application, the GitHub application, and then you would have to run this one-liner command and done. Then a package PRU would be enabled for your library. So you can just try that continuous release and see if that bug fix or that feature actually works in the real world. Well, after you install it, you would have package PRU sending comments to you with the instructions to try out that specific package in that specific state. For instance, you can see the expect type here at the PR number 92. It would just npm add it, and you would have that version accessible for you. The other thing you can do, as I said, is the commit hash, or if you want to try the branch, you can just put the branch name after the @ sign, and it's all done. You would have that version in your workspace. So the lineup has been amazing. Most of the teams, companies, and folks that I looked up to my whole life tried package PRU, and it's one of the best events in my life and Amir's life, actually. So if you want to be part of the family, just try package PRU out and send us a PR for our README and include your logo over there. So we'd be happy to just host you. Legends are happy using package PRU. You can see Divyansh from Vite Press, you can see Alec, you can see Johnson from Volar, Peru, and even you over there. Everyone is apparently happy with package PRU, and if you read these testimonials, you can see that the experience is amazing, and apparently package PRU was a game changer for their workspace and their tooling. We never expected that, actually, but it happened already, so it might change the game for you too. So please try it out and let us know. And soon we got amazing integrations and features coming up. We have the ESM.sh one, which is a CDN, one of the best CDNs over there for JavaScript. And what would that do is enable package PRU, hopefully in places like Dino or the Vue Playground, where it's just a browser thing and it's a browser native website and would just like accept URLs in the import maps. The other feature coming up is the UI for package PRU. Acrium just shipped the 90.acrium.dev, and we just hit Acrium up and we just told them that let's try this thing and have something coming up with the package PRU there. And huge shout out to Jay and Acrium for all the hard work. Hopefully when this video comes out, we already have shipped this, but who knows? It all depends on time. Okay, so that's the end of the presentation. If you have any other question, any other issue with package PRU, just hit us up. Just ping us or check our URL pkg.pr.new, and then check the documentation and see if package PRU works for you. We'd be happy to discuss anything around package PRU with you, so just keep us updated and ping us everywhere. And by the way, if you're a company trying to use package PRU internally, honestly, we'd be happy to collaborate with you and come up with a solution for you. So just send us a DM or ping us in Twitter or do anything you want. Just keep us in the loop. So feel free to ask any question. I would be happy to help you there. Thanks so much, everyone. Peace.
Hey everyone, I'm Jan Braga, Storybook maintainer at Chromatic, and I'm here to talk about exciting new integrations for Storybook with Vite and Vitest. But before, for the ones that don't know, Storybook is the most popular tool for building UI components in isolation to assist engineers with development, testing, and documentation. Let me show it in practice. On the left side, I have a button component. It has different UI based on props like large, clear, and round. So similar to how you write tests in a collocated test file in the component directory, for Storybook you have a stories file. This is where you define which component you want to render, you can provide properties to be applied, and then each one of your named exports translates to a UI state, which we call a story. You can also refer these stories in an MDX file, which would attach custom documentation to that component. So let's start Storybook to see how it looks like. As I run Yarn Storybook, it uses Vite to serve all the code, which is super fast. It opens the browser and the first story is for my button component. You can see that documentation is coming from the MDX file I have over here. So you can even attach live Figma design specs, which I find pretty cool. But anyways, let's go back to our stories file and we see that the default and clear story relates to the ones on the sidebar. So I can easily see the different variants of my component, and I can use the controls add-on to tweak with its props. For instance, making the button round. And let's change the text to like hello ViteConf. And now I can click on the save button, which will actually save the code right there for me. It's also quite handy to create new stories. Let's create a disable button state. So we toggle the prop and then we can click on the new button. We give it a name. And as you can see, now I have a disabled state in my story file. You can see how easy it is to cover all UI states of your components, right? Stories are essentially tests. Apart from passing props to them, you can also write interactions and assertions by using the stories play function. You can use test utilities to, for instance, locate the button and then expect it to be disabled. The expect function comes from the Storybook test package, which is powered by Vitest, by the way. As I save the file, the test will run, and on the right side there's an interactions panel, which will show all of the steps related to the test we just wrote in the play function. So let's cause a regression by changing the disabled property to false. And on the right side, we see a failure mentioning that the button is not disabled. Once we fix the failure and save, it's all green, it's all good. You can use Storybook to develop all sorts of components, from simple to complex. Like I have many stories, for instance, pretty much for all of my components in the project. So with advanced mocking mechanisms, I can use Storybook to even render fully fledged pages, like for instance, this restaurant detail page. I can use the play function with interactions to, for instance, open a model, or I can mock network requests, allowing me to easily access hard to reach states, like a loading, not found, and error states. So how does Storybook relate to Vite? Storybook is built on top of Vite and integrates tightly with the Vite ecosystem. This is the third year in a row that we're sharing about Storybook at ViteConf, and each year the connection gets deeper and better. Before we talk about a brand new integration to Storybook, I would like to share a couple of updates on Storybook 8, our latest version. First, I'm excited to report that a whopping 65% of new Storybooks are using Vite. This is more about Vite's success than Storybook, but it's really exciting for us because the developer experience of Vite is just amazing. Also, in Storybook 8, we consolidated many Storybook packages, which resulted in a drastic install size reduction from previous versions, up to 50% smaller. We're also working together with the E18E, the incredible ecosystem performance community, getting continuous contributions like replacement of older packages with newer ones, as well as many optimizations which are making Storybook smaller and faster. We are partnering with the Vite and Vitest teams to make Storybook even better. Storybook is now part of the Vite ecosystem CI, making sure that Vite and Storybook are always compatible with every new release. Now I'm excited for our biggest update, which is component testing with Storybook and Vitest. This is a deep collaboration between the Storybook and the Vitest team. And before I get into the details, I would like to give a huge shout out to Vladimir and the Vitest team, who have been amazing to work with. Now let's talk about component testing. In this project, I am using Vitest alongside a few test files. I'm basically testing some React hooks using testing library. I'm also using the amazing Vitest VS Code extension, which detects all my test files and shows them directly in the extension sidebar where you can execute them without using the CLI, which is super handy. So let's go to the testing tab, and then right here you can see all of my tests. I can click on this button to jump into the test definition. I can also run specific tests by clicking on this play button, and I can run tests from a specific file, or I can run all tests from a particular directory, which is super cool and convenient. I can also run all of the tests in coverage mode, and then I can see the coverage information at the bottom. I can also go to the Explorer sidebar and look into the coverage per file over here. I can see that my hooks files, they have about 74 and 100% code coverage. However, my entire application has only 2%, which is really bad. But that's not true. Stories are tests, and in this project I have tons of stories which test and cover a lot of my code. The thing is that the story tests are not automated or integrated with my Vitest suite. Well, not anymore. We now provide a new experimental Vitest plugin that fully integrates your stories in your Vitest configuration, all of which can be configured by running a single command, npx storybook add experimental add-on test. This command will install the Storybook add-on, which is compatible with React, Svelte, and Vue. It will install and set up the Vitest browser mode with Playwright so you can run your tests in a real browser environment. Finally, it will add the necessary Vitest configuration files for your project. And that's it. The installation assistant tells me that I can run npx Vitest project storybook to run all of my story tests, or that I can use the Vitest extension in the editor to look at all my tests. So let's open the workspace file to see how things actually work. So the command configured a Vitest workspace file that integrates with my existing testing suite, and then it adds a new one for my stories using Vitest browser mode with Playwright for high fidelity tests. So the core functionality actually comes from the Storybook Vitest plugin, which transforms all of your stories into Vitest tests. You don't even need Storybook to be running in order to test your stories, but you can always pass a Storybook script option to the plugin so that when you run Vitest, it runs Storybook in background in case you want to inspect your stories upon failure. Now that it's all set up, let's revisit the test tab. Not only do we have the tests from our original testing suite, but we now have tons more tests coming from the story files. For instance, in the components section, we have the button stories that we worked on before. We can go into the file, and now all of the stories are seen as tests by Vitest. As I click on this button, it spawns a Chromium browser and runs the tests in Vitest browser mode. I can test all of my button stories by clicking on this button, and if there's a failure, for instance, let's force one, when I rerun the tests, I get an inline error message directly in the file, which is incredibly cool. I don't even need to leave the file to understand what's going on. In this case, the error message is quite clear, right? The button is not disabled when it should be. But you can imagine that most of the times the error messages are quite cryptic, and therefore you need something more visual to inspect and understand what's going on. Because we provide a Storybook script to the plugin, the Vitest plugin ran Storybook in the background and provided a URL which will make debugging just a breeze. So once we click on the URL, it brings us to the failing story with the interactions panel open so we can see what's happening. Then I can go back into VS Code and then fix the regression so that I can rerun my tests. And it's all passing in Vitest as well as in Storybook. This click to debug functionality is especially useful if you publish your Storybook as part of CI. And if the tests fail, you can actually point to that live Storybook where you can jump to the failure directly from CI. Now let me show you a more complete testing example so you can see how cool it is to debug things in Storybook. Let's go from this simple button to the stories for my entire application. So in this story, I essentially visit the homepage of my app, where I can actually navigate through it manually myself, and then I can see how my app behaves in different flows. I can click on the remount button to bring it back to its initial state. However, I have stories where I automate all of these actions by writing interactions and assertions in the play function, allowing me to test the app basically from end to end. And the cool thing here is that every step in the play function is shown in the interactions panel, and I can use the debugger to step through them. I can go back and forth. I can even jump onto like a specific step, and then I can see how my component looks at every step of the way. If there was a failure in the tests, we would easily know what happened, where it happened, and how the component looked like at that moment. And all of this works the same in a deployed Storybook, by the way. This means that from a single URL, all of your teammates could see and debug the failures without even having Storybook in their machines. As you can see, not only I have stories for my button components, but also for pretty much all of the components, testing many different use cases in multiple stories. So my code coverage should actually be much higher than 2%. Let's go back into VS Code and rerun all my tests with coverage again. This runs all of my non-Storybook tests in Node, as well as my Storybook tests in a real browser with Playwright. For the stories that don't have a play function, they're smoke tested and will fail if the rendering doesn't succeed. Once I get the test results back, I see a lot more coverage. So if I go back into my sidebar, things are much more exciting. I went from 2% to a whopping 86% of code coverage by using Storybook. So you can now use the power of Storybook while developing and get automated Vitest tests for free. And that was component testing with Storybook and Vitest. You can turn all of your stories into tests. You can increase your code coverage greatly with all of your stories. You integrate with existing testing suite, so you can extend and run alongside of your existing tests. And of course, use Vitest browser mode for fast and reliable tests. Now, you might be wondering, well, what if I'm using Storybook for Next.js, which is a Webpack-based framework? Will I be able to use this new integration? Yes, actually, we're also happy to announce a new Storybook package for Next.js and Vite. So the Storybook experimental Next.js Vite package not only allows you to use the new Vitest integration in Storybook, but also to run Storybook for Next.js with Vite as a builder. So that means that you get all of the speed from Vite, but also the features from Next.js, such as the image component, navigation, React Server components, and much more. And all these things are available today in Storybook 8.3. So please try it out. We're really looking forward to your feedback. Now let's take a look into the future, shall we? What's coming in Storybook 9? Vitest is the backbone of our component testing efforts, but functional tests are not the only kinds of tests we're interested in. Storybook also has best-in-class visual and accessibility tests, and we're looking to bring this into a unified UI in Storybook sidebar. Powered by Vitest, running automated tests on the click of a button, toggling watch mode whenever you want, being able to choose different types of tests. You can also filter the sidebar based on story statuses, so you can glance at the stories which are failing or have any warnings. Vite has been really great for dragging the JS ecosystem towards ESM, and Storybook is looking to join that fight and are hoping to ship an ESM-only release in Storybook 9. This will also bring a lot of reduction on our install size, and we have much more in store to make Storybook even smaller. And that was it. I'm Jan Braga. Thank you so much for your time and joining me at ViteConf, and I'll see you next time.
Hi everyone! Today we're going to talk about NX and specifically how NX will make your Vite project fly. I am Katarina Skrumpelu. I'm a senior engineer at NX, a Google developer expert for Angular and Google Maps, a Women Tech Makers ambassador, a speaker and instructor. I really like cats, and you can follow me at CyberCity or cyber.city. So what is NX? NX is not just another build system. NX will make your CI faster. I will assume that most of you know what NX is, more or less, so I will not bore you with the details. What I will do is that I will show you an amazing demo on StackBlitz that you can try right now at home. But just to be sure, NX offers two main pillars: the NX Cloud, which ensures that you can scale your projects, you can replay your tasks and make everything fast. And NX plugins through the NX CLI no less, that provide automation, automatic migrations, and can help with code maintenance. So let's jump to the demo. You were just going to start with a StackBlade blank project. You can use a React or a Vue or whatever you want because NX plugins support all. We're going to start with a TypeScript React project. We are going to make a GitHub repository out of it. We are going to use the amazing npx nx init command to add NX to our new React Vite application. So npx nx latest init, and it's going to ask us a few questions to set up our new NX workspace. First, it's going to ask which of the following scripts are cacheable. That means produce the same output given the same input. The build and the lint tasks are usually cacheable. Does the build script create any outputs? Sure, they put it inside this. Does the lint script create any outputs? I don't know, I will leave it blank. And do you like to enable remote caching to make your builds faster? Yes, of course, this is NX Cloud. And it's going to ask us if we want to add some NX plugins. We're going to add ESLint and Vite plugins in order to take advantage of what NX offers. And yes, we want to start using NX in our package.json scripts. Now that it has generated and installed everything, it says that we have to commit and push our changes because our NX Cloud workspace is ready. We have to commit and push our changes and create a pull request for the changes. Now that I have added and pushed everything, I can go back to the NX Cloud link. Here I can connect a GitHub repository. I can add it to an existing organization. It doesn't matter at the moment. And I just click Connect Workspace. Right now, we don't have any runs that are run and no CI pipeline executions. If I run the npx nx run many build command, it will run the build command for my Vite project. Once these are finished, I can go back to my runs and see my runs in the Show All Runs page. I can go back to my terminal and click on the cloud.nx.app link, and it will take me to my run on NX Cloud, and I can see it there and see all the outputs from each command. Now, you can see if we go on GitHub, you can see that adding NX just makes minimum changes to your workspace. It just adds some new packages in package.json, just changes the package.json scripts for build and serve. And it also adds an nx.json file with some configurations for NX. It's not intrusive, it doesn't change anything on your application. Just adds a config file and changes some things in your package.json. Now, let's see how you can set up continuous integration in your newly created Vite and NX workspace. So we can go ahead and set up CI by running this generator npx nx generate CI workflow. What is our target CI provider? It's GitHub. What should we name our workflow? Let's say CI. And you see it did add a CI workflow inside our GitHub folder, which will run a command that's npx nx affected and target lint test build. We don't have any tests at the moment, and the affected means that NX affected only runs tasks that have been affected by the changes. We cross out the test, and we're just going to push our changes. Once our changes are pushed, GitHub already has this action set up that it's already running, and we can see that it's running all the steps in that workflow. So if we go back to our workspace and make a new change, let's first create a pull request. And let's make a small change to our app.tsx. Now, once our change is pushed, we can go on GitHub and open a new pull request for this change. And soon enough, the NX Cloud report will appear here. And I can click the Click to Track Progress button, which is going to take me on NX Cloud, where I can see my workflow being in progress. And here I can actually see what the agents are and what tasks are being run. I can already see that it's spinning up 2 agents because it wants to run the build and the lint tasks in parallel in these 2 agents that I have. And I can granularly see what the build and the lint look like, how long they take, and everything is available on NX Cloud to look at. Now, let's take a look at the magic of affected. In my existing NX workspace, which is just a Vite app, I generated a new Vite React TypeScript app using the Vite CLI. And I just added it inside an apps folder inside my existing Vite repository. This app just has one component named app2. In package.json, what I added was the workspace's attribute. Now, if I run nxgraph, the command nxgraph, I can see the 2 projects that are in my NX workspace. What my goal is now is to create a change in my new application to see how the affected command works. I commit my change and I create a new PR with this change. So now on NX Cloud, the command is nx affected with target lint and build. And because I only made changes in this new project, you will see that it's only building and linting this new project, the React-TS project, and it's not building the other project or linting the other project at all. What we're going to do now is we're going to go on our main app.tsx and import the app2 from our other application. Now, if I run nxgraph again and click Show All Projects, we are going to see that our main project is dependent on the React.ts project because it's importing it. Now, let's push our changes and make a new PR with making a change again to the React.ts project. After we've made the changes and we've pushed them to just the new application and we create the new pull request, we're waiting to see what NX Cloud says and how NX will treat these new changes. And we see that now it's running 4 tasks instead of 2. Before, it only ran 2 tasks because only the new application was affected. But now, because the old application, the main application, depends on the new application, it has to rerun, rebuild, and relint actually the main application as well. So it's running 4 tasks distributed on 2 agents. One agent is running the build for the one application. The other agent is running the linting, the build, and the lint of the other application as well. So you can see how easy it is, after all, to add NX to your Vite project. You can just do npx NX init, and it will work. What's more, NX loves the OSS community, and the OSS community loves NX. So what are you waiting for? You can find NX at NX DevTools on X, or nx.dev or nx.app. And you can find me at CyberCity or cyber.city. See you soon!
Okay, so how is everybody going?
I'm doing good. The chat's been amazing. Thank you to the speakers who've been able to keep up and attend during their talk. And thank you to everyone participating in the chat, leaving such positive messages and making the speakers feel really good, because I can tell you it can be a little nerve-wracking.
Yeah, it's very nice how things are going so far. So let's keep it up. If you are just joining, like, we don't want to give a spoiler again, but as Sarah was saying, like if you just tuning in and you are seeing like the stream, go to chat.vitejs.dev because there is where the action is going. Or if you go to vitecon.org/live, you're going to see the chat there, and you can join us. Remember also that we have the Run Talks code, the button that is below us, so you can play with the examples that the different speakers are talking about. And yeah, I don't know, like, do you have any more advices? Like, should we keep going? How we are just starting?
Yeah, my advice is go put on another coffee or tea, because there's still a lot left to go, and we want that energy level up. We want to keep the chat going, we want the discussions going, we want your mind sharp for all these amazing ideas and new things that you're learning. So get yourself ready. It's a little bit of a break now, so you can go do that, and then come meet us right back in the chat for more talks.
Yeah, and then after this break, we are going to start with the infrastructure section. Volar is coming, DevTools Kit and Nitro, and then the frameworks that are using some of them, like these tools. So there is a lot of very interesting topics coming just now. So as Sarah said, let's refresh a little bit, and then we are going to get all back together here.
See you soon.
See you soon.
Hello, welcome to ViteConf 2024. I'm Johnson Ju, the creator of Volar.js. On Volar.js.div, it says that Volar is the embedded language tooling framework. Today, I will talk about how Volar.js works. Volar is a framework for building language tools that can support any embedded language for any frontend framework in any environment. Currently, Volar has been widely adopted, and many useful language tools has been built based on it. We have made many improvements over the past 20 months for this. Now, let me show you how Volar achieves this capability through its architecture. This diagram shows the module relationship of Volar. The language core module is the most fundamental module, used to construct these language applications. The language surface module encapsulates the handling of embedded codes and exposes language features APIs based on LSP types. It is used to construct this language surface application. Finally, front-end frameworks can use language application and language surface application to build their language tools. You can see the plugin layer before the language core module, which defines the capability to handle embedded language for all downstream modules. In the language plugin layer, the language tool needs to define their visual code transformation and mapping method based on the Volar language plugin interface. In the create visual code hook, you can disconstruct a language that a downstream module does not recognize into mutable language visual code and mapping that downstream modules do recognize. This provides Volar with enough information to port language features and handle various mapping issues. In the LSP and TS plugin, there is no direct way to load the language ID of a file that has not been synchronized to the language server. Returning a definite language ID for recognized file extension in getLanguageID hook helps downstream language application correctly handle files that are not open in IDE. Now, let's look at the language application layer. The Volar language module accepts multiple language plugins as a parameter and returns scripts and math properties. The scripts property provides an interface to query the relationship between the source code and the visual code. The math property provides the mapping functionality between the source code and the visual code. This gives language application the ability to handle embedded language. In the language surface plugin layer, Volar improvement the language surface plugin interface for each available embedded language through a glue layer. Through the language surface plugin interface, the Volar language surface can add language filter for any embedded language in a pluggable manner. Implementing and maintaining the glue layer for all third-party libraries require a lot of work, but the Volar team has already done it for you. In the language surface glue layer, Volar integrates language surface API for each useful use case and package them into a more user-friendly library, including SP, CLI2, Moloko, etc. Finally, in the integration layer, Volar modularizes each use case and exposes easy-to-use APIs. Volar's modularization is carefully designed. You don't need to worry about package dependency relationship. This diagram greatly simplifies the work done behind the integration. Like Erica said, this is work that you don't need to care about and don't want to care about. If you have searched for LSP on Google, you have probably seen the image above, which clearly shows how LSP effectively reduces repetitive work in software engineering. Volar.js was created for similar reasons but goes a step further. In addition to solving the repetitive work of implementing embedded language support, we are also addressing the repetitive work of implementing a complete toolchain for frontend framework. We are gradually moving toward the vision of improving the DX of the entire frontend ecosystem. There is even a chance where ecosystems unrelated to the frontend are benefiting from Volar. Finally, I want to say thank you to my sponsor. A special big thanks to Stabilis, who have unconditionally funded my full-time development of Volar.js for the past 20 months. They have never made any demands or exerted any pressure on me. I'm very grateful for their trust in my work and vision. The progress Volar has made was unimaginable a year ago. Similarly, I cannot predict what will happen a year from now, so I look forward to talk about Volar with you again this year. Thank you for watching this talk and see you next time.
Hi everyone, my name is Erica. I'm a coordinator on Volar and Astro. At last year's ViteConf, I introduced you all to Volar, a cruel framework for making language servers, and hopefully, if everything went well, this video plays right after a talk by Johnson, the creator of Volar, giving you even more reasons why Volar is awesome. In this talk, I'd like to now give a quick summary of the past year, the current state, and the future of Volar. Starting with this past year, of course, we've been hard at work on improving Volar and everything around it. Listing everything that has been improved or fixed would take a very long time and honestly not be super interesting. But to summarize, we've done what you would expect. More features, better performance, bug fixes, you get the point. We now have an official website at Volar.js.dev with docs, guide, news about the project. It's still a little bit light on content, which, to be honest, is pretty much my fault. But we and I'm working on it. And in general, now that Volar is more stable, more learning resources and better onboarding is definitely one of our priorities. Adoption of Volar has grown a lot in the last year, from both small one-person projects to large companies. We're happy to see Volar used successfully in production and people being happy with it. Volar now gets more than 2 million downloads per week, which is a very impressive amount, and also, let's be honest, a very scary amount of people potentially relying on code that I wrote, but it's okay. If they're happy, I'm happy, and it's fine. Even the slides behind me were made thanks to Volar, using slide.dev.new language server. And yeah, it's getting more and more likely that you've interacted with Volar somehow, and I think that's pretty cool. Seeing all those tools integrate with Volar has also been really beneficial to the development of Volar, both because we get to notice limits of the current APIs, or because just simply those others end up contributing back to Volar, and as I've talked about last year, it ends up benefiting an entire ecosystem of tools. For instance, for their Angular support, JetBrains needed to add a new feature to Volar, and I ended up using it in Astro 2 weeks later. That's cool. So what's next? One of our main focus for the coming month will be to improve support for other editors than VS Code. In particular, we're starting to explore integration with the web code editor CodeMirror so that people could provide language tooling for their web playground or just web editors in general. We'd also like to improve the story around testing language integration in editors. Right now, it's often a bit challenging to make sure everything works because there's a lot of moving parts and there's a lot of editors and there's different language server implementation. And well, that's something we would like to hopefully make easier. And apart from that, well, the usual, fixing bugs, improving performance, new features, as the things we do. And that's pretty much it. Thanks for listening to me and happy ViteConf. Bye bye.
Hello everyone, welcome to this talk about Devtool Kit. My name is Guillaume Shaw, I'm part of the Vue.js core team, and you can find me on X and GitHub with my handle Acria. So there's been a lot of new DevTools in the Vue.js community. So for example, we got amazing Next DevTools, which you can open in any Next project, and it's gonna display a lot of information about your Next application, which is pretty cool. And there's also the new Vue DevTools, which is pretty similar and using the same ideas of a button on your page to display the DevTools. it can also be installed as an extension or as a standalone application. So those new DevTools are amazing, but they are different and they are not fully compatible with each other. So that's why we started working on this new idea of a DevTool Kit. So the goals of this DevTool Kit is to unify the DevTools under a common set of utilities and APIs, and to also make them compatible with each other so that you can find the component inspector from the Vue.js DevTool inside the Nuxt DevTools, or you could find the Nuxt roots from the Nuxt DevTools inside the Vue.js DevTools in the future. And also we want to make it easier to build DevTools in the first place for any other frameworks. It's basically going to be an SDK to create DevTools. With it, you can create DevTools for any framework, so not just Nuxt or Vue.js. And it's going to support a lot of different environments. Creating DevTools is a pretty complex task. Everything I'm going to show is work in progress, so we're still figuring out what the APIs look like. So anything can change between now and when the SDK is going to be stable. So DevTools is a tricky thing to solve because a user application can be in any kind of different situations, and the development involves a lot of different environments, like the browser or the Node.js server where you have the Vite server, or an extension or a standalone application. So that's a lot of different environments. To make sure that every kind of situation is supported is a little bit tricky, and the new SDK is going to help a lot with that. So this example is basically the current Nuxt DevTools situation, where you have the Vite server and you have both the application and the Nuxt DevTools inside the browser page. In this other example, we can see the current situation with the DevTools for Vue.js, which are displayed inside the browser extension. This example is a little bit different because here it's in the case of using the standalone version of the Vue.js DevTools, where it's running inside an Electron app, basically, so you can use it in any browser or even native script. And you can also use it if you build the application and publish it into a staging environment. And this last example is if you have the staging environment and you're using the Vue.js extension. So that's a lot of different situations and different environments to handle. The new SDK is going to be very helpful for that. So basically an applet is a debugging feature inside the DevTools. So for example, you could have an applet to inspect Vue.js components, or you could have an applet to inspect the Nitro routes from the next application, and together they becomes the DevTools you're using to debug your application. So here's an example of an applet, and it can have different kind of modules, which are here a main module, and page module, and a view module, and they all communicate with the core experience of the DevTools. So if, for example, you're using the Nuxt DevTools, the core here is going to be the UI provided by Nuxt. So currently there are 4 types of applet modules. So the main one is going to be the one registering the page modules, and also the tabs in the DevTools, the views, the commands, and basically the main API for the applet. You can also have page modules, which are going to live in the same context of the user application, so you can interact with it. And then you're going to have view modules, which are basically the visible part of your applet. So for example, a component inspector with the tree and the state inspector. And you're going to have some server module as well, which are going to be mocked if you build your application with DevTools enabled. So I'm going to show a little bit of code during this talk, but it's still work in progress and everything is subject to change. The main module is going to be the one registering page modules, but it can also add views or commands on other things. And it's gonna initially be run inside the Vite's context, but it can also run inside the application page if you, for example, build the application while still enabling the DevTools and put it into a staging environment. So let's see here. I have an example of an applet for the DevTools. So this applet is basically split into two parts. So you have here the different JavaScript files that are going to be used by the DevTools. And there's also a view, which is a small view application, which will display some basic interface to the user. So the main module here is gonna first register the page module for my applet. And then I'm gonna also expose this function, and it will be available to the other module of the applet. And then I'm creating a channel to the page module, a channel to the view module, and calling a function from the page module here, and then also creating a few views to display, usually in tabs in the DevTools. But it's up to the core experience how to display those views. So it could be something different. So next we have the page module, which is very useful because it lives in the same environment as the user application, which is why you can interact with it to, for example, fetch, store state, or call functions that are declared in the user application. You can also interact with the page DOM if you need. You can also use the general API to register new tabs or new commands like the main module. So let's take a look at our page module here. So this module is going to expose two functions here, but this function is more interesting because it's actually interacting with the view application on the page to fetch the store state. And then I'm creating a few channels to the main, the view, and the server modules, and creating a few buttons to test the communication between the modules here. And similar to the main module, I'm also adding a few tabs. And this one is very interesting because it's the view application inside the applet. So if we take a look at our application, we can see that I have the 4 buttons added by the page module that allows us to test if we can communicate between the different modules. So if I click on this one, we can see that I received the information from the main module here, which currently lives inside my Vite server on Node.js, so not in the browser. Next, we have the view module, which is the visible part of the applet. It's going to be displayed inside DevTools tab. And it's going to, in our case, be a view application displaying the user interface to interact with the store. So in our demo here, it's going to be a simple view application, nothing special, but it can call functions from other modules. So in this example, I'm creating a channel to the main module and the page module, but we're going to use mostly the page module. And it also exposes a few functions that can be called by other modules as well. This one is pretty interesting because it will allow the page module to push new state to the view to automatically update the inspector. And in this view component, I'm manually calling the function from the page module here. So if we go back to the page module, we can see that I'm directly calling the function from the view to push new state for this automatic update to work. Here, I have a simple UI for the DevTools core experience. In this Pinia tab, I can see the Vue component rendering here. In our user application, we can see a simple store with a counter. And if I increment the store, we can see that the state is gonna be updated through the page module, which then sends the update to the Vue module here. So we can see that it updates automatically. And finally, we'll have the server modules, which are very useful to send information that we only have access to during development. For example, in an Oxc application, we could list the Nitro routes, or we could use any Node API because this module is going to run only in a Node environment. If we build our application to production, but still enabling the DevTools, we can mock all of the calls made to the server module so that we still have the Nitro routes, for example, in our staging environment. So if we go back to our code, we can see here that I'm using a Node API to release the files in the project. But then in production, I'm gonna write the results of this call into a static file used while building the application, so that when the application is running in the browser on a staging environment, it can still have the list of the files using initially the Node API, which is no longer available because we no longer have a Vite server in our staging environment. The DevTools Kit provides us with a managed communication system that allows all of those modules to communicate. Even if we are in the main module, we can call a function from the Vue module or a function from the page module, and everything can communicate. So this communication system is basically a remote procedure call system where you can call the functions from other modules just like if there were functions in the same context. Any module can communicate with any other module. The Vue can communicate with the server or the main or the page, and it's bidirectional, so the page can also call methods from the Vue. And it's fully typed, so if you are using TypeScript, you can see all of the types coming back from the calls. So if we look at this one, for example, we can see that TypeScript got the types. We return a state object. And if we take a look at the page module here, we can see that the function returns a state object. So currently we have a few communication channels that DevTools Kit is gonna use automatically between the different modules. So we have the direct one, which is useful if two modules are in the same context. So for example, if the main and the server modules are in the same Vite server. And then you can use post message. For example, if you have the view inside the browser DevTools and you have the page, you need to use post message to communicate. And then you can also use WebSockets, which is the standard to communicate between the browser and the Node server. If you are using Vite, use also the HTML API to communicate, which is also using WebSockets. Thanks to the mocks that we can do for the server calls, we can imagine in the future having the next DevTools running in a staging environment where you can still see the Nitro rules or anything related to the Vite server inside the DevTools. Here's a little summary of the main APIs that you can use in the applet. So obviously this communication system, but also the views. They can be iframes or commands or terminals or inspectors, which allows any library inside an application to integrate with the DevTools, even if they are not specifically made for the framework. So we can imagine having a DevTools implemented in Svelte, displaying a store from a Pinia store in a Vue application, which is kind of crazy. And then you can also have commands, actions, and prompts that helps with usage of the DevTools using a palette, for example. And those applets are basically small bricks that you can assemble to create a much bigger DevTools experience. So we can imagine in the future mixing and matching different kinds of applets for different kinds of tools or frameworks and create a super version of the DevTools tailored for your specific use case. So for example, we could have the component inspector from the Vue.js DevTools and the modules inspector from the next DevTools, or a Tailwind DevTool or a Storybook DevTool. and have them automatically appear in your Vue.js DevTools. That's it for today. I hope you enjoyed this talk, and you can find me on Twitter or GitHub with Acrium. Thanks a lot.
Hi, I'm Priya Parsa. I'm creator of OnJS and Nitro and a core team member of Next. Today, we are going to have a first look at the exciting features that are coming with Nitro version 3. Nitro is a server toolkit, essentially a framework set of utilities, features, and packages that allows you to write your framework and deployment agnostic servers using easy and powerful APIs. And once ready, it can automatically compile, bundle, and prepare your application to be deployed on any deployment provider that you want. You can learn more about Nitro from the official Nitro website. Here is an overall look of how Nitro features essentially, there are two parts. There is a runtime part, is the code and logic that goes to your server bundle that you run this in production or in development time. Runtime has several features. One of the most important ones is the API routes, that you use them using a file system structure to define your server API handlers using as event handler API. This is powered by another framework called H3. You can learn more about it in the official website. It gives more features such as plugins that run under server startup, WebSockets API that you can define your routed WebSocket handlers that are independent of the deployment provider. So we can just write simple WebSocket handlers. There is a built-in renderer layer that is used by frameworks for server-side rendering. There is a route rules engine that can match your routes and apply rules on them, like redirects or proxy or adding headers. There is a built-in storage system that is backend agnostic. You can configure it or just use the default options and use it for storing data in your server application. There is a core task runner and cron job runner, and you can use it to run some specific actions based on a timer or an action. There is a powerful built-in caching layer that you can use it to easily cache your API responses to make the server much faster. And there is a database layer that is already configured out of the box as well, and you can use it to have an embedded database in your application or configure it to use an external database. The second part of the Nitro is the Builder API. Builder is the part of the compatibility of Nitro that can actually build your application, bundle your user logic combined with the Nitro built-in logic, the features that it has, and make it ready for production deployment. When you want to deploy your Nitro application and you run a Nitro build or the framework command build, it bundles your server logic into the format using the configuration and deployment presets into an output format that is responsible for your deployment provider. It is powered by Rollup, by the way. And there is a development part. If you want to locally develop your application, quickly have iteration over it, you can use the development server. It provides an isolated dev server and worker, and a built-in bundler, which is also powered by Rollup, and we plan to replace it with Vite for even faster rebuilds, and it has the same experience of the production. Nitro has other features such as the built-in CLI that you can use it directly to develop server applications using Nitro. It has a pure render feature that can statically pre-render your routes during build for production. It has an extension kit that is under progress for Nitro version 3 that allows to even have more integrations to the core of Nitro without extending its core. Probably one of the main things that we was working on for Nitro version 3 and HTTP version 2 releases was the web standards compatibility. Since beginning, Nitro had web standards compatibility in mind, and it was designed to make your applications to be deployable on edge platforms such as Gulf Workers. But during the time, a few years ago, Node.js standard and Node.js servers was the dominant in basically all ecosystem. So instead of just trying to break everything, we tried to add a super powerful compatibility layer on top of the Node.js APIs and make sure that as much as possible, we can have NPM compatibility, existing libraries, make them compatible for deployment on edge platforms. Web standards are so much powerful and they are now getting more and more adopted. So we almost made 2 full rewrites of 2 major frameworks and 2 major parts of our ecosystem that make it possible that we have web standards as first-class support, yet still have Node.js, full Node.js support and performances. Here is how a traditional Node.js server application looks like. If you want to create a Node.js HTTP server, you have to define a request handler, which has 2 parts. When a HTTP request comes, Node.js gives you 2 objects, an incoming message and a server response. Inside this handler, you have to read any request information that you need from the request object, make some decisions, write some logic, and using REST object, you have to prepare a response, for example, set the response header, set the response and status code, and send the response body. It is all up to you, and it's simple and classic. Also, frameworks such as Express that are built on top of the Node.js server API have the same characteristics. With new runtimes such as Dino, Bon, and Clover Workers, they adopted something new, something that was based on new web standards, request and response objects. They are used also for Fetch API, and it makes the server definition simpler and different. In this new API, you only get a request object which contains the incoming HTTP request information in a different format. And inside the server handler, we have to prepare a response and return a new response instance instead of calling some functions on top of it. This format is simpler and used by newer runtimes. If we have a closer look at the differences of these 2 different handler formats, you can see there are 2 arguments. There's 1 argument. In Node.js, we have to handle everything ourselves. In web handlers, we have to return explicit and response object. And this new format has some major benefits that was worse for our ecosystem to migrate. First is the composability. Because the web handler format is explicit with the request as argument and the response as the return value of the function, we can easily compose this web handler as a function with other functions. We can add wrappers on top of it for interception. We can compose it to create a middleware system and other stuff. We can also compose it with other frameworks for compatibility because it's all explicit. It's also more observable. From a view of a runtime, what is handling and running inside this function is obscure. Runtime doesn't know if a request handler is async or sync. Runtime doesn't know if a request handler would probably throw an async error. For example, if you want to try to make an external call inside this handler. While in the newer format, because runtimes have to run the function and wait for a return value, they can explicitly observe it. They can explicitly handle errors within this function. And same for Nitro. We can do more better. This API is also more consistent. Why? Because if you want to make an HTTP call from a web browser or anywhere that supports Fetch API, you have to exactly create a request object using Fetch. And the return value of the Fetch is a response. And they are exactly the same interfaces that we have in our server side. So for full stack frameworks such as Nitro, it's making everything much more understandable because the same request object is on the server and the client. Same response object that we return on the server is also expected on the client. There are not much differences. And testability. Traditionally, if you want to test the Node.js handler, we have 2 ways. we have to either start actually a Node.js server on a port during the testing time, send HTTP requests to it, and wait for responses to test them. Or we could just mock these two different interfaces using another library. This is also what we used to use for Nitro as compatibility layer for Node by polyfilling and mocking the request and response. But with this new web handler format, things are much easier. Why? Because we can quickly and easily construct the request object, call the function, and test the response behavior. It makes testing also much faster and easier and more straightforward. H0 v2 is also being released and shipped alongside with Nitro version 3. You can learn more about H3 and latest updates from the official documentation. H0 v2 is 60%, even smaller than bundle size. It's 10 times faster for handling web responses, and probably these two measures are making H3 one of the fastest and smallest web frameworks on the web for modern web standards. And these are with no compromises. We have these benefits regardless of the runtime and regardless of how the complex routes are. It's possible with a complete rewrite of H3. Of course, we made sure that we have as much as possible backward compatibility, and there is a true migration guide inside the official documentation that you can follow if you're already using H3. H3 version 2 is fully based on web standards, yet it has first-class support for Node standards. In order to create an H3 v2, we rewrote the whole router and route matching library, a new library called Route3. It's also probably one of the smallest and fastest in all condition routers in the industry. H3 v2 has easier request body handling and more standard and more stable because it's based on the web standards. And we also have standard headers and URL right inside the event object. So accessing them and working with them is much more easier and familiar. In Nitro version 3, we tried to, instead of breaking behavior, focus on breaking changes that was required to make the core simpler, keep it simpler, more stable. So the bundle output size is much smaller now. We have more stability because we focused on the stability instead of introducing more features. The legacy polyfills that was previously required for fetch in Node.js less than 18 are now completely removed from the server bundle, which also makes it significantly smaller. We removed the feature called app config from the Nitro core because it was causing duplicate bundle size when combined with higher level frameworks such as Nuxt. So we removed this non-essential feature of Nitro. Internals such as legacy externals tracking system and plugin is removed to make the core also more maintainable and smaller. Nitro npm package, it used to be NitroPack, and thanks to Ujesh Germandi and Daniel Rowe, now we have a much shorter npm package. And using a mirroring system, we are going to use the new shorter version of Nitro as main package for Nitro version 3, and we mirror to the other package namespace. So if you are depending on NitroPack, you can keep using it, and you can also migrate to the new shorter one. In this new version of Nitro, version 3, we are now trying to experiment to see how much we can leverage from Nitro from Vite integration. Initially for Nitro, when we made Nitro for Nuxt 3 was using Vite, and we used Nitro for server builder part, and it was powered by Rollup, and it's kind of fast. But as more and more ecosystem is adopting Vite, and thanks to the new multi-environment API, we can now leverage more. So one of the first things that we are thinking about is creating a Vite plugin for Nitro. And you can use this Vite plugin to quickly integrate Nitro to your existing Vite setups without having major changes to your applications, and yet still leverage all of these features. We are also experimenting with Vite as an alternative builder for Rollup. All the internal buildings happen. So we refactor Rollup as a separate part in the code base. We prepared the code base to support Vite as first class. We are thinking to leverage Vite Environment API to make it possible to create full-stack applications just with a Nitro setup. We are also trying to push Vite Dev Server to leverage the web standards and replace legacy Connect API with something that is web compatible as part of the Servex project that is also powering H3. We also improved the Node.js compatibility for Edge. OnEnv is the compatible layer that we initially created for Nitro to make it possible to deploy Nitro applications on Edge. Now with the collaboration with Clover team, we have much better compatibility with version 2. Using hybrid native polyfills, we can leverage both polyfills and exactly for the exports and the features that have a native implementation, we can integrate them all from both sides. This version of OnEnv is now directly also integrated to Clover workers, so any Wrangler deployment can enable the Node.js compatibility and leverage OnEnv layer. This version of OnEnv has full Node.js module exports, so it's increasing the compatibility with the NPM ecosystem much more. And we are also focusing and working with Node.js team to improve the runtime support, so we actually backport and polyfill more features of Node inside your deployments. Thank you.
Hello, it's a pleasure to be here at ViteConf 2024, talking about magically optimizing your fonts. My name is Daniel Rowe. I am a full-time open source developer. I lead the Next core team. I am also part of a number of other projects like Nitro in the UnJS ecosystem, like Elk, which is a client for Mastodon, and some others as well, like Fontaine or Magic Regex. And you can check out a few of those on the screen. I also have a website, which is row.dev, and you can find out more about what I'm involved with and getting up to there, as well as find out my details to drop me a line. Feel free to message me if there's anything I can do to answer any questions you have as a result of this talk, or if you just want to talk about something else too, that's fine also. I'm based in Edinburgh in the UK. Although I'm not originally from here. This is my cat, Barley, who does her best to keep me from being productive, which is excellent. And this is her normal position. Right now, she's on the bed behind me and sleeping, and hopefully that will continue for the duration of this talk. So I could talk a little bit about Vite's philosophy, at least as far as I see it. And that will obviously be a partial picture. But one of the things I love about Vite is how polymorphic it is. Vite takes the position of, one, being very good for end users. So if someone just wants to build a project on Vite, it's a phenomenal experience. So you can get going with Vue, you can get going with React, and Vite makes that incredible. You don't need to be using a framework built on top of Vite at all. But Vite is also very much ideal for a framework author, for people who want to build on top of it. And I honestly think that's one of the things that's brought us all here today, that we have so many people from so many different frameworks and backgrounds and libraries all using and building on top of Vite. And the openness of the core team to that is what makes that possible. And honestly, I think there are lessons in general for a lack of egoism in open source that we could all draw from the Vite team. And for example, I could talk about how we were able to re-implement public asset loading in Nuxt as a result, in order to support a feature that we have in Nitro, which is the idea that you can have multiple public folders, each with their own rules for caching, each with their own rules for a base URL, and so on. And we were able to re-implement that fully, even though this is a feature that Vite provides public asset resolving. We might be able to port that upstream back to Vite if there's a desire for that. We're able to re-implement chunk loading errors and handle that at the framework level, working in collaboration with the Vite team, which is amazing. And we recently rebuilt our WebSocket handling to be able to share the same port for our dev server and Vite's WebSocket. And there are lots of things like that I could point to. And I could give a whole talk about that. But today I just want to pick one thing to talk about to showcase what Vite is able to enable us to do at Nuxt. And that is the challenge of web fonts. Now, if you might say that web fonts aren't challenging, it's simple. You just have to paste a couple of links into your index.html, or however you add head metadata in your website, and you're good to go. But it's not quite that simple. I mean, that's possible. You can make things a little bit better by downloading the fonts and putting them in your public directory, but it's not quite that simple. Here's one reason why. So I don't know if you spend some time optimizing your website with for your core web vitals, you should. And you'll notice that among those, largest contentful paint, interaction to next paint, those are key. But one of the things that web fonts particularly struggle with is cumulative layout shift. And that is because when you load the font, it can cause a readjustment of the layout of the site. And here are a couple of different ways that might look based on your font display choice. So if you have a blocking font, you will have the font come in later, maybe as soon as the font files have loaded, and that is definitely a big issue for last contentful paint. So you might not want to do that. You might want to do something like font display swap, which is default for Google Fonts, for example, and you'll get a behavior a little bit like this. So your font comes in, and then it swaps across to a different font, and that causes this sort of feeling of jank as the user looks at your website. And you might also say, well, let's rather than swapping, between Times New Roman and Poppins, let's actually provide a native fallback, something like sans serif or UI sans serif, and you can have a whole list. Tailwind has a good example, and you get something which feels a little bit better, but it's still this sort of movement on the screen. And this is probably as simple as it gets. This is not changing the number of lines, but you can actually find when there's a difference between your custom web font and your system font that actually the whole page changes, because 2 lines turns to 3, and that's multiplied across the whole page. And that's bad experience for users. They can't click a button because it moves around, and it just feels bad too. And you'll get worse performance scores as a result. And I mean, I could give that as an example of anything else. There's Open Sans, that's what that looks like. Maybe it's a bit better. You might pick something which is really similar to your site. Roboto, maybe quite similar, and it's not going to adjust quite so much. But that's requiring manual fine tuning. There are a number of solutions that people have adopted to try and solve this problem. So you can inline fonts as data URIs. It's actually bad. It's not cacheable. It really increases the initial load of your HTML. Can subset fonts. It's not scalable. You have to do that manually, and really only works for sort of headlines where they're not changing. Can preload fonts. It's not performant. You don't know what fonts will be used on any given page. You might end up having to preload lots and lots of different versions of the font for italics, bold, different languages. Again, they might not all be used, and it blocks your site, so it makes it slower in appearance to your users. And one of the things that we've jumped on is font metrics. So all credit here to Katie Hempenius, who's at Google. Do check her out. She's a great engineer. And her approach is basically to take certain characteristics of fonts and use those characteristics to calculate some CSS properties: size adjust, ascent override, descent override, and line gap override. And we can actually calculate those based on two fonts. So take the web font you want to display, and then take the system font that's going to display until it loads. And you can basically force one font to take up the same amount of space as the other. So this is a little bit of what we would do. That, for example, between Poppins and Arial, we could calculate these kind of ascent overrides, descent overrides. And you get something then that's like this. So that. So let's switch it off, try again. So this is what we would get natively, but with custom metrics, we can get something like this. So it does adjust, of course, they're different fonts, but barely. It's much less perceptible. Whereas again, this is the behavior if you're just swapping. So it's an immediate benefit, and it's just a few lines of CSS. So we were able to make that I was able to make that repeatable by taking this great idea, which wasn't mine, and building it on top of some metrics from an amazing project called Capsize, which actually exists to solve a slightly different problem in font CSS. But they made available metrics for all kinds of different fonts, Google fonts particularly. So taking the metrics from their project, we're able to wrap that in Unplugin. If you haven't come across it, it's a project by Anthony Fu, which makes it possible to easily write plugins that work in any bundler from Rollup to Vite to Webpack. And that whole thing meant we were basically able to inject into any CSS file the necessary fallbacks to make CSS with web fonts more performant. If you haven't come across it, check out Fontaine. So Fontaine is the result of this work, and it's a bundler agnostic tool that generates pure CSS, so it's build time only with zero runtime overhead, and it immediately improves web font performance on the cumulative layout shift by injecting those font metrics wherever your fonts are used. So that's usable today. There's another project that I'm just making open source today called Unifont, which is a way of accessing font provider APIs like Google Fonts, Font Source, and many others in an agnostic way from code. So rather than having to parse their responses or write custom handlers for these different providers, there's a single way to do it. And then, on top of these two open source projects, which can be used by anybody, we built Nuxt Fonts. So Nuxt Fonts aims to totally get rid of the pain of any kind of web font optimization. So you don't have to configure anything. It's privacy first, and it is performance optimized. And this is why. This is how it works. So you write some CSS. So this is a view file. And you can do this in your view file. You can do it using Tailwind, Uno CSS, or just a normal CSS file. It doesn't matter. But basically, when Nuxt Font spots that you have this font family in your CSS anywhere, it knows to do a couple of things. And here's what it does. First, it changes the declaration to add this special fallback font face, which is how we can automatically determine the metrics based approach I talked about earlier. And this uses Fontaine under the hood. Then in front of that usage, it injects a font face definition from any one of the providers. So it basically searches through the providers from Google to Font Source, so on. I think we have 7, and even a local provider. So if you stick a file called this in your public directory, it will find that too. It creates the font face declaration for you. It adds the Unicode range or the font weight or whatever else is required. It actually produces lots of these. So it gives you your italic version and your bold version and so on, and for different Unicode ranges as well. And it downloads the font from wherever it is located. So whether that's in Google or whether that's some other CDN or a custom font provider, and make sure it's in your project. It's cached, so it doesn't actually go into your Git repo, and you don't download it more than once, but it will be part of your build output. So it will go into your public folder when you build. And that means that there's no privacy concern because you're not heading a third party. You also don't have to pre-connect or connect to like a third-party origin. It's just part of your site. And for Nuxt users, they also benefit from caching. So if they're deploying to a CDN-based provider like Vercel or Netlify or Cloudflare Pages, it's cached as part of the CDN there, and it becomes incredibly fast. It's also handled like an asset in your Vite build, so you can get automatic preload behavior if that's what if that's what you want to have in your project. Again, I advise against preloading fonts because you might have a lot of font files and it's not turned on by default. But we also generate that fallback CSS that enables the font to load in without much shift. And we have quite a lot of interesting things on the roadmap, including support for different font weights and producing fallbacks that exactly match the weights of the fonts that you have, or even the ability to directly compute the specific letters used in key value propositions like a heading or something like that, and create something which is just ideally subsetted and targeted for that. Now, all of this is only possible because it's happening at build time, because it's deeply integrated with Vite, and we're able to see like what the user is using. We're able to take control of public assets and how they work. We're able to do things like fetch from public APIs using Unifont and download them. And the whole experience from a developer's point of view is pretty cool. So I'm really excited about that. Now, I'd love to show you what it's like to use as a user. So I fired up a Nuxt project here. We're all ready to go. Let's just start our dev server. And the experience, of course, with getting started with Nuxt is that you have a dev server running. You can do a lot of things through DevTools. So in this case, I'm going to go to my modules tab and install the Nuxt fonts module. So here we go. It's going to install it and add it to my Nuxt config file. And that's done. So I now have the fonts module, and I can switch. I have a DevTools tab, which I'll see some cool stuff with in a moment. But again, it gets going not because I interact with it, but just because I write some CSS. So this is what I might want to do. I might want to add a little line here, which says, hello, ViteConf. And we'll add a style. And we'll write I can write CSS. We'll write some stuff. So you might have color red or something like that. And that should be displaying in my browser. There we go, hello ViteConf. And now if I make some changes to that, like if I add font family, let's just add pop and say, boom. And what happens is in the browser, in the background, we have a request now to this hash that I talked about, which is the actual Poppins font. And that is being cached now in my local project. So it's in a cache folder. You can't see it in Node modules. And when I build my project, that's going to become part of the build. And that font file and some others as well will be added into the public folder. And it will be possible when you deploy it for those fonts to be part of your site. And all the rest that I talked about, the font fallbacks and so on, it's all happening in the background. So if I were to say, for example, that Poppins is my first choice, but maybe Arial is my second choice, then what's going to happen here is that the fallback is going to be calculated relative to Arial for me. So I could have a look actually at the generated CSS if you want to see that. And you can see all of this. The metrics are added, the normal font, the ones from Google Fonts are injected here, and the whole thing is wrapped up, ideally so that users don't have to spend any extra work making their websites performant and implementing web fonts. So there we go. A super brief overview of what it's possible to do with Vite. If you're interested, please do check out the docs on nuxt.com or fonts.nuxt.com. You can follow Nuxt on Twitter or Mastodon, or you could follow the other people on the Nuxt team, would be great. And we have a Discord server, chat.nuxt.com, so feel free to join and chat about any of this. And a final offer, if you do want to book 10 minutes of time to have a quick chat with me, I'd love that. If there's anything I can do to help you or help you get started in open source, particularly if this is something that's quite foreign to you, or you think, the people you see contributing to some of these projects don't really seem a lot like you, then I would love to tell you that you'd be really welcome. So do book a call. I'd love to talk. But it's been a real pleasure to be here today. So thank you for having me. And I'm really looking forward to some of the rest of the talks we have today. So all the best.
Hi, I'm Ryan Carniato, the creator of the JavaScript framework Solid.js. As always, I'm excited to be talking at ViteConf. It's one of my favorite talks of the year because it has a way of bringing all the communities together, which isn't unlike what I'm talking to you about today, which is our journey to bring the client and the server together. This is no easy task, as I'm sure you're all aware, and we've been trying to do this a number of ways the past several years. This has been a journey. It would be easy to mistake this as a return to the past, relearning the lessons from like PHP or Rails. And while there's a little bit of that, I wouldn't say that's been the defining characteristic. When JavaScript made its mass exodus from the server languages to establish its own identity, a lot of what doesn't work was discovered. There's a reason almost no JavaScript framework identifies as MVC anymore, etc. We return to the server, this time with purpose. In no way this is a new trend, but it's one that has taken a long time to mature. The cost of ambition, really. The scope of what we are all trying to accomplish has moved beyond what a simple renderer can accomplish. And since we aren't just satisfied with the past, it's insufficient to view the client and the server as separate things or repeat, other mistakes of the past. We needed to recognize the solution isn't one of these things, but all of these things. That's a lot when you consider the abstractions built on top of this as well. But building the abstractions isn't so much the problem, as much as understanding the boundaries underneath can shift with each of these new abstractions. Still, the way out is to consolidate the base primitives. Vite continues to be a source of that normalization. If not Vite itself, libraries very close to it in the ecosystem. Things like Nitro, which powers Nuxt, Analog, Solid's meta framework Solid Start, and the upcoming TanStack Start. And Vinci, which powers the latter two. It's another layer to handle the abstractions like server functions or server components and file system routing in a generic way. And with Vite 6's upcoming environment API, what might be the biggest reason for us creating Vinci in the first place is getting baked right into the core of Vite. So there's this cycle here. We needed these features before they ended up in Vite, but in the end we reach a place of consolidation. And trusting in that means that a whole bunch of things I don't need to worry about anymore. Which brings us to the present. Solid Start, Solid's meta framework, built on Vite, Vinci, and Nitro, has reached 1.0 as of May. I'm very happy about this, as it's a culmination of work of hundreds of developers, and honestly, most of the last 3 years of my life. It wasn't easy to get here, but I'm happy with the results, and that you've all been with us through this journey. First, when we leveraged Vite to introduce server functions to the world. That is the ability to create compiled typed RPC calls from annotated functions. This would power Solid's data fetching and action APIs, as well as become the means for server functions in Qwik and server actions in React. This slide was from that original talk a couple of years ago. We've changed the syntax over time. Now it's use server, but it's the exact same concept. And then again, when last year we presented the first routerless JavaScript framework, when we recognized that the router carried the opinions that could be isolated. This powered our client-only SPA mode or single-page app mode and opened up the door to other tools being used first-party inside Solid Start. It opened the door to bring your own file system router conventions as well, not to mention a baseline bundle size of just 4.7 kilobytes minified and gzipped. Unheard of, really, from a fully hydrating SSR JavaScript framework. Everything a la carte. But I want to stress that we got here sort of by necessity, not completely by choice. We set goals as to not alienate our growing ecosystem. Very important. And those constraints actually led to this innovation. But, that's been the last couple of years. You might be asking, what have we been up to this year? Well, it started with significant funding from the Chrome team. We hired on another full-time developer, Alexis, to explore improving the ways we build on the web. Our initial goal was to bring our movie app demo to the mainstream. It was basically our take on server components. That solved a lot of the problems that other server component solutions had not. Removing duplicated serialization, keeping the code size incredibly small, while maintaining that client-side routing. The demo had done so effectively, handling navigation and actions seamlessly. It was a fraction the size of other frameworks, including normal solid start, and outperformed them all. However, it was limited and had some really significant flaws. First of all, it didn't handle persistent state all that well, which could easily lead to hydration errors. It was pretty brittle, to say the least. And secondly, it wasn't designed to handle streaming async after the initial page render. Yes, it could handle async data, but it all came in as a single chunk instead of streaming it in. So we kind of started our exploration focusing on that second objective. Yep, it all leads to serialization. We needed a data format to handle async and nested async. We needed the ability to send data over the wire with the promise of resolving more data afterwards. We needed to be able to send HTML and have more HTML stream in the same way after we do that initial render. And, well, we identified a few other problems too. The main one was that in an SPA, data serialization is pretty straightforward. It more or less exists outside your app and ends up being appended as some large JSON blob. You've probably seen this next data blob before. It's pretty much omnipresent in our current server-rendered single-page app world. Remix data, Nux data, Svelte data, solid start data, so on. But with islands or client components, whatever you choose to call them, we need to serialize the props for each island. This has a benefit that not all the data needs to come to the browser. But because there are more entry points, and often, even if not all the data makes it to the browser, some nested part of it does, it might be shared across multiple islands. The combinatorics of how this is handled, if naive, could actually increase serialization overhead, sending the same data multiple times. And of course, this doesn't bring in async. What if certain islands are only available after other async data loads? We need to keep these serialization references across each flush. So I want to introduce you to Cerevel. This is Alexis's creation, the project that now powers all of Solid Start's serialization, right? And fortunately, Alexis made a little playground so that we can play with this. On the base level, I'm just going to return an object so you can see it, and you can just click serialize. And you can pretend like this side is the server and this side is the client as it gets the data. So we can serialize something, send it across, and we see that we have this kind of self-referencing object for deduplication. We get our greeting across. And what's kind of cool about this is I can take this object and just kind of show you, we could, return an array and have this object show up 3 times in it. Sorry. And what you're going to see is we send back the array, and the first one gets assigned to a reference here. And then we use the same reference for the second two. I mean, this isn't too tricky to visualize how this scales, but this is definitely very cool. We're able to serialize all sort of data shapes and essentially be able to have them spit out the other side. And this includes async. I actually had a little fun here playing around in this playground. What if I made a countdown, like recursive call? So essentially this is creates a promise with a timeout that until the number gets down to 0, it resolves another object, which gives you the current number, and then countdowns again. So I'm just putting promises and promises and promises and promises, and just start by returning the first countdown. So we're going to count down from 5. And when I serialize this, again, this is the server. You can pretend this is the client. What you're going to see is initially it sends commencing countdown, and then it'll send 5, and then 4, 3, 2, 1. Every second, blast off. It actually handles sending it each in pieces as it comes down automatically. Obviously, I could do something like change the delay, change the number. Let's try this again. You can watch it come down. 5, 3, see, and so on. So we can construct interesting async patterns of data, and as long as they get passed out, they can be serialized. Of course, doing promises like this is a little bit chunky. Cerevel supports async iterables, so we can make a promise and run it through an async generator function. And here he's this is the base example on their page. They have 1, 2, 3, 1, 2, 3 things as all iterators passing the object. And if we serialize, you're going to see the next functions being called on these iterables as the data comes in. And this is pretty powerful because async iterators and iterables are basically stream protocols. This is how you can do observables, readable streams. It just kind of built in that, but simply by having an async function or generator function, you can pass data as a stream from client to server. So I hope you're starting seeing the power of serialization here. So we got here and we continued our exploration into solving server components in a performant way, but we kept hitting more complexity. We found that in serializing props, we brought back the double data problem again. That is, everything currently being rendered gets serialized twice. Now in the HTML and as a prop. There are tricks to reverse template props out of rendered HTML, but even deciding what to serialize based on what is rendered initially is actually hard thanks to async. You could be needing to send part of a client island without even knowing if that prop will ever be used. Do you serialize it or don't you? Yeah, think about that one for a minute. Even after we came up with some clever solutions, bridging the data fetching story and mutation between server and client was still a mess. Our server components on a given page all rendered together, meaning every re-render, every mutation meant refetching all the data on that page. Suddenly, our baseline examples required blob storage and caches, which ends up making it specific to certain infrastructure. You know, if I want to deploy this on Cloudflare, do I use their KV? Or if I go to Netlify, you know, use their blob storage or Vercel. And this was kind of necessary with this architecture for it to be performant. We didn't have any of these concerns with our SSR single page app. All through this, I found myself doing more and more, simply just taking server functions with Cerevel to represent my data. So I thought, what if this was enough? If we weren't going to solve double data in a convenient way, if our framework is small enough to orchestrate loading assets on the client as needed, if we've already solved data loading waterfalls, if we had a means to run code only on the server, whether called there or in the client, what's the biggest issue left we face that would make something like server components valuable? Well, I only really came up with one thing, and that was single flight mutations. Wait, not this, this. Now, it might seem obvious that the first side, the multi-flight here, is a bunch of extra work. Right? We send an action down, get an acknowledgement, then validate or redirect, and then fetch the data. But client apps have kind of gone this way the last few years. No one wants to manually deal with cache management at application level. Not to mention, when the client is responsible for routing, it knows what data it needs for the next page. Sometimes we don't revalidate, we redirect. Sometimes we do a bit of both. So sure, it would be easy for some mutation to return a piece of data back when you update it, but applying that change and all downstream changes of a mutation can involve a lot of wiring. So we don't. We just rely on TanStack query or framework loaders, which, let's face it, make it a breeze to implement consistent APIs. But the old form post was single flight because it re-rendered the whole page, right? You posted your form and then got the HTML for the next page back. Server components are single flight for a similar reason. Can we keep our powerful granular APIs and do single flight? Yeah, of course we can. We have incredible knowledge when combined key-based revalidation with nested routing and hoisted data fetching. You could picture a simple social media site where you have a users page and maybe a feeds page. And under the users page, there might be posts and settings. Each of these route sections knows what data it needs. So if we were on if we had taken, user settings, like Ryan Solid settings, and navigated back to my post page, we could tell from this graph that we only need to fetch the new data for posts, and the rest of the data on the page is fine. And more than that, we can perform actions which can cause redirects and invalidate certain data on the page. For example, if a settings page updated the user's name and we realized we had to update the user profile, well, we could just via key say, hey, this needs to be refetched. So now it can say invalidate this and redirect back to posts on save. And it will know to fetch both pieces of data. It occurred to me while working on this problem that we had all that information at the time of action on the server before we even responded to the client. So if we know that and we have a super serializer, we could simply respond right away to tell the client to redirect while streaming back the promise of the data that we would otherwise need to fetch. We could literally, because it's separated, because it's hoisted, and because we know what route we're going to, we could start fetching that data on the server in the same request and have it come in all at the same time without changing the model. No need for that second request. Your DX would stay the same, yet doubling the response of every single mutation you do on the page. So we used that and made our own Trello board demo with this technology. I think a lot of you have seen this demo before. You can go in, you can add a card. Let's add third card. You can move cards around. Sorry, grab the thing. It's a fun little demo. And if we look at the network, what you're going to notice, first of all, is that when we do this install, start, and move stuff around, it's only one request. We don't do two. And the reason we can do that, again, is we have Cerevel here. This should look a little familiar, serializing the data we need for the next fetch. So everything can be single flight, right? And if I go in here and say, make the network really slow, now you can visually see here how long it's taking to resolve. There it goes. And obviously being single flight, that's already twice as fast as if we were doing two. But the optimistic updates here handle this pretty smoothly while we're waiting. So smoothly that we should be able to drag stuff around, drag it under, and have multiple things in flight if I can move fast enough, as you can see, and not have this concern with losing state of our app. Now, this is pretty powerful and pretty happy with the results of this demo and the work done by the community members who actually built this. But it's just an example of how these things layer together quite nicely. What's really cool about this example, which if you ever get a chance to check out the source code here in this repo, is that we basically can use our combination of optimistic updates and then have the information here to apply each update individually. Most libraries, when they do this, like with the v.omdiff, you have to take the existing board and every time you add a new mutation, merge it all together, diff it all. With the fine-grained approach we take here, what will happen is each mutation is applied independently. We don't have to merge them every time, only as they get added. So if I go in and rename this card, maybe we want to make it second card, we only actually apply the mutation of the specific text in the client while we're doing it. And then when the server comes back with the fresh data, and we do have to do that diff, well, nothing's changed. So in a sense, no components rerun at all in this process in what I just did. So combining the fastest approach in terms of single fetch with the fastest way to doing the least work in the browser. I'm very impressed with the work that the community did here. So what am I saying? I'm happy with where things are, but they're still evolving. Most of the content of this talk is technology we released actually 8 months ago, and we're already kind of on the next thing. But it's amazing to live in a time where we can so rapidly prototype out these ideas and explore different approaches. And having the tools available to accelerate this is what makes it all possible. That last demo has had a huge influence on how I view reactivity and the approaches we're taking Solid 2.0. So I'm very thankful to have this platform to build on. Very thankful to Vite and this community. If you like what you heard today, you can find all the resources offsolidjs.com. Find me on Twitter at Ryan Carniato. And if you really like nerding out on JavaScript frameworks, I stream weekly on YouTube and Twitch. Thank you.
Last year, Angular and React were effectively the same framework. I know, you might be thinking, this is ridiculous, makes no sense. Angular uses classes and templates, and React uses functions and TSX or JSX. How could that be even remotely true? Well, even though we use very different types of syntax in each one of these frameworks, under the hood, last year the frameworks used to function very similarly. And there was one thing that caused divergence between them that we're going to discuss today. My name is Miku Getchev. I'm the product lead for Angular at Google, where I'm also working on converging Angular with another internal framework called Wiz. You're going to learn about it in just a little bit. Today, I'm going to share with you how frameworks might be more similar under the hood that you would anticipate, and also you're going to learn on a couple of major trends in the front-end space. And I'm going to make a prediction on what we could be potentially converging next. So let's go back to Angular and React again. In both cases, we're going to develop our components with absolutely different types of syntax. In Angular, we're going to use classes and templates. In React, we're going to use functions and TSX if you're using modern React. From there on, the framework is going to take these components at runtime and build a component tree. And the framework is going to make sure that when the data in our application changes, it updates the view. That's exactly the part where Angular and React were actually very similar a year ago, until something happened. In both cases, we would somehow notify the framework that the state has changed. From there, the framework is going to traverse this entire component tree to figure out what has changed and reflect the changes in the view. Let us look at a very simple example. Here we have an Angular application using Angular syntax because, well, that's the framework I'm working on. So more familiar with its syntax. We have the app component that has the user profile component and a shopping cart component inside of it. In the user profile component, we just display the username. And in the shopping cart component, we just iterate over a list of items in a cart. And for each one of them, we display the quantity. That's it. From here, the framework is going to build the following component tree. We have the app component at the root. We have the user profile component on the left. And we have on the right, the shopping cart component. So let's suppose we update the first item in the shopping cart. In this case, the framework is first going to check whether anything changed in the root. After that, the framework is going to go to the left child and verify whether everything is still the same in the user profile component. And finally, it is going to go to the shopping cart component and figure out that the actual change that happened is actually only affecting this single component. In both change detection of Angular and reconciliation, the algorithm will be very much the same. So we perform 2 unnecessary visits of nodes just in order to verify that nothing really there changed. In both Angular and React, we can optimize that very much using the same approach, different syntax, but under the hood, the frameworks are using very much the same tree pruning algorithm. In Angular, we can use onPush, and in React, we can use memoization. When we specify in the cart that the quantity of the first item is 1, and we're using onPush or memoization, we could only visit the root component and the shopping cart component. So this way, we're going to skip one whole component subtree. In this case, the user profile component. But we still perform a necessary traversal. Now, if you're not convinced yet that Angular and React are more similar than they appear, or they were more similar than they appear, we can look at framework benchmarks. This here uses React hooks version 18 and Angular version 17. This was before Angular introduced its new control flow syntax, which significantly improved these benchmarks. In both cases, we can see that we have very much the same performance pattern here. Both frameworks are doing pretty poorly with swapping roles, and they have pretty fast partial updates. Now let's go back to our previous example here. We have this pretty small component tree. So in order to verify what's changed in it, we'll just have to traverse 3 components at most, which probably doesn't seem like a big deal, right? Whether we traverse 1 or 3 components, basically the same thing. But real-life applications are very different. We often have hundreds or even thousands of component instances on the page at a given point. So if we have to traverse every single one of these components, one by one, every time when the state might have changed, this could slow down significantly our apps. And it could cause some user experience regressions, which would be pretty unfortunate. We can start dropping frames and provide suboptimal user experience. That is why Angular started evaluating what can we change to remove all these redundant tree traversals. And that's exactly when we decided to adopt signals. Signals is this reactivity primitive that is used by Vue, Angular, Solid, Svelte, Ember, React, and others. React decided to adopt a slightly different approach. You might be thinking, yeah, the React compiler is doing the exact same thing. Well, the React compiler is an amazing engineering accomplishment. It is a really solid piece of software, but it does something else. Instead of being extremely precise about what might actually have changed, which it does really well as well, by the way, it also separates the view in static and dynamic parts, which is very similar to what the Angular compiler does as well. Of course, in the React compiler, you're going to get a couple of more benefits, which are going to reach good amounts of fine-grained reactivity, probably not as fine-grained as you would achieve with signals. With signals, you declare a signal, and you just read it in your template. And from here, just by reading the signal, we notify the framework where exactly this signal has been used, so that when you update the signal value, the framework can go to this exact component and this exact part of its component tree and update the value. Now, if we look at our more complicated example here with the hundreds of components, if we update the quantity of the first item, and this item here is a signal, instead of traversing the entire component tree, we'll just have to go to the individual components that have read the value of this quantity. And this way, we're going to prevent performing unnecessary traversals. That's pretty cool. Now you can see that signals, they gained significant traction in the JavaScript community. They've been also getting traction inside of Google. In Google, we have Angular and a framework called Wiz. Wiz is, you can think about it as Eleventy or Astro to an extent, or Qwik. In fact, Wiz invented resumability that Qwik adopted about 2 years ago. And Angular and Wiz have been used for different kinds of products. But overall, we noticed that developers using Angular, they wanted some of the performance features of Wiz, and developers using Wiz wanted some of the developer experience features of Angular. So that's how we started collaborating together. I was assigned to figure out how we can potentially converge these two frameworks into one. And I joined the leads group of Wiz. By looking at their chat one day, I noticed that they were working on supporting YouTube. That's the second biggest website in the world, in improving their user interface story. And they were planning to do that with signals. At the same time, though, Angular was already actively developing Angular signals and figuring out the Angular's reactivity story with signals. So I decided maybe here we can collaborate. And this is how we started using Angular signals in YouTube with Wiz. After YouTube started using Wiz with Angular signals, they noticed 35% better input latency on low-end devices compared to their previous legacy virtual DOM implementation. They also noticed 60 frames per second swiping on low-end devices in YouTube mobile web shorts compared to their previous jitter implementation. And they noticed significant increase of engagement as well. So seeing that signals were very successful in Angular and they're very successful in this converged story of Angular, we decided that potentially we could make them a thing in the broader JavaScript ecosystem. So we gathered together framework authors from Ember, Vue, Svelte, React, and other frameworks into the joint effort to make signals part of the JavaScript language. This has been pretty exciting because the reference implementation for signals originated from Angular signals because they proved to be scalable and also to be versatile, used by 2 frameworks already. Now, I know merging 2 frameworks sounds like a really big deal, and it actually is. I'm not aware of anyone who has done that in the past. But the way we think about it is just taking the best from each one of these frameworks into the other until they eventually converge. And we'll be doing that by seeking opportunities to open source primitives and share them as industry best practices. I'll say that that's exactly what we did with signals. By converging these 2 frameworks, we notice very similar concepts in all the frameworks out there. A lot of similarities in reactivity, authoring experience, event handling. Pretty much every single framework there has some version of dependency injection as well. And I know you're thinking, no way, React does not have dependency injection. Some people might be thinking also, no way, Angular does not have a context API. What if I tell you that Angular's dependency injection and React's context API are in fact serving very much the same purpose, and they have very much the same hierarchical structure? So frameworks are not that different, and there are a couple of deviations. One of them, as I mentioned, between Angular and React occurred thanks to the fine-grained reactivity that Angular implemented with signals. All right, converging to different frameworks sometimes can create concerns around stability. So this is something that we have been really heavily investing in Angular for a while now. Every single change that we do in Angular goes through a pull request, and we have over 27,000 pull requests to the Angular repository that we have handled so far. Most of them merged, the vast majority of them, I'll say. And each one of them goes through over 20 different checks. Of course, size regression tests. We have different tests for unit tests, end-to-end tests, different snapshot tests, and so much more. But probably the most impactful one that is extremely unique to Angular is the so-called Google internal tests, which means that every single change that we push to GitHub goes through internal tests. So all the hundreds of thousands of tests that are dependent on this change in Google are going to let us know if this change was backward compatible or not. If we break something, we need to fix it, which means a lot of pain for the Angular team. But at the same time, it means unmatched backwards compatibility. So this is what makes us very confident in the stability of Angular. Now, I would like to finish this talk with a prediction about another thing that frameworks will be converging on in the future. And in my opinion, this is event replay and fine-grained code loading. Now, in a traditional application, which is not optimized using client-side rendering only, the user is going to navigate to a URL. The server is going to respond with some HTML. There is going to be some reference CSS and JavaScript that the browser will have to download from the server. From there, we have to execute the JavaScript, and we're going to fetch some data, and finally, we're going to render something onto the screen. And this could take forever. There are optimized versions of this. We can add server-side rendering to, instead of just returning some basic HTML and having to render the initial version of the page after we fetch data, we can do that on the server and immediately push the rendered content. But we still have an interactivity gap. Since we render to the moment in which we execute the JavaScript and attach all the event listeners, there is nothing going on the page. Like, if the user starts interacting with the page, just there will not be event handlers to handle these events. And this interactivity gap, at Google, we have been handling it with something called event replay. So here is a very simple mock. When it is gray, this means that the page is just not interactive yet. When it is blue, means that the page has gotten interactive. See, when I start clicking on the Add to Cart button, nothing happens. But when the page becomes interactive, I get 4 items in my shopping cart. This happens because when we load the page, we load it with a very small, very thin layer of JavaScript that records events. And once we download the functionality responsible for handling these events, we just replay them. This is a feature, as I mentioned again, called Event Replay. It is available in Angular today, in developer preview for the next couple of weeks. We're going to graduate it to stable. And it is powered by an abstraction called Event Dispatch that has been used in Google search for over 10 years now. We modernized this version and we put it in the Angular repository. So if you're interested in what has been handling your events when searching things on Google, just head out to the Angular repository and find Event Dispatch. This collaboration between Angular and Wiz has been also leading to some inspiration. Now, Angular introduced this concept of deferrable views, which have great client-side semantics. We download code only when it is necessary. But in Wiz, we have resumability, which is a really powerful concept that enables us to lazily load code and download only the code that is responsible for handling certain user interaction. Now, very inspired by this concept of resumability and working closely with the Wiz team, we have been experimenting with something called incremental hydration. So when we send a request from the clients to the server and we get the rendered page, here we can have different deferred views or different incrementally hydratable regions on the page that have been specified with this defer block. When we load the application, none of this JavaScript is present, which means that we significantly reduce the total blocking time, and from there have better core web vitals. When we start interacting with a particular component, let's say in this case a navigation, we're going to download the JavaScript associated with this component and hydrate it, make it interactive, and replay the user event. Now, we have been exploring one more thing here. What if the site navigation uses a signal, modifies its value, and its value is used in another component, let's say in the top bar component? It is entirely possible to serialize the signals graph, and when we update a signal that is used somewhere in the top bar, hydrate the top bar as well and reflect the value. This is not part of the initial implementation, but we were very interested to see whether you have use cases for that and how important this feature is for you, so that we can consider implementation and add it to future versions of incremental hydration. All right, now I covered a lot of stuff here. I talked about reactivity, event handling, and dependency injection, and I haven't even scratched the surface. There is so much more in one web framework. But hopefully you saw that frameworks are very much converging on similar concepts. And Adius Mani shared in his JavaScript Meta Frameworks in 2024 talk at I/O that frameworks are often sharing also very similar features. Now I updated this chart a little bit to reflect my own views, but you can see that we have all of the frameworks being component-based. We have very similar server-side rendering support. We have pretty much shared reactivity story across most frameworks. So how do you even pick a framework? Well, when picking a framework, just don't overthink it. You end up using the same technology with just a different facade. But when I pick a framework for a production website that I know I'm going to maintain for the years to come, and my income depends on it, I'll usually pick a framework that is stable and reliable. A framework that has a supportive community and a rich ecosystem, and a framework that I enjoy using. That's everything I had for you today. Thank you very much for listening to my talk, and happy coding!
Building the next meta framework for Angular with Analog. Hi, my name is Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts. I tweet out GIFs, I talk about sports, I block people sometimes, but we have a good time there. You can also follow me on YouTube for web development and open source content. I am the creator of Analog.js, also a maintainer on the NGRX project, an Angular GDE and an X champion, which just means I've been around the community for a while. And I work as the engineering lead at OpenSauced. So for this talk, we're going to talk about Vite, of course, is ViteConf. Talk about Analog, and really quickly talk about contributing in the community. So for Vite, we are at ViteConf, and we know that there are many frameworks and meta frameworks out there that have adopted Vite. And by the time you see this video, there may even be another one announced that has built on top of Vite and continues to thrive there. Also wanted to announce that since last ViteConf, Analog has gone 1.0, and we're even up to version 1.8 now and continuing to build out the meta framework and push forward. But the biggest question that we've gotten along the way is, how did we get here? Why does Analog exist? Angular is a framework with SSR already. And so I usually can sum this up in pretty much one word, and it's spite. But seriously, Angular is pretty great also, and we wanted to extend the Angular ecosystem to other places and tools. So Analog is a big part of that. So we use a few things here to kind of build out this vision of building a full stack solution for Angular. Of course, Vite is there as a foundational piece. There's also Nitro, which I'll get into later, and NX. So on the Angular side, Angular has progressed in many ways that allowed a project like Analog to be created with building blocks such as standalone components, which are becoming the default in the future of Angular. Building it with ESBuild, even better support for ESM, and even the Angular framework itself with its SSR story is continuing to improve there. When we started this, it was an integration with Angular and Vite through the Vite plugin for Angular. This allowed us to do things like dynamic imports, where we could import things like Markdown or even just files for file system-based routing, and use the Markdown plugin to generate content from there. There's also Nitro, which is a server toolkit maintained by the Node.js org. And we build on top of what Nitro does to allow things like pre-rendering, supporting different deployment targets, API routes, and extensibility. Because I mentioned before that Nitro and Vite kind of build into this story of a common ecosystem that many frameworks can share. There's also NX, which has generators for applications, and routes. It also has executors that use more native commands and can build on top of each native toolchain and even retest, and can automate migrations for things like upgrades and presets that allow you to generate an analog application that's already pre-configured. So some of the features that we've built out over this time was file system-based routing. We've included server-side rendering and improvements there, static site generation, API routes, and even server-only data fetching. So Analog does have a file system-based router where you can do static routes, you can do dynamic routes, you can even group routes with parentheses that don't impact the URL, or even catch-all routes. And these are built on the structure of your file system to allow to build these pages out pretty quickly. As I mentioned before, there's server-side rendering with ngserve, or if you want to use Vite directly, you can do that. Server-side rendering is enabled by default. And we support different platforms such as Node, Edge, and many different deployment providers. A few of the common ones such as Firebase and Netlify, Vercel, and Cloudflare, or even more providers like Xerox. There's also static site generation, where you use ngbuild, and you can set up an array of routes to pre-render. And this supports content routes as well as just dynamic routes within the application itself. For API routes, these are popular in frameworks like Express and Nest.js, where you can define these routes to go along with your application. But here we have these built in using the file system-based syntax also. Here is an example of a source server routes products route on the API, and that's expressed as API/API/products. There's also server-side data fetching, which you can place these routes alongside your page routes and define these endpoints to fetch data on the server and do other common tasks that you're doing with full stack frameworks. So in this case, I'm defining a load function that can take parameters or query parameters in the request, and you would process your server data there, which could include environment variables, and return some serializable data there. And we also glue these together on the front end where you can inject this data into your component, whether it be connecting through component input bindings with the Angular router, or converted this to a signal. All this is integrated into Analog with server-side data fetching. So these are some of the things, some of the features that are in Analog today and helped us build out this solution on top of Vite and Nitro. But the question usually a lot of times comes up is what's next? We've gotten this far, and where are we going from here? So Angular and Analog are together in this and about pushing these ecosystems forward and moving into other ecosystems also. So with Angular, Analog, and Vite, we are, like I said, integrating with these other ecosystems and continuing to expand the available tools in these ecosystems. Whether this be Vitest, which we'll talk about in a minute, Storybook, Astro, Qwik, or Playwright. So Vitest, which I'm sure you've heard about during the conference, is a testing framework built on top of Vite. It has a JS-compatible API. It supports snapshot tests, and most recently made a big improvement to the browser testing offering that they have. And with the integration with Analog, we have you can use this with existing Angular applications, and even migrate them to Vitest depending on what you're using there. So to try this out, if you have an existing project, you can install the analog.js/platform package, and you can run the schematic to generate the setup for Vitest against the project. And as I mentioned before, if you're using existing testing APIs, there may be some migrations there, but this will at least get you there up and running to try out Vitest against their existing project or even a new project. There's also Playwright, which is an EDE testing framework. They have had component testing around for a while, but it's also looking to incorporate Angular components into that component testing story. And that happens through the analog plugin, Vite plugin for Angular. So as you can see, the Vite plugin kind of serves as the foundation for a lot of these projects and integrations that we're moving towards with. There's also Storybook. Storybook is a front-end workshop where you can use to build these components and build these components in isolation. And it has integrations with Vite and Vitest. So like I mentioned before, Vite is powering just about every tool that's out there these days. And Storybook is no different in that they integrate well with it. And we can extend this to Angular projects. There's also some experimental parts that we're moving forward with analog also. One of those things is the analog SFC. And this is something that we've been building out in analog itself that has built on top of some of the things that are available in Vite using Vite's transform pipeline. And this allowed us to kind of reimagine what an Angular component looks like in the context of authoring. So here we have a look at a traditional Angular component, and we wanted to look at a different way to author this component, but still achieve the same behavior as it is today. So this is what the analog SFC looks like. You can also try this out today in an analog project. Like I said, still experimental, but we are making some great progress there and looking forward to more feedback there. Also, things that are happening with analog, we're looking into things such as form actions, server-only components, and really focusing on building out a full stack framework with analog and continue these integrations. So with form actions, we are looking to bring the server and client closer together, which makes things more seamless if you want to incorporate the server into your application. And form actions is an example of that. Here's an example where I'm using a form that's progressively enhanced using the form action directive, and it's will be connected to an endpoint on the server where you can process the data from this form on the server and return data back to a client. In this case, it's just a newsletter form where you can sign up with an email. And then on the server, you can define an action in your server.ts file to process that action and return some data back to the client, whether it be a failure or a redirect or even just a successful JSON. So those are some of the things we're looking forward to building out in the future with analog. Lastly, I did want to talk about community because we wouldn't be here without the community and contributors that we've had so far. We've had over 100 plus contributors in analog, made it to over 2,000 stars on GitHub, accepted into the first GitHub accelerator cohort, have a growing Discord community, and you can follow Analog.js on Twitter to see what else is going on there. You can also try out analog directly on StackBlitz. If you want to try out a new analog project, you can go to analog.js.org/new, and it'll spin up an analog project directly in StackBlitz that you can play around with. So to recap, we talked about Vite and its impact on the ecosystem. Talked about analog, how we got here, where we're going next, and how people can get involved in contributing to the project. And I hope you enjoy the rest of ViteConf, and I hope to see you around soon.
Hey ViteConf, I'm Ben Holmes, and I'm here to talk about local first apps. This is a new buzzword you may not... Oh shoot, I'm getting a phone call. Let me click on this. Whiteboard guy?
Hey!
Yeah, what's up? How's it going?
What's up? I'm on my Islands architecture vacation.
Yeah, it looks like you're getting a lot of sun out there.
Thanks. Yeah, and I see you're giving a talk.
Yeah.
But like, come on, slides? You can do better than that. Let me say something.
All right. Okay, yeah, go ahead and send me... Oh, you have Discord. Okay. Well, let me just download that. Yeah.
Check it out. And best of luck on the talk.
Yeah, take it easy, man.
Subscribe to my YouTube.
Crazy guy. Never lets me do what I want to do. Well, all right, no more slides. Let's go ahead and see what this repository is. And okay, yeah, we're working with VS Code here. We've got just an index Astro, starting from the HTML document, keeping it simple. And we have, all right, we have a search bar. We have a SQLite file. Okay, we might be working with local apps. And down here, we have a script tag where we're just initializing a database. Did he get this backwards? Is this supposed to go on the server? Why are we doing a database on the client? Okay, let me click into this. I see we're using Drizzle, so that works in the client apparently. Today I learned. We're also using SQL Local. I've heard of this before. I was just looking at it. This is a way to set up SQLite in the browser. And it's using the Origin private file system to store it in your browser across sessions. And it's not as scary as it sounds. This is a file system that Google Chrome keeps track of for you, or Firefox or whatever. So you don't have to ask for someone's downloads folder. You can just store files on their behalf. Really cool. And we're just taking this database from the tutorial and we're creating a new one inside of here. Then we're creating a new table. So we're working with documents. So it's probably like a document store, title, text, vector. So maybe LLM related, I don't know. Then down here, we have a migration file to create that table if it doesn't exist in your browser. Okay, sounds simple. And we're also keeping track of whatever ID you're looking at with the hash. So if you say like hash1 at the end of a URL, we want to take that and use it as the ID to go look up the document in the database. Let's implement looking up a document in a database. So we can create a document, we can go to DB, select from docs, and we can say where, yeah, something like that, Copilot. We'll look for the docs ID, and if they're equal, we'll take that document, display it to the user. And otherwise, it means we just don't have a document in the database. So let's insert a new one with the title untitled and redirect you to that new document instead. Then to display it to people, yeah, we'll use the title and text. These are two elements that are selected at the top right here by ID. And that's it. So now if we go back to our dev server, which I think I have running, I do. Okay, so this creates a new document, redirects me to the ID, and I can type stuff. But if I refresh, we're not able to see those changes. Makes sense, we're not actually persisting those updates. So let's add a few more clauses in here. We'll take that title input, and Copilot's way ahead of me, of course, but we'll take that title, we'll look for inputs, and we'll set the text content to whatever that text is. And we'll do the exact same thing for this guy. Whenever you input body text, we'll update the document store as well. If it's empty or something, we probably want to handle that as well. Beauty of type safety, you always get things checked. Head back over here, let's adjust this, my first post. Refresh, there it is. My content, refresh, there it is. Okay, so now we have a basic document editor in one file of JavaScript. Kind of crazy. But I'm not really creative enough to come up with a whole bunch of documents since we want to implement search. So let's just figure out uploading a SQLite file into the browser. Should help with debugging as well. So I'm hoping Whiteboard Guy gave us a little alias to work with. He sure did. Okay, so this is gonna take that file input and let us upload that file into the file system. So this is the low-level API in the browser. We're not importing anything to go to that file and write to it. And this works just like writing a file in Node. You can iterate over like a stream of chunks coming from wherever. You can write it to that database and then reload the window. So we're going to go ahead and do that. I think Whiteboard Guy gave us an example database. Yes, so in this repository, we have data/example. You can do so as well when you try out the repository at home. If we upload that, boom, now all of a sudden we have a document store and we're looking at Laravel. Well, that's really not my favorite one. Let's see what's at position 3. Okay, this is the good stuff. All right, try out Astro build today. That's the good one. Okay, so I think we have like 3 or 4 documents in here. Yeah, we have something about RSCs. Document 1 is this. Cool. But we can't find these easily. I don't want to type a hash. I want to implement like a search bar. And I think there's the bones of a search bar if I scroll up here. Yeah, okay, we have a dialog element. And this is a native element in the browser to just make a pop-up with all the keyboard accessibility. Love that. So let's implement the JavaScript to expose this dialog whenever you click on the button that we have at the top, this search button. Let's start by selecting all of those search elements, and we'll set up this trigger to display the dialog. I'll just add it wherever. Search trigger, click, add event listener, and that will show the modal. Again, browser native, love it. And it manages focus state for us, so we don't even need that. And we head back over here, we can see, boom, search pops up right for us. And you know what, let's make it a little bit fancier, because people are saying you need framer motion in order to make search dialogues look good. Well, let me show you what a view transition can do. This is just using browser native view transitions if they're available. Otherwise, just show it. We can see right now, boom, beautiful fade. And we could add CSS to make this as fancy as we want to, but I'm pretty happy with that fade. Let's implement the search though. Let's not get distracted. I'll set up our search input right here, add event listener for inputs. Our query comes from the search value, and our results come from a basic text search, and we'll implement that here. Down at the bottom, we have text search set up, and it looks like Whiteboard Guy just said, let's use the like operator. I agree. You can set up search tables, but you know, we only have 15 minutes. Let's make it simple. We'll select from the docs and yeah, use the like operator from Drizzle to select anything that has the query somewhere inside of, let's say, the title, just to keep it simple. Now let's display those results to the user. Again, we're just using HTML, empty it out, and render some list items with the ID in the title. Last, let's collapse the dialog whenever that changes. You can listen for changes on a route with just hash change. And we'll add a little view transition sauce every time you navigate around. Love a little sauce. We'll say search dialog.close so that we can display the new item. All right, so let's search inside of here. And yeah, look at that. So it's searching for Astro, Laravel, RSCs. Click on an item, beautiful transition. Okay, so now we have full document search. But I'm not super satisfied with this because, yeah, it works for basic search. But what if you're searching for something kind of similar? Like, I remember Astro's a really awesome framework that I should use, but what was it called again? Is it called Spaceman? No, that's not it. It's called Comet, Meteor. Oh, it's Astro. Okay, there it is. So you can get there, but you can imagine if you can't quite get the words for it, we want to surface results that are similar to whatever the search query was, and not just fuzzy search, actually using an LLM to figure out what the similar items are. And I saw Whiteboard Guy hinting at it with this universal sentence encoder. This is coming from TensorFlow, which is an LLM that Google created to perform similar text search. You can use it for all sorts of things, but the sentence encoder will serve our purposes. And to boot it up, you can just load directly from the registry. Okay, Whiteboard Guy couldn't figure out how to get Vite working, so we're just going to load it from the third party, but if you can figure it out, definitely do so. And we can boot up the model just by calling the load function. This is available on a global object, and once the model's loaded, we'll place it into that variable and initialize some things in a moment. I'll show you the network activity for this. Since we're loading a pretty large model, you're going to see quite a lot of activity down here as it loads all of these shards and gets you 36 megabytes of LLM goodness. As you can imagine, that's a lot of data, so make sure you load it asynchronously, maybe in a web worker, and have some sort of progressive enhancement so people can use your website while it loads. And we'll implement all of that here. We're going to iterate over all of our elements and look for the ones that don't have a vector assigned yet. And for each of them, we'll run our LLM across the text. So we'll take our vector, we'll create an embedding from the title here, and an embedding is converting a string of text into a sequence of numbers that an LM can use to decide how similar 2 bits of text are. And we can store this directly back into our database. Placing the vector directly in there, and I set up a nice adapter to convert an array of data into a blob so SQLite is happy. With those vectors populated, we can implement a search algorithm. We'll start by checking if the model even exists, and if it does, we'll create another one of those embeddings. This is taking your search query and also converting it to a sequence of numbers to see how similar the two are. Then we'll query for all of the data inside of our database because we're not running vector search inside of the database, we're running it in memory. So yes, this could be an expensive operation, but it's a small database, we can do it for now. And we'll iterate over all those and compute similarities. And this is going to get into a bit of mathematics. So we have this cosine similarity function that's going to compute how similar two vectors are. And since it's a cosine, we're looking at values between 1 and -1. So 1 means things are super similar, 0 means they're not similar at all, or orthogonal if you've heard that before, and -1 means they're polar opposites. We also want to handle when there's not a vector and just say it's not similar at all. Now we're ready to wire up this search. So you remember earlier we had our text search implemented. Let's add a little progressive enhancement. So if AI has booted up, let's use a vector search to make things super awesome. And if AI is still loading, we'll fall back to text search, no harm done. Heading back to the browser, you can see our beautiful LLM is booting up. And if we look at our search results, you can see things are actually loading from an LLM. Things are even resorting themselves as I type. Very cool. Let me add a little bit of feedback so you know what we're working with as well. This will log out that similarity number. So you can see if we type the perfect string, it's going to be 1, super similar. But if we type something kind of close like spaceman, Astro still comes up. Look at that. We could type like authentication, and that should bring up like backend and Laravel. And if we type, I don't know, Lambo, that should bring Laravel. Okay. All right. Astro developers getting Lambos. We like that. Laravel, you're at number 2. You got to keep up, according to Google. Okay, so in all honesty, it's only as good as the dictionary you give it. So if you have internet humor to match results, it's not going to be perfect. But if you're looking for synonyms, it's the best thesaurus that you can find. So that's really the whole demo. We put SQLite in the browser, we put AI in the browser, and I'll leave you with this parting thought of how far things can go. You can actually load entire AI chatbots and models in the browser too. I was trying out Gemma the other day, which is like Gemini Mini, and it's a 2 GB model. Like, we're going way beyond the bounds of what you should probably put in the browser, but it's pretty promising that you can get comparable performance to a real engine, all running on your computer without having to contact a third party or pay for their bills. So really excited for this on-device compute future that we're leaning towards. And Astro is the perfect place to try it. You can use whatever component framework you want. You can write one big script tag and just run with view transitions like I did here. Also clone the repo to go on your own adventures with it. With that, enjoy the rest of ViteConf.
We made it! Woo! 1. Did you figure out why my tests are failing?
Almost got it. And just One, it's working on my computer. How come it's not working in production?
Safari. One, how can I scroll lock in Safari without the keyboard going crazy when I focus?
Just feel like things have gotten so complex. I sort of miss Rails.
Do you ever think we'll get that again?
I don't know, but check this out.
What is this?
Ask it any coding question.
Okay. What's better, Drizzle or Prisma?
Look,
Whoa, no way.
here, watch this. What do you think of server components?
All right, so one is not a new AI coding assistant, but what one is a new React framework. And you may be thinking, we don't need more of either of those things. But one does two things differently. First, it makes Vite able to serve React Native and web at the same time with seamless file system routing across server, client, and static pages, all while hot reloading on native and web at the same time. The second thing that one does is it makes local first a first-class citizen. We're working with the team behind Zero to integrate it as the default but ejectable solution to data. We think that it makes for the first time that you can actually share code across web and native apps without downsides. Let's take a look.
All right, I am so excited to be showing you guys one today. Our team has been working super hard on it, and it's really been coming together over the last few months. So I'm gonna go ahead and get started. You can create a one app as simply as npx1, and I'll go ahead and just choose all of the defaults for our create flow here, just so we can get going. And we'll use bun so that things are nice and fast. And now that our app is created, we can go ahead and cd in, and then give it a run. All right, and it's as simple as that. We can pop this thing open, and let's open it up in Chrome. And so what you'll see is we've just put together a little social network demo. And I think as with any Vite app, the first thing you kind of want to take a look at is the Vite config. So let's go ahead and open that up. And I think the main thing to note here is just that one is just a Vite plugin, and it's as simple as that. It works with your Vite plugins. We're using our tsconfig paths, so we have nice import paths. And there's just a few things going on here. We have our zero true. This is the default. You can turn it off, but when you turn it on, it just does a few things to optimize zero even further. We also are setting our default render mode here to be SPA, like single page app. And this is one of the features that's unique to one that I think is probably one of the cooler things, and it's never been really done before, which is that you can, on a per route or on a global fallback level, you can configure your app to route across 3 different modes as of today: server-side rendered, statically generated at build time, or you can also have it just be a client-side app. And this works with everything. Our typed file system routing and everything all works across that. So you don't have to actually bail out of your file system routing to do this. One thing that we realized when sort of like building one is that when you're building a native app, it's very much like a SPA. But on the web, you sort of have these different worlds. A lot of times you have maybe like a logged in page or a dashboard or internal tools or something like that are much more like SPA-like apps, and they're much easier to build if you don't have to worry so much about the server. But at the same time, you always have these marketing pages or SEO sensitive pages or pages that you just want to load really fast on the first request. This is the first time you can really share code, not just from native and web, but also from app-like websites to more, website or static-like web pages. I think we can go ahead and dive in now. You can see our file system routes here. We've got our layout. This one is just setting up a few things. I don't think there's too much here that's too interesting. I mean, we've got our color scheme provider, for light and dark mode. We can import CSS. We can diverge as much as we want within these layouts, and you'll see more on that in a bit. We are providing Zero. We are providing Tamagui. One thing that I want to talk about with Tamagui just very, very quickly is that Tamagui really gives you all those web features you're used to. I mean, you're talking about, very advanced, like, children styling, you're talking about container queries, you're talking about advanced media queries. Like it really gives you all of that. And the optimizing compiler works right out of the box with one. It gives you, optimized CSS that's output completely statically. It can actually flatten your entire page. So basically, I think Tamagui really solves this problem deeply between sharing code, not just, again, between native and web, but also between apps and websites. And we can go ahead and take a look at our homepage here, our index page. And one thing you'll notice right off the bat is that we're doing plus SSG. And so this is how you opt in, like I mentioned, into the render modes for each page. And in this case, we're doing a statically generated page. So this is at build time when you're building for production. You'll actually get this to be HTML. You can serve it from your CDN, and it'll still be very SEO it'll be very SEO optimized, I guess SEO optimized, and it'll be rendered fully like that. And so we can take a look. Actually, let's prove it. I guess we can grab this piece of text here from the page and search it, and you can see that it's rendered into the HTML. It's rendered as one giant single line string from React, but it is there. And if I refresh the page there really quickly, there is absolutely no flickering. And that gets to our next point, which is that the zero integration with one is really nice. And we've spent a lot of time getting this just right so that there's no waterfalls. Everything's loaded very performantly. And we've got our zero query here. This one's a very simple one. We're doing a limit on our posts, and then we're nesting this subquery, and we'll show more on that in a second. But what I just wanted to touch on really quickly is that the server handoff here is really nice. Actually, even when you do have nested use queries going down your tree, what one is doing is it's actually capturing all those queries on the server side, serializing them all into a format that we understand. And then on the client side, it's actually then handing off. So on the first load on client, it's going to use that server rendered data. It's going to wait for zero to sync, and then zero is going to go ahead and hand it off. And zero is actually very smart. This is one of the coolest features about zero, is that it actually syncs exactly what it needs to begin with. Rather than syncing everything, zero is very smart, and it just syncs what it needs. So not only is the first load extremely fast thanks to one, but the handoff is also very fast thanks to zero. All right, let's continue. So we've got our layout here, and we can go ahead and click in to log in. And I think this is probably well past the time for us to go ahead and prove that one does work on native. And so we'll go ahead and load it up here. One thing to note is that one is using SWC, which SWC is lightning fast. This is actually there's no babble going on here. So this is a significant speed up, and it's been really actually awesome. It's been a lot of work to get that to work seamlessly across the wide ecosystem of React Native libraries. And we've got our index page here, and we can go ahead and just click into the actual logged in page. And so one thing you'll notice right off the bat, I think, is that these layouts look completely different. And that is one of the strong parts of React Native, and it fully works in one and with Vite. And that is that you can fork your layouts. You can fork any file actually just by using platform extensions. Here we're using .native, and you can see we're rendering some tabs. And that's how we're controlling these tabs down here and sort of giving them icons, giving them different colors and all that stuff. And then we're actually also on the web doing something completely different. And so that's this layout here. And you can actually do .iOS, you can do .android, you can do .web. In this case, .native targets both iOS and Android. So we get to use that nice abstraction where it is rendering to a native, tab style view on native apps. And then on the web, we've got our web layout now. We did a little bit of responsive design here. Oh, and we also have a touch layout that we've diverged from. So I'll show that really quickly here. Okay. Oh, opening Siri. Well, let's go ahead and pop open our mobile Safari, and then we can go ahead and load this. And all I wanted to show here is just that you have this really deep control, and we're just doing a touchable Boolean, but we could have done this with a fancy media query and made this extremely performant. But just because these layouts are so different, I just figured let's keep it simple and write them separately. And so that's basically that. Just wanted to show how basically flexible we are in terms of controlling the look and feel of your applications. So we can go back to our native app here, and we can look into our feed view, and we're nesting here. One thing to note is that this authenticated group, this is a group basically, which is in parentheses. It lets you do multiple layouts. You can see that we have this layout at the root, but then we have another layout. And so we're actually just we're basically giving a lot of control into how your app looks and feels and renders. And then we can go ahead and click into here at our feed. So this is the feed that we're looking at right here. And I think it's probably just interesting to start poking into zero a little bit and talking about what zero is bringing us and what we're doing to optimize it. I already alluded to the fact that it is preloaded from the server on server rendered pages. But another thing that you'll see is that we are actually nesting this query here. And that's because we have come up with a method that's a lot like relay to allow you to have basically a relay fragment, or to allow you to co-locate your queries for data where they're actually used, and to decouple your components so that they're not tied to the data exactly, and you can actually render them outside of the tree or in different places. And so let's take a look at how this feed card works. You can see we're rendering a feed card here, and we're using the feed card query that's also exported from it. And the pattern that I'm showing here as we open up our feed card is the simplest thing that we can come up with that still gives you this really nice, it gives you nice composability, but it also gives you great performance, but it also is just it's very easy to demo. And we're sort of working with the Zero team. We worked with them to come up with this pattern, but we think there's even a further pattern that could make it even better in terms of allowing your types and queries to be linked together a little bit more tightly. But I really like this one because of how easy it is to understand. You can see our feed card here. It takes an ID, and then we've got this param. And all param is, it's very, very simple. It's either a string, so you can just give this feed card a string basically, or it's a reference to a string that the Zero query lets you chain. And if you look here back at our index page, you can see what we're doing is we're calling .sub, and then we're calling feed card query, and we're passing it this param ID, param string, which is a ID, which is a param string. And all this is building essentially a join. Like, this Zero just runs on Postgres. That's one of the great things about it. It runs with your existing schema. It doesn't require any special, change to that. It actually reacts to your Postgres changes directly, which is amazing. And so I think this is like some of the big barriers to local first are just being knocked down by Zero, and that's why we're so excited about it. But another big one is that it lets you do these nested subqueries, which give you basically joins. And so this is how we avoid waterfalls. We're actually fetching this entire query up front. But at the same time, we're also able to just use this feed card independently. If you wanted to test it or use it with Storybook, again, it can just render like that with just an ID. And so it gives you both. And that's why that param there is the only thing you really need to understand. And once you understand that, you've got everything you need. You've got great types and you've got great nesting and composability here. So I just wanted to show that, we've got our little refresh control here. We've got a few other tabs. We made it just, simple profile and notifications tab and screens. But, nothing too crazy going on there. I think one thing that you will see with the notifications is, well, this is a legacy. I had it as SPA. We switched everything to SPA, so everything is a SPA now. But I just wanted to very quickly show loaders. Loaders, we adopted a very similar pattern from Remix. This is actually when we converted the Tamagui website over to one, which has been running in production for quite a while now, tamagui.dev. The loader pattern was essential for us to be able to port it very easily from Next.js. And actually, we found our code to be very, very clean after the port. It works the same way. It tree shakes out. It lets you just, here we're using Drizzle as an example, but we're doing some very advanced, querying, and then you pass it down here, and you actually get fully typed loaders as well, because we changed this to be just a little bit different here. But just wanted to show that very quickly, show that, migrating over to one is actually quite nice if you're coming from something like a Remix or Next.js. And let's go ahead and click into our feed card now. So we can go ahead and look at it. As you can see, things are super fast thanks to Zero. And one thing that I haven't really shown yet, which I just realized, is I haven't done HMR. And, I think it's actually, this one is really nice to show. If we go back to our feed page, it's just kind of cool to show not only that Zero gives you these nice types here, but, oh yeah, show them side by side, huh? But you can see, if I change this back and forth, it HMRs instantly. And not only that, but just works, with your queries. And so we'll go back in here and we'll go back to our ID page. And there's not much to show here. I think what I wanted to show is one is that the layout, once again, is diverging. You can see we get this really nice native layout on native. It's a stack. We're just doing a simpler form here. You don't have to do platform extensions if you don't want to. It's a very simple screen here that we're doing this layout. And then we're just using this for this ID page. We're just rendering it out here. And I think there's one thing that's kind of cool to show here, which is this typed route helpers that we have. So everything is typed in one. The file system routes are scanned for types. In fact, if we go back to our SSG page, I can show you really quickly the link here. And if I just go ahead and edit that, you can see that, I've got my feed, I've got my profile. So you get type checking across all of that, which is really nice. And you also get these type helpers. We're actually thinking about maybe even automating this even further, but by just grabbing this route.feed.id, and you can grab your use params here. You can also create your loader if you wanted to have a loader that's nicely typed. But I just want to show how nicely this all composes. We've got our ID, which our param ID, so that we can nest this if we'd like. We're doing subqueries here, which is really nice, and we're just calling it with use query, and it just works now. So I think for sort of the grand finale here, we want to show, of course, mutations and optimistic mutations, which Zero gives us for free. No glue code. You don't have to do a hook and add a bunch of logic. You don't have to worry about anything. We've got our feed cards going on here. We've got our reply box, and I can just go ahead and on native say hello from ViteConf and hit reply, and it shows up absolutely instantly. In fact, because it's local first, on the very next frame, you're going to get this update on this side, and then of course as soon as it syncs. Another thing that Zero does that's amazing is that the sync engine is granular. It's not rerunning all of your queries in order to sync on the client or on the server, and this is huge. I don't think any other local first library is doing this that I know of. So we can say aloha and send it right back. And so there you go. With almost no code, this is literally just one query here. And then if you look down here at the mutation, that's it. Just a typed mutate.replies.create. Zero handles the rest. It handles caching on the server side. It handles all the sync logic. It handles the local first logic. And so we're just huge fans. We're excited to be working with the Zero team to include it. And I think it just makes, for the first time, you're really able to bridge web and native because Zero is lightweight. It's not bringing along a 1 megabyte, SQLite engine to the client. It's not having to it's a custom, database engine that's implemented from scratch. And so it's quite light. I don't know what the final numbers will be, but enough that you can basically use it on, even the most performant of static web pages. And that's what we're really trying to achieve with 1 and 0 is we're trying to, for the first time, unlock true code sharing with no downsides and really give you that great performance, whether you're doing a website only, a static website only, a dynamic website app, or a full-on cross-platform app that has dashboards that are very dynamic, but also has static pages that need to be performant. We're really trying to knock down these barriers and be the best web-only framework, but also the best native framework and the best unified, universal web and native framework. And so I think that's about all. That's been quite a bit. I'm so So happy and so honored to be able to speak to you guys today and to be able to finally release this. 1 is available today. It's as easy as running npx 1. 0 is very close to being in public beta. I'm not sure if by the time this talk comes out, it will be out, but needless to say, 1 will be available without it. And then the second that 0 is launched, it will be launching alongside 1, and we will have it completely ready. So I'm so happy to show this to you guys today, and I hope you guys have a great rest of your ViteConf.
What's up, ViteConf? My name is Attila. I'm the X lead at Crab Nebula, and I'm part of the Tauri working group and SolidX team. As you may have guessed by the frameworks I use, I really love Vite. I think it allows us to ship high quality apps while giving our users the best developer experience. So today, I'm here to return the favor. At Crab Nebula, we're very passionate about Tauri. We really believe it is the best alternative to create desktop and mobile apps with web tech. So much so, we have created a cloud to help you deploy, publish, and scale those apps with as little effort as you can imagine. And today, I'm here to show you the next step on this mission. We call it Taurify. So let's say you just finished creating your app. It might be a simpler demo app like the Solid Hacker News, or a more complete app like Elk, the Nuxt-based client for Mastodon. So once the web app is done, now is the time you bring Taurify into your stack and get ready to ship a native app. At its most reduced form, Taurify is an SDK. So you can use it as a package or a crate to work with your app in development mode. Once you're ready to ship, it's going to use the deployed versions or services to build your production-grade app. And it does a little bit more than just wrapping your app in Tauri. It brings a bunch of optimizations and quality of life improvements. For example, it creates a release profile to optimize your bundle size and make sure you ship as less kilobytes over the wire as possible. It adds Crab Nebula DevTools, which is our open source project to help you debug and profile your app as if it was a web app, but it plugs to the Rust runtime. It adds push updates with our auto updater service, and it has release management with our cloud. Plus, we have our brand new crate, Tauri plugin OTA. OTA stands for over-the-air updates, and it can reduce the total build time from minutes to seconds for all the platforms. The reason this plugin is so fast is because it can update your JavaScript code without rebuilding the entire Rust code. This reduces the time for each platform from minutes to all platforms in seconds. But talk is cheap, so let me show you how it actually works. Mind you though, this is a pre-release, which means things are bound to get better before the end of this year, 2024. If you're interested in that, we love your feedback. It's ready to be used on dev mode, so reach out to me if you have any doubts, questions, or feedback, please. So here we are with our Solid Hacker News demo already open, the code base on one side and the browser desktop on another. As you can see, it's a solid start app, and we just have a bunch of routes, basically like any other web app. If I run the dev mode, you'll be able to see our Hacker News demo working. So one of the things we might want to do is create a Taurify JSON. And in this Taurify JSON, we can establish the name of our app, a version for us to deploy, some descriptions, and if we want to deploy it to Crab Nebula Cloud, we can set up our org slug and our app slug. And then in the app, we have some customizations that we can do, like we can establish an icon for this app, and we can make some configs to the window that we're going to open. Lastly, we can add the targets to which we're going to build. And that's pretty much everything that we need to do. So now I stop the server. Nothing is running at this time. And we can then run our Taurify in dev mode. This is going to build our app again and then create the Tauri version. So if I refresh this page, it's still listening to the same localhost, which means that they are existing in sync. So if I open my CSS and I change anything here, it's going to reflect immediately with hot module replacement. So let's say Solid.js changed its brand colors and all works the same way. Now I'm done with my development. And what I can do then is come over here, stop the dev server, and now I want to ship this. So instead of running Taurify dev, I'm going to run Taurify build. And this is going to trigger the build of my app, and it's going to trigger then the build of my Tauri app and push it to Crab Nebula Cloud. And so if I open my cloud dashboard, I can see my release here, and I can download the packaged version. This is just a demo app. So what we need to do now is see it with a real world app. So let's swap code bases. So now we're in a much bigger code base. This is Elk, the client for Mastodon built with Nuxt. So it has a bunch of routes and components. It's a pretty complete app. I can run the dev server again. And you can see Elk's working. Then again, the same thing as before, we can open our Taurify JSON, and then we need to we can create a product name. The unique identifier is something that's required to ship the apps. And in this example, I'm only building for macOS this time. So let's bump the version one more time. And let's get started with our development build first. So we can use pnpm dlx or npx and we run it. So as you can see, it already starts the Tauri shell while it's still building the Nuxt app. So as you can see, both apps are in sync. And for example, if I go to my translations and I say that hot module replacement works, both of them happen at the same time. And now we are ready to ship. So what we're going to do is the same thing as before. Instead of dev, we run build. And this is going to build the Nuxt app, it's going to build the Tauri app, and it's going to connect to Crab Nebula Cloud, draft a release. Once the build is done, it's going to publish the release, and then we're going to be good to go. So you can see right now I have some previous releases already published, and with the magic of editing, I'm going to make our own release, our build to finish, and our release to be there. And there we are, release 032, and all good for macOS Silicon. I hope you have enjoyed these demos. Make sure to join our waiting list, and I'll see you around. It was a pleasure. Bye, ViteConf.
Hello everyone, I'm Joey. I am a contributor to Node. Recently, we've been working on some new features in the Node module loaders, so I like to use this opportunity to introduce them to folks in the Vite ecosystem and get more feedback on how to improve them. Now let's get started. The first one, which you may have heard about before, is that we have implemented ESM support in require. It's still under an experimental flag, -- experimental require module, and our plan is to unflag this in 23, get more beta testing before we backport this to LTS. So previously, if you have a ES module, like this hello.js that we have here, and then you try to require it from a common.js module, like this index.cjs here, it will throw error require ESM. This has been a major source of frustration in the ecosystem and blocked a lot of package maintainers from either shipping ESM or supporting the users who want to use ESM. But now we have support for require ESM. After we unflag this feature, a common.js module will be able to load a ES module using require as long as the ES module is synchronous. And by being synchronous, I mean that the module doesn't contain any top-level await. If it does, since require is synchronous, we cannot run the asynchronous away from it, and this will throw another error, the error require async module. But the vast majority of the ES modules out there don't actually use top-level await anyway, so this error should be quite uncommon compared to the previous error that just forbids requiring any kind of ES module. You can still use top-level await in an entry point or use import with it. It's just not supported when you try to require a module that does it. Sometimes the top-level await might come from a dependency in your graph, so it can be difficult for you to find out where it is or how to fix it. For this, we have introduced another helper flag that runs the code, find out where that top-level await is, and print it out for you. We expect to remove the experimental prefix of this flag in the future and maybe enable this by default when we figure out how to locate it without running the code. For now, on Node 22 with this -- experimental print require TLA flag, when you require an ES module that contains top-level await, as you can see in the example here, it will print the location as well as the source code of the line that contains the await statement. Now, on the topic of top-level await, one common use case of this that we found is that cross-platform code sometimes need to use it to detect whether the code is running on Node. Like here in the first example, it's trying to load OS built-in dynamically and do some tuning if that's available. With pure ES module syntax, you could only try to load a potentially non-existent module with the dynamic import call, which is asynchronous. That's why people had to use await at the top level to initialize their code. To fill this gap, we introduced process get built-in module. So ES modules can do this detection by just checking on global this and see if the function is there. If it is, then you can invoke this function to get the built-in. This returns synchronously, so you don't have to use await, and the module can then be required. This has been available on both 22 and 20. Another new feature that has been unflagged in 22 is module syntax detection in .js files. Previously, if you have an ES module in a file with the .js extension, like the esm.js here, and you don't use the type field in a package.json to tell Node that it is an ES module, Node will try to parse it as common.js for backward compatibility, which will not work because parsing the ES module syntax requires the runtime to tell the JavaScript engine it is ES module first. So when Node got this syntax error from the JavaScript engine, it used to just give up and ask users to be explicit about the module type, like setting type module in the package.json or using the .njs extension. Since 22.7, when Node tries to parse a .js file as common.js and it doesn't work, and the syntax error indicates that it might be an ES module, Node will try to parse it again. For example, with the simple esm.js file using import here, when there isn't a package.json around, or if its package.json doesn't have a type field, Node would try to parse it again as an ES module, which would not throw, so Node would just accept that and load it as an ES module. This is meant to improve the user experience of executing simple scripts without a package.json. But if you do have a package.json, it's still recommended to add the type field because other tools or editors that you use may still rely on it for configuration. Also, the file will get parsed twice for the detection, and the result does not necessarily always match your expectation. So currently, if it hits this detection path when you do have a package.json, and you could have specified a type field to save all this guesswork, Node will remind you with a warning. Another feature we recently added is module compile cache, which can be enabled with either the Node compile cache environment variable or the module enable compile cache JavaScript API. If you have used the VA compile cache libraries on NPM, you can probably already tell that it is a built-in alternative to them. And the nice thing about it is that it supports ESM out of the box. After the module compile cache is enabled, when Node compiles a user module, if this module is loaded for the first time in the system and there isn't code cache for it on disk, Node will compile it from source, which is a bit slow, but the cache will be generated and returned to disk. So the next time the application is run, Node sees that there is already a cache, then it can read and visualize the bytecode, which is a lot faster than compiling the code from scratch. Some experiments in TypeScript has already shown that it can make TSC load more than twice as fast. So please give it a try if you're writing applications or tools that care about module loading time. So those were the features that we already released. Now let's talk about some other features that we have been working on. And by the time this video is recorded, they are still under review and are not yet released, but they should come out soon. And if you're interested, please check them out, send us feedback, or do some early experiments with them to help us make them mature. So one of the motivations of supporting Require ESM was helping package authors ship native ESM. I took the data from a repository that has been serving the module types of more than 5,000 high-impact NPM packages, and as you can see here, the migration to ESM has been going very slowly. Many package authors are choosing to ship both CommonJS and ESM to maximize compatibility, that is labeled dual here, or shipping transpiled CommonJS, that is labeled full here. Shipping both ESM and CommonJS off the same package can lead to the so-called dual package hazard, where you end up with two versions of the same package in the graph that are conflicting with each other. So far, a common way to avoid this hazard is using the exports conditions. Like in this example, it is treating Node as an exception to use the CommonJS version, no matter it's required or imported, so that there won't be multiple versions of the same package in the graph. Now, with Require ESM available, it will be possible for package authors to ship ESM for both import and require on newer versions of Node and avoid the hazard. But if it's not yet time for them to drop the support for older versions of Node, they will need a way to let Node only use the ESM version when it supports Require ESM. For this, we are introducing a new exports condition for ESM, regardless of how it's loaded. We are looking into reusing the name module for this condition because it's already recognized by many bundlers, such as Webpack and Rollup, for a similar purpose. So this will help avoid further bloating your exports conditions. So here we have an example. On newer versions of Node, the module condition gets picked, and Node will let both require and import get the ESM version of the package. On older versions of Node, where neither the module condition nor require is supported, Node will pick up the default export condition and always use the transpiled CommonJS version. When I made this video, we haven't yet finalized on the name of this condition, but I expect that we'll get it settled by October. When upgrading a CommonJS library to ESM, another issue package authors may run into is that in ES modules, the default exports are separate from the name exports. So if you have a CommonJS module that reassigns module.exports to something else, your CommonJS users are going to expect require to just return that thing. Now, if you upgrade it to ESM by using export default, your CommonJS users will have to get it by unwrapping the .default property of the return namespace, because that's how ESM namespace works. You might be wondering, why can't Node just unwrap it for you? That's because if there are any additional name exports, they will get lost. This is not a problem if the module doesn't have default exports, but when they do, we need the hint from package authors to customize what required ESM should return. Now, when I'm recording this video, we haven't made up our mind yet, but so far, one of the nicer looking idea is that package authors can export something as module.exports using a string name. The CommonJS users would just get what's exported as that directly, and they don't need to change their code after the package is upgraded to ESM, which would be pretty nice. This is still under discussion, and the module exports idea is just one of the options. But anyway, we'll probably settle it by October. Another feature we've been working on is synchronous module loader hooks. Now, we have already the module register, but those are run on a separate thread and have some limitations that can be challenging to work around. So we are working on a complementary API that fills this gap. This is meant to be synchronous, lightweight, and in-thread, so the new module loader hooks can mutate the main context and pass the functions around. It will be easier to debug, and it will work for all types of module loading APIs, no matter how the application is launched. There have been a lot of user code in the wild that are monkey patching the internals of require or the internals of the module prototype, which has made the maintenance of the module loaders very difficult. But it is also very difficult for them to migrate to the module register API because they have very different execution models. So with this new hook API that provides a more similar execution model, will hopefully allow them to migrate to a more public API and allow us to maintain the node module loader better. And because this is not CommonJS specific, this might also allow them to support ESM out of the box. The rough sketch of the new API basically looks like this. It's still similar to module register, but it will be all synchronous since we need to run them directly from require. And this API will just accept functions directly. So let's say to port the example of the Pirates package on npm, you can implement a load hook, invoke the default loading step synchronously using the last argument, next load, then modify the source code a bit if the extension matches a pattern. This API will also unblock future hooks for mutating the results of require directly, since it's now on the same thread. This is what the require in the middle npm package currently does with monkey patching. It can also unblock more granular customization of ESM needed by other packages. So far, we have settled down on some of the key design questions, and we'll probably have an experimental implementation coming out soon. The last thing I want to introduce, and this is a pretty ambitious project, is support for Node runtime configuration files that can be automatically loaded. So sometimes a tool may want their users to preload some of their code to prepare the environment before any other user code is run. You could tell the users to use the --import or --require command line flags, but users will also need to make sure to pass them down into their own workers or child processes. Sometimes users might want to pass additional node flags to a process launched by another executable, which already takes control over the flags. They could use the node options environment variable, but then it can get lost if the third-party code overrides this when spawning a child worker or process. And overall, the user experience would be nicer if these configurations can be specified with a file and edited by tools. So we're currently designing a way for users to specify node runtime configurations in a file. So far, the general idea is, in package.json, you can specify a node RC field that points to another JSON configuration. The schema of this configuration is controlled by Node, and it is versioned by breaking changes. When a Node process is launched from the directory that contains these files, it will automatically discover these configurations, and for example, preload some code to set up telemetry, and make sure that all the child workers can inherit these configurations. This also allows, for example, loading the environment variable from a local file without having to use the --m file command line flag. We also have other ideas, such as allowing some kind of structural representation of the flags, or allowing extends or overrides of another configuration file. But anyway, these are all very early drafts, and I expect that we'll iterate quite a bit on this before it gets implemented and released. It would be great though to get more input from people who have experience with runtime configurations or people who have been trying to get this done properly, either for their own code or for their users' code. So that's a summary for the new stuff we've been working on in Node module loaders. Thanks for staying with me, and I hope to see you all on GitHub.
Hello everyone, my name is Natalia Bendito and I'm a principal lead for JavaScript developer experience and developer tools across the many services and tools that can be used by JavaScript developers to build applications on Microsoft Azure. Over the years, I have become increasingly more interested in performance optimization, especially at runtime. How can we run JavaScript in a way that, when a program is very much resources and capacity consuming, it won't degrade the experience for the end user? One of the technologies that enables us to use the JavaScript engine to run code client-side, but can also be run server-side, as we will see later, code that is so compute-intensive that would typically very much stress the system, is WebAssembly. It's a web standard that allows us to compile code as a portable binary that we can then run at a very low level in the JavaScript environment. What does that mean? It means that code written in whatever language that has the necessary toolchain available to compile it to WebAssembly as target can run in the JavaScript execution context or the engine and share the initialization environment and configuration and APIs made available via the host to the application to run. Let me quickly illustrate this. Let's imagine we have a program in C, C++, Rust, or other language, and we want to compile it to WebAssembly. We use its corresponding toolchain or a set of developer tools and compilers, which will then emit that code as a core WebAssembly module with imports and exports. Then we can import it into our JavaScript application by using the WebAssembly JavaScript bindings or the JavaScript API. Since we have the ability to fetch WebAssembly modules as part of our JavaScript programs at runtime, we can compose user interfaces client-side and run CPU-intensive operations at a lower level in a more performant way. I mentioned that we can do that server-side too, and that's true. Let's dive deeper to see this. We mentioned we can use the fetch API to get the WebAssembly module and compile and instantiate it. Let me demonstrate the integration of our Rust program that is compiled to WebAssembly as target and then imported to the JavaScript application. And while I do this, I will also show you something that you're probably wondering. So if we are importing a module that is written in a different language other than JavaScript, can we then debug it all the way down to the sources? I'm going to start by showing you some of the tools we have available to work with WebAssembly in the Vite ecosystem. The Vite plugin WebAssembly helps us easily bundle WebAssembly modules as static assets, so we can then asynchronously import them at runtime. Because Vite bundles and processes the code using ESM or ECMAScript modules, we need the top-level await plugin to support those WebAssembly asynchronous imports at the top level and correctly handle the instantiation of a module that returns a promise using top-level await internally. To run this demo, I have a few additional dependencies installed, including cargo, since the module is written in Rust. I also have the Wasm binding CLI or WebAssembly binding CLI. I will delete the target now to regenerate it running cargo build with target WebAssembly 32-unknown for the web, and then use the WebAssembly binding CLI to package the WebAssembly module with its JavaScript bindings. Now, when I start the Vite server for the application, an application that takes a string and outputs its binary form representation, for example, in this case, this would be for hello. If I try to translate special characters, I get an error. As a developer working in the UI, I may not know where this error is coming from and how to display some good UI notification around it or how to catch it. Now, notice that developer tools in any Chromium-based browser will actually import all sources, including the precompiled code that results in the WebAssembly module. I can see the Rust program in the sources, and with that, I can put a breakpoint directly in the problematic line of code. I can do exactly the same in VS Code, since the extension is built on top of the same mechanisms, and then use the Vite dev server to run the debugging process. Let's try it again and see how it goes from the JavaScript code to the bindings to the expressions, and how you can debug all the way down to the memory inspector and into the very Rust source. This has demonstrated how we can use Vite to bundle and handle imports for WebAssembly core modules, even when written in languages other than JavaScript, and that there are tools available to debug applications with these types of integration in the browser or in the dev server. Now, as a JavaScript developer, you are wondering, is it possible to write JavaScript and compile it to WebAssembly as target? It is, but not only that, we have tools that enable the implementation of the component model, a new form of architecture for WebAssembly that enables cross-language interoperability at its maximum expression. We have explained that WebAssembly works on imports and exports, but there is a limitation. When exposing functionality to the outside world, core modules are limited to take and return integers and floating point numbers. So if you want to work with structs, that's strings, lists, records, they have to be represented by those two types, which is often not interchangeable between languages. This is why the component model is a game changer, since it implements the WebAssembly interface type, or WIT, the extension that WIT, to create a wrapper around core modules to act as an interface layer for richer types. In the JavaScript ecosystem, we have tools that allow us to componentize JavaScript code, meaning compile it to WebAssembly, but not as a module, as a component, and then transpile it back to be run directly in the browser or server-side with a runtime like Node.js. For this demo, I do not need to have the WebAssembly plugin configured in Vite. What I will do is run componentize.js, a library that allows us to generate the WebAssembly component using the JavaScript source code and its corresponding Vite code, so I can use also the JCode CLI to transpile it back to TypeScript with its corresponding declarations and import it to my main entry point as part of a horizontal split micro frontend application that I'm building using web fragments, and more concretely, the reframed library of web fragments. Now see, I'm intentionally causing this error by using an older version of the WASI shim. WASI is the WebAssembly System Interface, and I do that so we can see the call stack and how it is ultimately calling the WebAssembly core module directly from our JavaScript application. So it's written in JavaScript end-to-end, compiled to WebAssembly, and then transpiled so you can use the imports. That core module could run in any WebAssembly-enabled runtime, including server-side, where WASI is available, like Wasm time, that also supports the component model. In sum, these are very exciting times for WebAssembly, for portability, for composition, and for interoperable components. And the Vite ecosystem has several actors working to enable additional plugins to enhance the development, the translation, and the importing processes, as well as to enable additional remote environments in the cloud, in Origin, and the edge. You can get involved using the links on screen. Thank you.
Hi ViteConf, I'm Matt Billman, CEO and co-founder of Netlify. Netlify enables the world's developers to unlock the power of the web. We are an enterprise-grade front-end cloud platform that helps you build, deploy, and operate websites, web apps, web store online. But today I'm going to talk a bit about the evolution of the space we're in. And I'm going to start back in 2016 when I gave a talk at Smashing Magazine's conference here in San Francisco about the modern front-end stack. And that was a talk where I coined the term Jamstack and talked about the stack moving up a level. I know there's been a lot of back and forth on what that word actually meant, and we've definitely let the community run with it for a bit. But back then, one thing that was clear to me was that it wasn't about static sites. Then we would just have called it static sites. It was really about this idea of decoupling, and specifically decoupling the front end from the back end, making sure that you could build the actual web UI with modern build tools aimed at web developers and web technologies. It happened at a time where there was a sense that the sort of monolithic n-tiered stack that we worked with generally had become really, really complex to operate and scale. There was caching at all these different layers. There was a lot of risk of security and downtime and so on. And it was just hard to reason about the stack. It was really complex. We proposed this idea of like really decoupling the build time from the runtime, the front end from the back end, lean on APIs for the back end, and talk to APIs either during the build or at runtime, and sort of really move from a monolithic stack, WordPress, Drupal, Adobe Experience Manager, or any of those where the front end was just sort of an afterthought from the framework driving your business logic, and to a stack where you could really build a self-standing web app distributed really close to the user and then talk to all these different apps and services. I saw the key components back then as the build tools you would use, Git as the driver of the workflow, frameworks as this web native layer that you would work in that was based on technologies that was really aligned with the core web platform. And then APIs and content delivery networks as, on the one hand, the services you would build your functionality around, and the delivery mechanism to get your web experiences really close to the users. But back then, in each of those buckets, the world really looked very different, right? Like the main build tools at the time was grunt and gulp for those who remember, sort of very simple task runners. There was the static site generators like Hugo and Jekyll that were actually not built with web technologies, but came more out of like the typical world of CMSs and backend tools. The API landscape had the first sort of headless CMSs like Contentful and Prismate trying to build headless content infrastructure. And in the framework landscape, it was still at the time when I gave this talk pretty dominated by Angular and Ember, with React just starting up. Now we moved from that to sort of really this idea of a Vue framework, where React and Vue over time became like the two most popular frameworks. But frameworks, as we'll see later, in a very different sense than how we talk about them today, right? Like they were really about running the UI in the browser. And you would have this set of tools like routers and state management libraries and all these small composable pieces that you could put together with built tools and compilers and bundlers, however you wanted. The downside was that you kind of had to compose together a bunch of different tools for every project without like a clear guideline to how you got started. So that's why we started seeing these meta frameworks emerge. It's kind of funny how the terminology has shifted, right? Like, but back then we were really talking about Gatsby, Next, and Nuxt as meta frameworks because they took these UI frameworks and then they gave some structure around it. Gatsby was the first one that came to popularity with the idea of like hydrating every single page you landed on as a single page application and then sort of taking over. Next and Nuxt took that same approach. And then over time, like Next kind of really grew to become pretty dominant in the space, and also sort of really moved from this idea of one way of operating to all these different rendering and operation modes: static, SSR, ISR. We have the page router, and then they started like the team started introducing the app router for more application-like routing patterns with layers, nested layouts with streaming. We had the whole movement towards like bundling in a strong opinion on state from the server with React server components that are sort of like deserialized, serialized rendering instructions sent to the virtual DOM in the client. We have like the partial pre-rendering that's starting to make its way in, where you stream a request and like the static fast part you deliver immediately, but then you keep the request open and start doing background processing from the edge layer to the backend layer, and start like pushing in those rendering instructions as RC once the whole thing is ready. And I think we've gotten to this point where it feels like in a certain way we've reinvented the monolith spanning both front end and back end, introducing a lot of state and a lot of complexity. When I think back on this old chart and all the different caching layers and elements in between, and then go look at the Next.js documentation for caching, conceptually, like this looks a bit cleaner, but conceptually it's very similar, right? Like you have the router cache and the full router cache and the memoization and the data cache and fetch caching and all these different layers, and starts becoming really hard to reason about. And the other day, like I just typed up a bit of my thoughts in a tweet that I saw immediately resonated with a lot of interesting people in the space. Just sort of sharing this observation that I think in the initial phases of this move to front-end frameworks and meta frameworks, we saw a big shift in what we could actually build for the web, in the performance and the dynamic elements of the experiences. But perhaps in the last 3 to 4 years, we've added a lot more complexity. It's become harder to reason about what we are, like the tools we're using. And at the same time, I don't think we've seen any big step change in what we're building. So if we're still building many of the same things that we also built 5 years ago, how can we make the web simpler again? How can we then free up complexity budget to spend it on innovation and whole new patterns? So I think a key piece in that is changing our mindset from frameworks and to smaller composable primitives. Smaller, simpler primitives that are easy to reason about in isolation, but that we can compose together and evolve independently. And fortunately, I'm not the only one thinking this. There's sort of a whole emerging landscape of new frameworks that all seem to embrace this idea in different ways. Astro is one of them, a framework that really emerged out of the idea of like, what if we don't try to do everything at the same time, but focus on being a framework for content-driven websites where you typically have a piece of a content that turns into a web page with a URL. And what if we use this idea of dynamic islands? We say most of this is actually just like an HTML page. It doesn't need to change a lot. And then we might have some specific interactive elements that we can swap in that can be powered by a component library. And maybe those can even be server islands. So they can load in after the first static page has popped up, populate from the server, and then either be interactive or non-interactive. You could think about like a product page where you have a set of recommended products for a specific visitor. Those would be in an island. Or you can think about like the card element being a little dynamic island, maybe totally client rendered. Astro doesn't have any big opinion around like the state for any of those for any of those elements. But there's a lot of different options. One of them is signals that got popularized maybe by Solid.js, but made its way into Preact and Angular, and is now starting to become a built-in browser primitive for state management and updates. So this is a small example of using signals to have one counter island that you can click, and another island that displays the same count across the page. But again, you could also use nano stores or any of the other state management techniques in place. Astro don't have an opinion around it as such. And Astro also views the UI frameworks, again, not as big vertical frameworks deciding both of server rendering and client rendering and state management, but as component libraries. And you can easily make islands in Lit or Solid or React and so on. It also views platforms like ours at Netlify as something that has a set of core primitives that you can deploy into in different ways, and comes with a bunch of adapters to any platform. I obviously think you should always use the Netlify adapter, but I like the fact that there's this like easy pluggable ecosystem around Astro, and that it feels modular instead of monolithic, component-based instead of monolithic, composable. TanStack Start is another emerging framework in alpha right now that actually really has started its life as a whole set of different components. In this case, really geared towards the other end of the spectrum, where Astro might say like piece of content maps to a page. TanStack is more about like single page applications and dashboards and application use cases with an in-client router. It's a really cool emerging framework, but again, built out of a whole set of individual composable primitives that you can also use outside of TanStack Start, and build upon a set of primitives that's emerging, like Vite, obviously, we're here because of that, Nitro and on.js. Remix, again, another example that started up as a venture-backed startup and kind of building it more of a monolithic framework, then got acquired by Shopify and got a maybe kind of freedom to say, we just need to build great web infrastructure. We don't need to dominate the space and capitalize on it. And after that, they went to Vite and say like, well, maybe Remix should actually just be a Vite plugin instead of building all of its own compilation and bundling layer and hot module reloading layer. And a bit after that, they said, okay, maybe Remix should just kind of merge into React Router and add some abilities to do data fetching and server-side rendering, but keep the whole surface area really small and fit into that original world of composable React applications you can sort of put together yourself. Vike is another framework that's really interesting. sits very close to sort of the core of Vite, but adds some opinions around how to do routing and data fetching and pre-rendering. Again, you'll see that you can use any of the UI frameworks, and it again starts treating that layer as just a view framework for rendering dynamic components in one way or the other, in the client or in the server. Again, really based on composable primitives, and again centered around Vite. We've sort of seen Vite being at the center of this whole motion, this whole explosion of frameworks that are more targeted, that are smaller, more focused, and more composable. And we've also seen Vite innovate in that space through the environment API that's really geared towards the idea of like each of these frameworks might write code and build concepts that deploy into different providers like Netlify Edge functions or Cloudflare workers or a service worker in the browser. In this way, we can start having a base of a base of shared compilation and a local dev server environment that maps really well onto all the primitives that we build across the different cloud providers and front-end cloud providers. So in short, I think we can make the web simpler if we start moving from thinking that everything should be one dominating monolithic framework to frameworks that are more specialized and takes a more specific direction. I think if we move towards composable primitives instead of monolithic frameworks, we start getting a healthier open source ecosystem, and we start being able to reason about those primitives in isolation. We can lean more into the web platform and make sure every primitive you learn makes you better at building for the web in general. And we can start focusing on simple concepts that are easy to reason about versus things that might be easy to write but hard to reason about, and move from frameworks to primitives in a simpler way, in a simpler web, hopefully still made easy by great developer experiences around it. That's what we're trying to do at Netlify, and we feel that the whole Vite community is an awesome partner in that. Thank you.
Hello everybody, my name is Igor. I'm a software engineer on a mission to help build a better web. You might know me from Angular, where I spent a good decade building the framework, but then about 2.5 years ago I joined Cloudflare to focus on the server side, because I think most of the new breakthroughs that will help web will actually come from the server side. Patak and I and our teams have started collaborating about a year ago, and we built some really cool things, and I'm excited to show you some of that today. As I was preparing this presentation, I started thinking about what should I call it? What is the presentation going to be called? And I even told Patak, I'm going to call it Building Decentralized Web Applications with Vite. But as I was doing the final preparations and slides and whatnot, I realized that decentralized is not quite the right name. I thought about this more, I did more research, and I landed on this new thing called Web Polyliths. It's kind of a mouthful, please bear with me, I'll explain where it's coming from. And if you have new ideas for a better name, please shoot me an email, I'll consider it. But Web Polyliths is a way to break away from the current era of web monoliths. This is how we're building applications today. And using monoliths to build applications has some downsides, and I think we can do better, and this presentation is about how we can do better. So polylithic web applications, what the heck? Like, this sounds totally made up. Is it made up? Well, yes and no. So I was doing the research. I was looking for a word that would describe something that is opposite to monolithic. And I came across a lot of research in geology, and there I found this polylithic definition where I found that it's defined as consisting of many stones, of many building blocks. It's the opposite of monolithic. I was like, yeah, that's it. This is exactly what I want, because polylithic applications are exactly the opposite of monoliths. They are made up of many pieces. These pieces operate in sometimes decentralized way, and this is where it's like where decentralized came to be. But I think like what I realized is decentralized often means that it's the control, it's the operator that is decentralized, that you have many parties operating the application, and that's not quite what I'm after. Even though like decentralization is often a good thing. The term is not fully made up, but it's also not very common yet. We'll see if it takes off. I hope it does. So before we go to polylithic applications, let's talk about monolithic applications, the applications of today. This is how we build applications. Most of our applications are monolithic. They have only single entry point. That's the code that bootstraps the application or responds to the request. This entry point often can be bundled. Bundling is optional. It doesn't have to, it's not a required part to be a monolithic application. And if you do bundle, you don't need to end up with a single file. You can still use lazy loading and end up with many chunks. But the point is that there is a single entry point, and from the point of like traversing the AST, the dependency graph of all the symbols in the application, there is really just like one universe of all the code. And this code is loaded into single JavaScript context, and that's how the application operates. Now, examples of monolithic applications, the most common one is SPA, single page applications. All of us have built some, but also Node.js. Node.js, most of the Node.js applications, unless you're using some of the advanced APIs like child process or VM module, your application is most likely monolithic, even if it's not bundled. Dino, the same thing. Again, unless you're doing something advanced, you're most likely building a monolithic application. And the same applies to Cloudflare Workers, which is interesting because we have this very nimble runtime that is deployed to 400 cities around the world, and people still build these bigger monolithic applications and deploy to them. Works, but we could do better. We'll talk about it soon. So what are the benefits of monolithic applications? Because there must be some, otherwise we would not be building these applications in this way. And the truth is that the main benefit is that they are simple. And simplicity is often such a key property, and we value it so highly that any other benefits or any other the disadvantages are secondary. Like we're already overwhelmed with a lot of complexity in our lives. So if there is a simple solution, then we'll just go for it. And that's the case with monolithic applications, I believe. But there are also some cons, some negatives about monolithic applications. They tend to be slow in two ways. One is that they often load more JavaScript than they need into the runtime, both on server side or client side. This slows down the initial interactivity, impacts both server side and client side. But also, they're slow because they can't take advantage of multi-threading. JavaScript is single-threaded. If you have a monolithic application and executes in a single JavaScript context, it cannot do more than one piece of work at a time. Monolithic applications are also inefficient, and efficiencies often come down to how they are deployed and operated. If you have a monolithic application, but that application talks to multiple data stores and those data stores are not centralized, then you often end up paying more latency when talking to these data stores because you cannot be in all the locations at the same time, which is not the case if you were to break up the application, in which case the individual compute units could run closer to the data. They're also less secure, and this is because all of the code runs in a single JavaScript context, and the JavaScript context shares some global state. So if intruder were to inject their codes in some way, maybe through third-party dependency, that intruder now has access to everything that is available in that JavaScript context, as long as it's traversable. And this is not great because from the perimeter and blast radius perspective, the blast radius is basically entire application. Not good. The other property that I care about a lot is also fragile. Monolithic applications tend to be fragile, especially as they grow, because the more code you have, the higher the chance of some kind of collision, race condition, some kind of interaction between various parts of the code base. that are hard to reason about and hard to debug, and eventually the application just becomes very troublesome to iterate on and debug and understand. So obviously polylithic applications solve all of these problems, right? Because otherwise we wouldn't be talking about them. But what are the trade-offs? Because there must be some trade-offs. However, before we jump there and talk about the trade-offs, let's talk about some surprises. Because I think most of you will be surprised to hear that all of you have already built some polylithic application already, and you maybe don't know it yet. This is because polylithic applications can be defined as applications that have 2 or more entry points. They have two that can be bundled into 2 or more bundles. They run in multiple isolated JavaScript contexts, one for each of the entry points or bundles. And good examples of these applications are full-stack applications. And this is where I think many of you have built some. Full-stack applications have a client-side and server-side program. These are bundled independently, loaded into 2 separate JavaScript contexts, one on the client side, one on the server side, and it's all handled by some kind of framework typically. So I bet many of you have built polylithic application. Another good use case is Web Worker. With Web Worker, the code running in a Web Worker is often in distinct independent program, and most of us have used Web Worker in one way or another. Service Worker, very similar story. Edge middleware, again, very similar. It's a distinct program that runs at the edge near the user. And very commonly these days we talk about RSCs, and RSCs are yet another good example of polylithic application where they are bundled, the React server components are bundled separately. They have their own entry point and they run in their own JavaScript context. So polylithic applications are becoming more and more common, but they're not the mainstream. It's not how we build applications these days. And if we were to build them in this way, we would get lots of benefits. They would be faster because often these programs are much smaller. They don't have problems with cold start latency. They can take advantage of multiple threads. They are more efficient because you can deploy them into various locations close to data, reducing the overall latency. They're more secure because the perimeter of the attack radius is the individual program, which is much smaller than the entire application. So if an attacker were to intrude into part of the application, it's not the entire application that is compromised. And also it's much more robust because if you have smaller chunks, it's much easier to understand the application. You can look at one part of the application in isolation from the rest and fully understand it. So it's much easier to understand, iterate, fix, and so on. However, there's no free lunch because if there was no downside, then everybody would be building applications in this way. However, the downside is complexity. And the complexity comes in several forms. It's configuration complexity, build complexity, deployment complexity. There's lots of them. And this complexity can be overwhelming. However, as I mentioned, we've been already building some of these polylithic applications all along. So how is that possible? Let's take a look at a very simple case with a web worker. We have a main program that runs in the main thread and does all of DOM manipulation. Then we have web worker. In this case, we have 2 programs that are composed into one application. They can be bundled into 2 bundles. These bundles are in 2 distinct JavaScript contexts. And often we build them in a single source code because you can have just a single Git repository to collocate all this code and work on it in one go. So before all of this was possible, it was possible to build these applications, but it was tricky. And the way we did it was we had all kinds of like custom builds using Rollup or ESBuild. We would rely on frameworks to abstract away the complexity. Most of the full stack frameworks do this behind the scenes. They just produce the client-side and JavaScript, client-side and server-side bundles for you. But there are also NPM packages that have been built for consumption in this way. For example, some libraries that are meant to be used in a web worker context or service worker context, you just load them in a way where it just creates a new web worker and then you talk to it and you don't really even know that that is happening. So All of this was possible, but it was limiting, and it is possible for it to get messy very quickly, just like this bunch of cables that I found online, this is not what we want. So Vite 6 changes all of this. Vite 6 comes with Environment API. Environment API is a very powerful API that allows us to build polylithic applications. So what does it do? It allows you to create many environments. So before Vite 6, Vite 5, imagine that you basically had just one environment. In Vite 6, you can have arbitrary number of environments. Each environment can support a separate program. This program gets its own configuration, loaders, transformers, and even JavaScript runtime. And this is why our team was involved in helping the Vite team build this feature, because we want to be able to use Vite, and we want our developers to be able to use Vite and run the code that is produced by Vite in our JavaScript runtime that Cloudflare makes, called Cloudflare Workers or Workerd. And Environment API allows that. If you build environment this way, you don't sacrifice any of the developer benefits. You get HMR, you get debugging, you get source mapping support, and all of the developer experience benefits that you're expecting from Vite. So obviously these polylithic web applications solve many problems that we have and have a wide range of application. It would be good if we could just take a quick look at some of the examples where we might want to take advantage of them. So I mentioned the web worker and the service worker scenario. In this case, Vite can create 3 environments with 3 different configurations, support HMR for all of these. And as a developer, you're just starting one Vite server, not realizing that all of this is happening behind the scenes. But you can now build the application just like it will be deployed to production, which is very powerful. The same is true for the server side. You can have a 3-tier server-side application with SSR backend and REST backend, and Vite can handle that. Again, 3 collaborating programs. You can build applications with Edge middleware and SSR backend. As I mentioned, Astro before. Astro supports this kind of configuration, very powerful. Vite supports it. And you can combine all of these and just go crazy and create basically as many environments as you want if your application requires it. So with Vite 6, you can get all of the benefits of polylithic web applications without the downsides of the complexity, because the complexity will be abstracted away by Vite itself. But let's take a look at the demo. I was thinking what to demo, and originally I thought I was going to show you Remix or Svelte Kit or Qwik, because we're working on integrations between all of these and Vite 6 and Cloudflare. But last week, one of my teammates, James Opstad, came to a meeting and was like, hey, I want to show you something cool. I built a prototype of what building Cloudflare workers with Vite natively could look like eventually in the future. And I was like, well, let's see. The actual application is very simple. I'm just making curl requests to Vite server. The Vite server then talks to 2 workers that are running in Workerd in the virtual machine and a JavaScript runtime that powers Cloudflare workers. Vite builds and bundles this and has an HMR client running in all of both of these contexts. So as we change code, we are able to reload worker A or worker D, depending on which one changed. And all of this is abstracted away, so as developers, you don't really see that this is happening. So we have 2 programs that are collaborating and working together. Let's jump into an editor here and take a look at what that looks like. So the code itself is very simple. I'll link to GitHub in a bit. The main part is ViteConf. In ViteConf, we are pulling in this plugin, which is experimental plugin. Don't use this in production. This is just for demo purposes, exploratory purposes. But the cool thing is that we have the Cloudflare plugin that defines 2 environments. In these environments, we have worker A and we have worker B. Both of them have this main property that defines an entry point, and then a config file that is just a very simple config file. The config file actually is almost empty, doesn't do much. In case of worker A, we're just saying that, hey, this is how you get hold of worker B, so you can talk to it. Now, if we take a look at the index file, The code itself is super simple. We have a fetch handler that gets hold of worker B, calls this function called a method called name, gets the result, and uses that to produce a response that is returned. Worker B, on the other hand, is even simpler because it's a class that has a name method that just returns a string. That's all. So if I go and I start my Vite server and I curl it, I get this response back. Now let's run this in a loop so that we see as it updates. If I go here and change this, let's say I just want a longer version of this year, we see that Vite reloaded. That caused HMR reload in the worker D runtime of affecting worker B. And now we see that the year is updated. So if I don't like the year at all, let's remove it. The same applies here. We can go and just add more hearts because everybody needs more hearts these days. And we see that Vite rebundles the application, updates the worker D runtime with the new code, and then as we make this next request, the response updates. Super simple, very powerful, because as a developer, I don't need to think about managing all of these VMs, managing the transpilation, build pipeline, and so on and so on. So let's jump back. Here's a link. You'll have a link to slides later, so don't worry about grabbing it now. But do me a favor and go build some polyliths. I think it's time to say goodbye to monoliths. I think we can do better. I think the whole web, both the developers as well as users, will be better off if we stop building monolithic applications and switch over to polyliths. And you can use Vite 6 to do that because Vite 6 makes it so easy. With that, I just want to thank you all. I want to thank Vite and Vite team and Patak for great collaboration. And yeah, see you out there. Bye.
All right, checking in with you, Matthias. How are you doing?
This is amazing. It's just like very intense as usual, but we are having a lot of fun, no?
No, the chat is always my favorite place to be. Thank you again, everyone who's participating. And if you haven't been participating in the chat, I mean, take a look. It's just so lovely and so many exciting discoveries are being made there. Let us know which talks you really enjoyed. Let us know what you've learned. Let us know what's new and exciting for you. It really does help the speakers. I can say that as a speaker. It can be a little scary being there live while people are watching your talk. So yeah, do participate, make some friends, make some connections. Make sure you go to the individual talk channels for some of that follow-up and async discussion. But what's on deck? What's coming up next, Matthias?
Yeah, now I think that we should say welcome to ViteConf because there is a testing section is coming in. First, it's going to be opened by Jessalyn from the Chrome DevTools team. And then afterwards, we are going to have Vladimir with the State of Vitest, and Ari and Misha are going to be there. Also, this is the first time that we have 3 talks about Vitest. So yeah, let's enjoy what's coming. We are going to go actually to a little break before the section. So yeah, like go as Sarah said in the last time, go get a coffee, a tea, a mate, or something, whatever you drink, and start to let's keep this going because there is so much still ahead of us.
Yep, and we'll see you right back in the chat pretty soon.
Hey everyone, it's awesome to be back at ViteConf this year. I am Jessalyn from the Chrome DevTools team, and I'm excited to show you 4 powerful tools to help you build the web you want, lightning fast. Well, by build, I mean debug and fix. Because, let's be honest, we spend a ton of time figuring out why things aren't working the way we want. So, let's make that process way smoother. Ready to dive in? Let's go! Number 1. Trying to inspect an element and it is gone. Like this drop-down menu from Daisy UI, I just want to inspect the item, but it disappears when I click on DevTools. It is frustrating, right? This happens because the page loses focus, but we can outsmart that. In the console, let's keep an eye on the document.hasFocus state. See, when you click on the page, it is true. However, when you click on DevTools, it is false, and the drop-down menu disappears. What is the trick then? We can make the page think it is always in focus. In the Styles tab, enable the Emulate a Focus Page setting, and boom, everything stays visible. These settings stick around so you won't have to keep turning it on. Do you want even more ways to freeze the screen and debug disappearing elements? Check out this video, it covers 5 more techniques. Number 2. Oh my, the console is exploding with errors. Sometimes it is challenging to figure out how to fix them. Wouldn't it be amazing to have a little help here? Check this out. We have got these undefined errors popping up. Click the code link shows us where the error is, but here is the cool part. There is a light bulb icon next to the error. Let's click it and get some AI assistance from Gemini. Gemini analyzes the errors and the surrounding code once you grant it permission. Voila! That's a pretty detailed explanation. It gives us a clear summary of the potential causes and suggests not only 1, but 3 possible solutions. Let's try this fix. I like that it understands the Vue.js code. Let's make the changes, refresh the page, and the errors are gone. How awesome is that? Give it a try yourself. You can learn more about this feature here. And hey, if the AI suggestion isn't helpful, you can always use the search function instead. Number 3. This is me every time I need to tackle performance issues. The performance panel is a goldmine of data, but it can feel overwhelming. We hear you. The DevTools team have been working hard this year, giving the performance panel a major overhaul. And guess what? Some awesome new UI features are already here. Ta-da! Now you can get a live view of your core web vitals without even recording. In fact, you don't even need to have DevTools open. The metrics are gathered in the background and available wherever you need it. This comes in handy for those times you feel something is slow and want to understand why immediately. As you load and interact with the page, these metrics will update in real time. They are also color-coded, making it easier to spot performance issues as they happen. But here's the thing. Developer machines are usually pretty fast. To get a real-world perspective, you can now compare your local performance with real user data right here in DevTools. Follow these steps to set up the field data and start comparing them side by side. Learn more about this and other updates on the performance panel here. Number 4. When was the last time that you wanted to build a web UI but the backend API just isn't ready yet? You can use the network overrides to mock the API and prototype faster. Let's say you are building a new coffee page with a new API. If you know the data structure, you can mock it up and keep your design process moving. Override the 404 request, add your mock data, save it, refresh the page, and bam! You can test your design instantly. All overridden files are stored on your drive, so you can edit them with your favorite code editor. You can even sync the folder to a shared location for easy team collaboration. And it gets better. You can override response headers too. Dive deeper into that here in this link. Alright, that's all for today. Go explore these tools and build something amazing. Connect with me and the DevTools team with these links. Enjoy the rest of the ViteConf. Ciao!
Hello, my name is Vladimir. I am a team member of Vitest and I am a team member of Vite. Today, in this talk, I wanted to talk about the state of Vitest and bring you all up to speed to the latest Vitest 2.1. Let's dive in. First of all, let's look at the weekly downloads graph. 1 year ago, Vitest had a little bit more than 2 million downloads a week. In the last year, we managed to almost triple this amount. Of course, downloads are not the most important thing, but we managed to also increase the amount of cool new features we have. And I will give you a brief overview of them here, and my colleagues will explain them in details in their own talks here on ViteConf. So don't miss them out. Just watch every testing talk here and you will be up to speed with what's going on with Vitest. First of all, it's browser mode. It was introduced quite a while ago as an experimental feature just to run a code in the browser. It stayed like that for quite a while until we decided to move forward to give more attention to the browser, to running tests in the browser, because we believe JSDOM is not as good and is not as good for everything. And there are very certain scenarios where when you want to run your tests in the browser. So in Vitest 2.0, we rewrote everything and we introduced the new UI. So it uses our old just preview UI, but here we are also showing you the iframe where the test runs and how it runs throughout the whole test. You can change the viewport, you can resize it. In Vitest 2.1, we also changed how the preview works. It is now showing you the full viewport. Previously, it would only show you the visible viewport, so it was 1-to-1 in your browser. Right now, it's more focused and more usable, to be honest. Another thing we did with the browser UI, we added new buttons like running the test from the UI itself. So it's not shown here, but if you click on SRC components, for example, on demand on any file there, you will see a button there to run the test. Very convenient, very similar to how it works in VS Code, foreshadowing. Next one is coverage. So we changed we changed a lot with coverage API. Most changes are related to the new defaults, like covering all files instead of files that we're running. So by default now in Vitest 2.0, you will see every file as covered or uncovered. Previously, by default, you will only see files that were ran by the test runner itself, not every file. We feel like it's more it makes more sense to see all your files if you're working with coverage, because you want to know if your test is covered, and if you don't see the file that you didn't even import, that doesn't really make a lot of sense. One of the most impactful changes, though, is with browser mode integration and the coverage
So in browser mode, in Vitest 2.1, you can now run V8 coverage instead of Istanbul right in your browser. To know more about the coverage in Vitest, check out Ari's talk. It will also be one of the next talks, I think. Okay, don't forget. I'll look at you. So next thing is type testing. It is still an experimental feature. Unfortunately, we're working more with browser mode at the moment, but there are new features there. The most impactful feature was finally it's here in Vitest 2.1. You can run your regular tests and your type tests in the same file. They're now reported as two different entries, so you will see like a TypeScript icon. The next version of expect type-off, as you see in the example on the slides, also updates its API. And Misha, the author of the library, will talk more about it and how it works and how you can use it in your projects. Also in one of the next talks. One of the coolest features, new features or new updates we have is VS Code extension. So it was rewritten from the ground up to be more responsive, and I will show you demo time. I'll show you more about it. Okay, let me just do this. So we are in VS Code. We are in Test Explorer section. You can see here it's called Test Explorer. So we can run tests on a concept. We can run, boom, it's very fast. We can run here, it's even faster. We can run here. Run here, can run here, can run here. We can run every test. I mean, this basically the sample is a bit too small, so it does everything the same, but it actually is different. So if you notice, it's very fast, as you can see here. It was 400, but I don't know why. Like 100 milliseconds. So it's as fast as if you are running Vitest CLI in Vouch mode, and the reason why it's that is because internally, it uses the same mechanism. Basically, we keep Vitest running in the background. It's not a very expensive process, so we can allow that. It's just code that waits some input, right? So when we click here, we can just run the test again. We don't need to process the file again. Everything is cached. Everything is nice and ready to run. So it's very fast. You can debug a test. So I did the debug. So it took much longer because it needs to spawn the process, needs to start Vitest, needs to import Vitest, it needs to process every file. So it will be slower, but it is better experience-wise because otherwise we tried another approach to do the same, but just use coverage instead. But use debugging API instead. Didn't work out very well. So if you were using VS Code extension in its initial version, you might have seen that debugging works quite badly, to be honest, with you in most situations. But now what it does is it spawns a new process, which is clean. It takes a bit longer, but it's a better overall experience. So breakpoints work as well. So we take a breakpoint here. We can see. So there are local variables. There is no local variable. There's block variables here in the file itself, global variables, and so on. You can go forward, go backwards. You can end here, and it works great. Another thing that's supported by the VS Code extension is coverage. So let me show you. I'm pressing this button. I see a test failing, but I also see a coverage of this file, this source code file. I'm hovering here and I can see how many times it was called. Very cool, very, very nice. Works out of the box. You will need to have the package installed. So Vitest coverage V8 or Vitest coverage Istanbul, you will need to have it installed manually. But after you've installed it, just press a button. You can run every file. You can run only a single file with coverage. So if you run a single file with coverage, it will not try to fetch every file in the project to see if they're covered. It will only run this test specifically, and which will be much faster. And it's very nice to see if you're developing like a like a component to see if all of the files of that component in particular are covered. Yes, so the next thing that I wanted to show you was also the browser mode is also supported here. Let me give you a small example here. We can go here, we see resolving Vitest. It takes some time because we need to start the Vitest. And you can see here, every file, every test was found already. And we can run it, right? So we want to run on the addition. It takes some time because as you can see here, we are starting the Vitest, the browser. Browser has started. We go back and tests have run. So it took us 7 seconds just to run this test. But you only need to do this once. Because next time you need to run a test, what you do is you press this button and it takes the same time as a test takes by Node. So it's even less, actually, less than 100 milliseconds. Because we keep the browser open, as long as you keep the browser open, or as long as you have a headless enabled manually. As you can see, it's immediate. What you can also see is that I didn't show you last time is the continuous run also works here. So continuous run is basically a feature that allows you to run every test or any specific text. Like in this example, we only want to rerun the test 2 when the file changes. So I'm changing here to 3. Well, I see here the error. And I can reflect on that. I can see the changes here. I can change it back to 2, so it's fixed now. I can also watch a specific suite. So every test in this suite will rerun when I change the test, when I change the code. So it takes some time because we have hard-coded times here. Go back, we run again. We can watch the file, we can watch the folder, and so on and so forth. We can watch every file here, so which is also very nice. This is it. I wanted to show you with the browser mode. Now I want to say thank you for listening to this. Thank you for supporting Vitest, and I will see you in Discord chat.
Hello ViteConf, my name is Ari and I'm here to talk to you about code coverage in Vitest, how to use it and how to get started with it. I'm part of the Vitest core team. I've been working on Vitest for the past 2.5 years now, I think. I'm also working at StackBlitz as an open source engineer. You're going to find me on GitHub and X behind these usernames. Now, what you can use code coverage for? It's a useful tool to see which parts of the source files are being executed by your test code. So by default here, Vitest will include your source files in the coverage report and mark them as uncovered. So when this file now doesn't have any test cases covering it, so we can see that everything is marked as red here and the coverage levels are at 0%. And once we start to add some test cases there, we can see that now our coverage levels are increasing and we can see that the lines are now marked as green here instead of red. And once we add some more test cases, the report is now more green and we can actually see that this line here is turning from red to green, which means that we are passing a threshold there. Now on line 7 here, we still have one place that is not being executed by our test files. Now, code coverage is useful to spot these kind of places, like if you now went and added a bug here on this line, like let's say that you changed this meow here to woof. Now, after a change like that, none of your tests would fail because this is not executed by any tests. So you can add bugs in your source files without even realizing it. So code coverage is a good tool to spot this kind of error-prone or bug-prone places. Now let's see how this works in practice in Vitest. Here I have the same setup as shown earlier. We only have the Vitest installed here, and the source file is the same one. And we have, let's actually comment out this one. All right, so we have one test case for it. And now if we run npm run test coverage, we can see that Vitest is throwing us an error saying that the coverage provider module is not installed. But let's press Y and install it. And now Vitest automatically installed us the package. Now the reason why this one is not included in the core package, the Vitest one, is that coverage is an optional feature. Maybe some people don't use it, and it requires some extra dependencies. So we can reduce the package size of the main package by adding this as its own package as pair dependency. Now let's rerun the command, and now we can see that tests ran and there is a coverage report. So here at the root we now have a coverage directory which has index.html. Let's open this one and close the sidebar. All right, so now we can see our coverage report here. Now we are only covering the first part of the source file, like the first if clause. But if we add another test case here and press save, the watch mode of Vitest instantly rerun the file and generated us a updated coverage report. And now we can see that the lines 6 to 8 are also covered. And we can see that there is still some parts of the source file that are not being covered by any test cases. So ideally we should add a test case for that one too. Now Vitest tries to provide good default options out of the box. The idea here is that users wouldn't need to configure anything. It would just work without any configuration. But for example, in a project like this where we have a couple of files here and a single test case, and this test case here is importing the math.js, which is coming from here. Now when we run coverage for this test case or this project, we will get a report that includes all of these files. So even though we are only importing the math.js, we are getting all of these other files in the report as well. And this is because Vitest enables the coverage.all option by default, which means that it will go through all of your files that are matching the include and exclude and add those into the coverage report as uncovered files. But as we can see here, this is not actually an ideal situation because the docs and scripts directories, those are not our application code, but they are still included in our coverage report. So what we typically see is that users start to add all of these patterns in the coverage.exclude, and quite quickly this can become a long list of options or patterns that is difficult to maintain. And this is not really ideal. Like, sure, this works. Now you are not seeing these in your coverage report, but if you now added another directory here or some file, it would also pop up in the report and you would have to define it here. So what's better is to help Vitest to find your source files. So instead of defining plenty of exclusions, just define a couple, maybe even just one inclusion. So you can help Vitest by telling it where your source code is. Now we don't have to go through all of the files and then add them there. We can just simply start by looking from the SRC directory and then apply the exclusions there. This will make your coverage report generation faster also. Now we cannot really set the SRC here as default because it's not a convention that everyone does. Like, some could have the code in, let's say, packages directory or lib or something like that. So you need to help Vitest to understand your project structure. Now Vitest comes with two coverage providers, the Istanbul and V8 one. The Istanbul here, it does the code coverage instrumentation using Babel, which means that it takes your JavaScript source code and adds plenty of, well, more JavaScript there. Like here we can see I have the same files. And let's take a look at what happens to the source file. So originally this one was just 12 lines. And once we run it through Istanbul instrumentation, we can see that the file is increased a lot. Like this is now 200 lines. And for example, here is a branch counter that is inside that if block there. And this is just a way how we can cover that. Okay, now increase the counter by 1 whenever we execute this if branch here. While this works perfectly, it's quite slow. Like you can imagine in a larger project, these files can grow like huge and executing them can become slow. But the reports are very accurate because the instrumentation is AST based. Like we can understand what the coverage actually contains. This is something that Zest does by default. By default, Zest has the coverage provider option with value Babel, which is the same as Istanbul on Vitest. And it's the same that NYC does. Now, Vitest has also the coverage V8, which we use by default. And this one is a bit more modern approach to coverage. So it does the instrumentation on V8. And V8 is the JavaScript engine that is used by Node.js and Chromium browsers. Now, we don't have to make any modifications to those source files before we execute them. We can just instruct V8 that, okay, before you actually execute this, start your own internal instrumentation and collect the coverage reports from this. And this one is really fast. But as it is not AST based, it's not something that we don't really control the instrumentation or how it is done. It is not as accurate as the Istanbul reports are. But in Vitest version 2, we were able to add features that actually improved the accuracy of V8 coverage reports as well. Like right now, we can exclude TypeScript types, empty lines, and so on. This is something that Zest supports by the V8 coverage provider option, and C8 does the same, and the Node built-in test runner with their experimental flag has the same features. Now we recommend to use V8 coverage always. Like if you are running your code in Node or Chromium browsers, use V8. But if you need to run your code, let's say in Cloudflare Workers or Firefox, then you can use the Istanbul. Or if you are doing migration from Zest and you don't want to see plenty of changes in the same migration, you can use the Istanbul first and maybe later change the coverage provider to V8. Now these are just some features that we've gone through now, like the basic options, but Vitest has plenty of coverage options like thresholds, workspaces. In workspaces you can see the coverage report of both browser and Node in the same report, which is really cool. And custom reporters, custom providers, you can build one of your own coverage provider yourself. And Vitest UI is able to show the coverage reports in the browser itself. And so much more. All right, thank you, ViteConf. I hope you have a good day.
Hi, my name is Misha Koletsky. I am the author of Expect Type, which is a library bundled into Vitest that helps TypeScript developers provide compile time tests for their types. This is to make sure that your types don't accidentally change or get worse over time, or that they do what you think they do in the first place. I'm going to show you how it works, why it's useful, and how it's built into Vitest. There's nothing you need to install. If you're using Vitest, you already have this available to you. So first, why it's useful. Most of us, I think, use TypeScript to catch errors. There's also obviously benefits like IntelliSense in IDEs, but it's also to make sure that when people use your code in future, they're going to use it in the right way. What it doesn't necessarily protect against is if your types are, say, too flexible, or if they change in future to allow any's or something like that. Expect type lets you explicitly test what your types are supposed to do to catch any future issues before they become bugs. But it's purely at the type level. It does nothing at runtime. But I'll show you an example. You can fit it into your existing Vitest tests. So we can jump into an example. Let's say you define a function, super useful module called calculator.ts. So in this example, we've got a number that we are adding to another number, and we expect the output to be a number. We want to make sure that the output type is correct. So here's what a test for that function might look like. You basically just call expect type of add, and then you pass in what you're trying to test into this helper function, and then you can run tests on both the parameters and the return type. There's a lot of different helpers that I won't go through all of them in this talk, but pretty much everything you might want to do with a TypeScript type, there's a helper for. So you can see if you type to be, we can say I expect the return type to be a function, and then I'm going to get what's hopefully a helpful error. So you might have seen Vladimir's talk about this a year ago, and there were some caveats around it. This was already part of Vitest in an experimental capacity, and the error messages weren't that great. It basically said, "You're wrong. This isn't a function." We've done a lot of work on improving the error messages because this is a pure TypeScript library. There's nothing fancy happening at runtime. There's no crazy hacked version of TypeScript that you have to download. This is just using the TypeScript compiler. So some of the error messages are still a little bit strange to read because TypeScript doesn't expose this kind of thing at runtime. So there's a ton of crazy TypeScript generics. There's TypeScript ternary operators inside this library. You shouldn't really need to worry about any of that. All you need to know is roughly how to read these messages. So let's say I expect add to return a function for some reason. I'm going to get an error message that is as close as we could get it to human readable. Obviously, feedback welcome. But basically, the way you read this is type expect function number has no call signatures. So the reason we've gone for a call signature error here is so that the error message actually includes what the expected type was and what the actual type was. So we're going to change this to be number. And this is roughly equivalent to be number is roughly equivalent to equal type of number. It's not exactly the same because I can do things like this. And then we can say the type 1 rather than, which has type literal 1 rather than number, that is a number. So you can use some of these helpers in different ways. It's worth experimenting with. So let's say we want to add some features to this calculator. Like let's say we want to support big ints as well. Okay, so now we should see, oh look, this is great. I'm running the TypeScript compiler, and this is just regular TSC. You can also run it through Vitest. And Vitest will show you exactly which test has the type assertion problem. And we're going to see that there is a problem in one of our tests that existed. Now we've got an overloaded function, and expect type of actually handles overloaded functions in a way that I would say is better than the TypeScript built-in option. So the problem here is that now the parameters are either a tuple of type number, because A could be number and B could be number, or it's a tuple of type big int. So if we change this, then we should see the error message go away, or big int. And then that one goes away because it's guessing what this is. And similarly, the return type, it may be a number or it may be a big int. This kind of mostly covers your bases because the parameters have type either that left-hand side or the right-hand side, and the return type has either number or big int. But obviously that return type, we want to make sure that that's not actually a union type that returns from the add function. You want to make sure that if you pass big ints in, you get a big int out. So we can actually test for that using expect type of without even calling it at runtime as well. So let's say expect type of add, we can use the helper to be callable with, and then we can say, yes, this type is callable with 1, 2. And then the nice thing about this is then we map that to the correct return type. So if we then say returns, we will get returns to be number. And similarly, I can say, we actually don't have the bigint helper yet, but to equal type of bigint. To be bigint is something that we need to add. It's just a missing helper, but like I said before, you can just use to equal type of bigint there too. So you can see this helps make sure that that number is mapped to number, and then we don't need to worry too much about the way that we did this casting. Obviously, this overload syntax is not the most familiar to all developers, so you might look at it and think, are you going to get number or bigint return type when you actually call this with bigint? But you won't. This can make sure that you've written the overload syntax in the right way, and these are the actual only two signatures that get exposed through the add function. Here's another slightly more involved example. I've got a module called ZAD, which is used to create schemas that can validate input objects and make sure they match a certain shape. In this example, I've got a person schema, and I'm making sure that they have a name property that's a string and an isMarried property that's a Boolean. If I want to add an age, I might do something like this, and then you'd expect this to start failing, and then I would add an age number property here, but then this helped me find a bug here. So if I look at the error message, it says expected number actual string. So if I go back to the implementation here, I'm going to see that this is the problem. I've got val is string rather than val is number. TypeScript is not going to find this error for you because type guards just kind of almost allow you to do anything as long as you're returning a Boolean. So this is a place where this kind of testing library can come in really useful. Another way that you can see is it actually protects you against any, which can be the scourge of a lot of TypeScript code bases. If I change this to val is any, this is still going to fail. The error message becomes a little bit harder to read because we have to map any to never in order for it to not match. But basically, we can see here that these types are not identical. So we really do a proper identical check. It's not just making sure that type A extends type B and type B extends type A. Any will not be allowed to match against number. So it's quite nice the way it checks for that kind of thing. There's also a lot of checks that if you were implementing something like this from scratch, you'd come across a lot of these edge cases. Let's say I want to add an optional helper, and then I make age optional to make it a backwards compatible change. You can see that what Cursor is suggesting here is that I just add a question mark to the age property, but that's still not quite going to work because you can see if you read the error message, one of the types has age as a truly optional property, but what we've got is age as a property that can have either type of number or type of undefined. So to fix that, I'm going to just take a shortcut and use typefest.partial on undefined deep. There are lots more helpers to dive into. For example, if you want to do only partial matching on a type, similar to the toMatch object method that exists on expect, you can do expect type of person to match type of name string, and that will be the equivalent of the toMatch object function. There are tons more. Have a look at the docs. They're on the Vitest website, and they're also on the npm package expect type. Thanks a lot for making it this far. Here's the npm package. The GitHub repo is linked here. Vitest is downstream of this package, so development happens here. And give me a follow on Twitter as well. I'll be talking about upcoming features of expect type, and there's tons and tons more usage documentation on npm here, and this is also copied onto the Vitest website. Thanks. Bye.
Hey friends, Rich here from the Svelte team. I'm going to keep this video nice and quick because the team is currently in crunch mode putting the finishing touches on Svelte 5. Svelte 5, you say? Tell me more. Well, okay, I'm a little offended that you even need to ask, but I'll explain. A little over a year ago, we started doing something that you should almost never do, a ground-up rewrite. Why would we do something so controversial and yet so brave? After all, according to survey after survey, developers love Svelte. You people can't get enough of it. I mean, look, if React is Taylor Swift, then we're more of a, I don't know, Phoebe Bridgers. She's critically acclaimed, you've heard of her, but you probably can't name that many of her songs. But we're clearly doing something, right? Right? Well, yeah, but after working on Svelte for a few years, we came to realize that we're also doing a bunch of stuff wrong. So let's rewind. What is Svelte and how did it work up until now? Svelte is a framework for describing user interfaces on the web. We've got some markup, some styles, and some JavaScript all working together in harmony. But Svelte is also a compiler. It takes its code as input and generates some vanilla JavaScript as its output that surgically updates the DOM when state changes. For example, it knows that it needs to update this piece of text when doubled changes, and it knows that doubled changes when count changes because it can see this count times 2 expression. And it knows that count changes when we click the button because it can see the count plus 1 assignment. In other words, we've turned JavaScript into a reactive language, without all of the overhead of rerunning code and diffing stuff. Now this idea works pretty well. It's easy to learn, easy to write, it's very fast, very memory efficient, and people have been very successful building stuff with it. But it comes with some limitations. For example, if I move this code into a function, the compiler can no longer see it and the text doesn't update. If I have my very large object with many properties and I update one of them, anything that cares about my other stuff will also get invalidated. And if I mutate an array, nothing happens until I tell the compiler that it's been invalidated. But perhaps the biggest limitation is that the variables that become reactive like this are the ones that are declared at the top level of a component. If I want to have some reactive state that's, for example, shared between multiple components, then I need to author things in a completely different way. Svelte 5 fixes all that. Instead of having implicit, component-based, compiler-driven, variable-level reactivity, we now have explicit, universal, runtime-driven, fine-grained reactivity. If we migrate our example component from before, we're now annotating count and doubled with something we call runes. And beyond components, we can also use runes in JavaScript and TypeScript modules as long as they have .svelte in the name. So we can easily share reactive state and encapsulate logic. In some ways, we're becoming more like other frameworks in that we're using signals as the basis for our reactivity. But we're also very much doing our own thing. Because we're a compiler, we can have better ergonomics around signals. Candidly, we don't think other frameworks have nailed this. And we can have better performance, at least according to this third-party benchmark. There's so much more that I'd love to share with you about Svelte 5, but for now, I'll leave it at this. Svelte 5 is going to be easier to learn. The framework is simpler than ever. It's going to be easier to use. You'll be able to write even less code. And you'll be able to write better apps, smaller, faster, and more robust. And perhaps biggest of all, this rewrite is a foundation for a ton of ideas we have for the coming years of web development. It's coming real soon, and I hope you'll give it a try. Before I go, because this is ViteConf, I'm going to talk momentarily about SvelteKit, which is our Vite-powered application framework. One of the things that we're most excited about is the environment API coming in Vite 6. When you build a SvelteKit app, you can run it wherever JavaScript runs, on Node, on Burn, on Dino, on Cloudflare, or if you're a person of good taste, Vercel, really anywhere you want. But when you're developing locally, everything is running in Node because that's where Vite runs. In the future, we'll be able to use non-Node runtimes while developing locally as well, which means it'll be possible to use platform-specific APIs in your app like Bun, SQLite, and things like that. You'll even be able to mix and match different server runtimes in the same app. It's not quite ready yet. We're talking to the Vite team because we kind of need the API to have some things that it doesn't yet have, and so I don't have anything to show you today. But I think the Vite world is on the cusp of some really exciting changes. That's all I got for now. See you next time.
let's talk about how Vite made Remix better. So Mark and I both learned a lot as we migrated Remix onto Vite, and there's just too much to talk about there. So instead, today, we're each going to pick one thing to highlight. So I'd like to start by talking about server code removal in Remix. So this is what a route in Remix looks like. Let's say we've got a loader here that is supplying some data, and that's running on the server. And we've got a component here that's in charge of using that data to display something nice to our users in their browser. And this one file is actually contributing to both the client and the server bundle. And that's nice ergonomics, but it means we have to be really careful to make sure that server code doesn't end up in the client. We don't want weird things happening like the browser to try to access files and that crashing. And even worse, we don't want any secrets or sensitive information from our server to get leaked on the client for anyone to see in their browser. So this loader has to go when we're building the client bundle. And not only that, we have to make sure that we don't leave any dangling things like this DB import here around for the client bundle either. We don't want that module to be polluting the browser. So we just want to end up with the stuff that is really designed for the client, like this. And the way we were accomplishing that is we were using tree shaking. So with ESBuild, prior to our adoption of Vite, we were just adding a virtual module in front of our routes. In this case, we've got this one client post that is just giving a view, a client-based view of this post route, and it's just re-exporting things from that route. And specifically, it's only re-exporting the things that are safe for the client. In this case, the default export. And so when a bundler like ESBuild looks at this, it realizes that the only interesting export in this module is the default one. All the other exports aren't being asked for, so we can get rid of those. And anything that those exports depended on that isn't being depended on by the default can go too. So it just tree shakes away all the rest of this code, and it does the server code removal for us, which is fantastic. Bundlers like ESBuild are really good at optimizations like this, right? And that's something that we got when we moved to Vite, because Vite is using Rollup under the hood. So even though it's a different bundler, we're still getting that tree shaking happening for us. And so when we wrote tests initially, it looked like everything was passing because we were just doing a Vite build and then seeing if that looked correct. But as soon as we were starting to be good citizens and actually test the dev server as well, we ran into some issues. And that's because Vite doesn't do any bundling in development. Bundling is expensive and slow, and so it makes sense to do for a production build, but it's sort of antithetical to a fast, good developer experience. So Vite doesn't do it in development. So we were a little stuck. We needed to find a way to remove these server exports. And what we realized was that removing server-only code from route modules is part of Remix's semantics. It's what makes Remix behave correctly. It's not something that we could just delegate to an optimization layer like tree shaking, especially if there's no bundle around. And so we decided to do this as part of Remix supplied transforms so that we could ensure that they always ran as part of your build or in your dev server. So now, if we look at that same post route, we can see that the inspect plugin is telling us that a couple transforms are happening to it. And notably, there's this Remix route exports transform that's happening that we're supplying. And we're removing that loader export. And we're also running some dead code elimination to remove that dangling database import as well. Great. So now we're getting rid of those server-only exports and the things that they depend on inside of route modules. And if you're authoring a new framework today from scratch, I would advise you to just have separate files for these things and don't mix server-only code with client-safe code in a single file. But we couldn't do that option because we're trying to land our Vite integration as an incremental upgrade for people inside of V2, Remix V2. And asking all of our users to refactor every single one of their routes to be two separate files and decide names for those files and come up with new file-based routing conventions that would allow all this, that was too heavy-handed. And so we couldn't use that option. We had to find a way to make this work for our users with the files that they had today. And that's why we chose to do this via AST transforms rather than asking users to split things up manually into separate files. Plus, even if you did do that, you'd still have to solve for a human error case. So let's look at this simple route where now, instead of using a loader, I'm just going to access the database module directly and ask for all my posts directly inside my component. And so we know that this line right here is doing some server-only code, and it's going to end up in the client bundle. And before Vite, this is something you could have done in a Remix application, and you wouldn't really know that this was an issue. Things might build just fine. If you never visited this page, maybe your smoke test didn't exercise this page either, and you never knew that something was wrong, and so you shipped this to production. But we know that as soon as you visit this route, something here is going to go wrong. Either things will crash, or if somehow this database query runs, you might leak some weird information to the client. So we need to get rid of this import as well, and that line too. So how do we deal with this case and just make sure that people never do something like this? And what we came up with was .server files. So by adding a suffix, .server in this case, to these modules, we could tell Remix that this was a special way to know that this was a server-only module that was being imported. And by knowing this, Remix could actually give you much nicer build time errors. So rather than this ever landing in production, we could tell you in your CI or in your dev server that something was wrong. And this is what that looks like. If you ever accidentally import a .server file and it's still there after we've done removal of server-only code in your route modules, you're going to see an error like this one. And so it's going to tell you, hey, there's server-only code ending up in the client. It's coming from dv.server. It's part of this route. Here's what you can do about it. Here's more information. So we think this is actually a really nice solution. And getting those build time errors is so much better than seeing this just blow up at runtime. So we learned a lot, and we actually wrote 2 decision documents about all the things we learned. One centered on tree shaking, and the other on client-server separation. But at the end of the day, the way to summarize those 2 things is that we really need explicit server separation. We know what exports are server-only in Remix, so we can handle those for you, and we've added .server files so that you can tell us what things in userland are server-only as well. And all of this is now statically enforced, and you get build time errors instead of runtime errors that you might have never caught. So this is, I think, a really fantastic way that Vite helped us rethink some of our design decisions and make them better. And now let's hear from Mark and see what example he picked.
Hey everyone, my name is Mike Dalgleish, and for part 2 of how Vite made Remix better, I'm going to be covering the topic of CSS bundling. Now, in Remix's original ESBuild-based compiler, Remix introduced a novel approach to CSS, which is that when you import a CSS file, what you get is a URL to the CSS file that you want to render into the page. This pairs well with Remix's ability to attach link tags to any nested route. So here you can see we're taking the href that we imported earlier and we're attaching it to a link tag. So rounding out a full page, it might look something like this, where what we're doing is importing the styles as an href, we're attaching it to a link tag, and then the component for this route is able to freely access the styles that have been injected into the page. This model is super simple and leans into web standards, which of course is something that Remix has become well known for. It's just regular old CSS files attached to nested routes. But this approach didn't come without its trade-offs, namely that it introduces quite a bit of boilerplate for reusable components in particular. So for example, if you have a shared button component, whereas typically you might think that all you need to do is import and render the component, you now also need to think about its link tag so that it has any necessary styles injected into the page alongside it. The challenge with this, of course, as well, is that these component styles are now tied to Remix. So if you are building a shared component library across multiple projects, you now need to think about whether you need to support Remix or non-Remix consumers in parallel. To address this limitation, the Remix compiler introduced new features for CSS bundling, such as CSS side effect imports and CSS modules. And in order to get access to those styles in the page, it still needed to fit into the Remix model of having a link tag in the page. So to do this, what you needed to do was import the CSS bundle package, which provided the CSS bundle href. So the downside of this is it meant that all bundled CSS was in a single file, but this was enough to unblock many people who were unable to port over to Remix. Now, when we moved over to Vite, Vite made us revisit our approach to CSS. And that's because, to its credit, Vite ships a lot of really great CSS features out of the box. So you don't have to install any plugins to get all of the standard CSS features you might expect up and running. So for example, here you can see using import inline and rebasing, post CSS support, CSS modules, Lightning CSS, and so on. So to be truly Vite native when moving to Vite, Remix needed to support Vite's built-in CSS features. The most exciting of which for us was support for CSS chunking provided by Rollup. So that meant that no longer would Remix have a single CSS file containing all CSS for the entire application. Instead, it would be much more like what you expect from JavaScript chunking when using Remix. Now, the way that that works under the hood in Remix via the classic compiler is that each nested route has fields in the manifest that describe which JavaScript files needed to be loaded in order to render this route. So how do we support CSS chunking? Well, we basically need to take a similar approach, which is that when you import a CSS file using a mechanism that implies the use of a bundler, such as a CSS side effect import, what we need to do is similarly attach the assets to the manifest. So in this case, there's now a new CSS field on the Remix manifest that describes the CSS files that are needed in order to render this route. So Vite forced us to make Remix's CSS better, and what we've ended up with here is more portable, more configurable via the Vite config, and better build output. But this still came with one big trade-off, and that's Vite's approach to lazy loading in development. Now, this is obviously one of its big selling points, but it introduces a challenge for CSS. And that's because when you import CSS in this way within a JavaScript file, there's really no native counterpart that it can directly translate to in the same way it can with JavaScript modules. So in practice, what this means is that that CSS file that you're importing has to be translated into this JavaScript file that in effect injects a string of CSS into the page as a side effect of being imported. This means that the CSS is loaded and injected after the HTML has already been rendered by your server, effectively introducing a flash of unstyled content. Now in practice, I'm sure you've seen that this is not something that happens during development. And the way we fix this is by, during development, again, not during production, what we do is we look at the module graph to figure out which CSS files are related to the routes that are being rendered. We grab all the CSS for those routes and inject them into an inline style tag in the page. So this fixes the problem, but introduces a new problem at the same time, which is that CSS differs between development and production. Now, in a lot of cases, and arguably most cases, this doesn't introduce problems, but it can introduce subtle bugs where the CSS in your development environment differs slightly from production. And that's because CSS is much more sensitive to reordering than what you experience with JavaScript. You can't simply take a collection of CSS, slice it up into pieces and reorder it, and then expect it to have the same specificity. So this can lead to scenarios where styles subtly change in your development and production environments. Really not ideal. So how do we take on the classic Remix approach in Vite where we import real CSS files in development? Is this possible? Luckily, Vite also gives us this mechanism of attaching a URL query string to CSS imports. And what this does is give us the same mechanism that we saw in the classic Remix compiler, where you're given a URL to a real CSS file. So given Remix supports this as a first-class feature at the route level for rendering link tags, we can take this output from Vite and simply attach it to the given route. So here what we're getting is, even in development, real CSS link tags rendered into the page, even during SSR. So in development, what you're going to see is a link to a real CSS file as it exists on disk in your source directory, but in production, you're going to get those fingerprinted assets with content hashes in the file names, as you would expect. So here what we found is that Vite has made Remix's CSS better, but thanks to URL, the query string parameter that you can pass to your CSS imports, I think we've helped go the other way as well. And Remix has actually helped to make Vite's CSS better too. So on the topic of how Vite made Remix better, that's it for us today. Thank you so much for listening.
Ladies and gentlemen, get ready to be amazed by magic, mystery, and enchantment. Our next presenter is a legendary showman who's won more than 20 Emmy Awards. He performed all over the world and is considered the greatest code illusionist of our time. He squashed the first ever computer bug, designed Apple's logo, and using his telekinesis powers, he influenced Alan Turing to create the first ever Turing machine, which was originally a coffee maker. He started the first tabs versus spaces argument and introduced the unsubscribe method into RxJS. No, it wasn't the pull request. He doesn't do pull requests. He only does push demands. Today, ladies and gentlemen, he is going to blow your mind. Please give it up for the magnificent Shai Reznikov.
Thank you, and welcome to the magnificent Shai Reznikov show. And today, you are about to experience magic. Wow, magic. And now, I will need a volunteer from the audience. You, come to the stage. Hello.
Hi.
What is your name?
Bonnie.
And what do you do for a living, Bonnie?
Well, I'm a software developer.
Oh, that's nice. And tell me, Bonnie, do we know each other?
No, we definitely do not know each other.
Good. So prepare to be amazed. It's now time for more magic. My shirt is white. Now, I want you to think about a problem you're currently facing.
Okay.
Wait, I sense that it's something related to the project you're currently working on?
Well, yeah. Now that I think about it, how did you... We do have a big issue in our project.
I see it. It's something about loading time. And as your app grows, the more manual optimization you need to do.
That's amazing. How did you do that?
I have special powers.
Yeah, every time we add something, we have to go file by file and lazy load it, or else our users complain.
Oh, those poor bastards.
We thought using server-side rendering would help us get the best user experience, but it didn't.
I hear ya. Oh, wise cat.
I'm not a cat.
What if I told you that with my magical powers, I can make all of your problems disappear?
Oh, that would be amazing.
Okay, since you're such a nice cat.
But I'm not a cat.
Let's go and see a magical demonstration. So, your app is slow when it's getting bigger, huh? Well, this is because of hydration.
Oh, yeah, I remember something like that. What is it again?
Hydration is part of the process of server-side rendering. After a route gets rendered on a server, the HTML is being sent to the client, and then JavaScript is downloaded and run in order to make the app interactive. This is called hydration, like rehydrating fruits or something like that. Now, watch this. Here, on this tab, I've taken an hydration-based technology, fully optimized and built for production, and I removed everything except one input and a text binding. So every time you type in the input, the text updates below. Simple, right?
Wow.
Wait, that's not the magic yet. I then took another cutting-edge iteration-based technology and did the same exact thing. Removed everything and just kept one input and one binding. You see?
That's amazing. Look at how the text is being updated on the screen. How did you do that?
We still haven't got to the magic. No need to get too excited prematurely, cat.
I'm not a cat.
Now, let's go and see the third tab. Here, we have another page, but this time full of components with lots of interactivity. As you can see, we have animation, we have charts, and we have a full-on data grid where you can switch pages, you could sort, and you could also filter and select everything. So, full interactive page. And at the top, you might notice the same input and text binding.
Okay, is this another hydration-based framework?
Oh no, this is something much more magical. And in order to demonstrate its magic, let's go back to the first tab and open the browser in incognito mode, so no caching, and simulate a slow network connection. Now, let's load the first technology and try to notice when this app becomes interactive. Let's count together. Count with me. I hit enter and 1, 2, 3, 4, 5, 6, 7, 8,
9, 10.
You see?
Oh my god! 8 seconds is a lot.
Yeah, well, it needs to load all the JavaScript, parse it, and run it until it's ready to respond to events. That's the reality of every modern framework these days.
And it even deleted all the previous text.
Yes. Now let's see the second example. As I mentioned before, this is another popular iteration-based JavaScript framework. We'll again simulate a slow network connection. Now, let's run it and count. Ready? Go! 1, 2, 3, 4, 5, 6, 7, 8, 9. This time, it didn't delete the text, but it still took 8 seconds. And think about it. This is nothing but an empty page with just one input and one binding. Very, very simple without a lot of interactivity.
Oh yeah, and my app has many more components and pages.
Yes, and in the fact that...
Many more.
Are you done?
Many. That's it.
Okay, now starts the magical part. Let's move to the third tab. Now, this might look like an ordinary page, but in fact, I casted a spell that makes it load instantly, no matter how much interactivity and JavaScript it has. We'll do the same exact thing. Let's simulate a slow connection, and remember, this time there are a lot more interactive components that need to be loaded, so it should take longer.
Oh yeah, I bet it will take like at least 30 seconds to load.
Let's see if you are right. Try to count together with me.
1, 2, 3.
Wait, stop counting. It's already interactive on the first input. Magic.
Oh my god! Oh my god! That's incredible! How is that even possible?
Magic. Okay, you can go back to your seat now.
But what about the money?
Never mind that now. Let me continue with the show.
Wait. Stop the show, everybody. Stop the show.
What? Who are you?
Hi, I'm Shai Resnick. I currently lead the core team behind the JavaScript framework Qwik, and I'm also the founder of HighRes.io, where we make web development fun and efficient through consulting and entertaining online courses. But I'm also a professional mythbuster, exposing frauds like this magician here.
How dare you? I was born with these powers.
Oh, really? Let's see, shall we?
First of all, the third tab that you showed is not fast because of your magical powers. It's because it was built with Qwik, the framework I mentioned at a part of its theme, so you cannot really fool me. So unlike other server-side render frameworks, which rely on hydration to make the app interactive by rerunning JavaScript on the client, Qwik is built from the ground up on a completely different foundation. To explain it, we use the metaphor JavaScript streaming. It's like video streaming, but for your app.
What? How do you stream an app?
You see, Qwik breaks your app into tiny bite-sized segments. In general, every function becomes a separate segment. It then renders the HTML on the server, but instead of sending just a plain HTML file, it encodes in it a lot of important information like what is the structure of the app, where are the event listeners, where are the component boundaries and such, and sends it to the client. Then on the browser, Qwik starts buffering the necessary segments of interactivity in the background. So by the time the user performs an action, the code they need is already there, ready to go. And then the framework only needs to execute it, not to load. That's why we call this last part lazy execution, which is very different from lazy loading. Again, because everything is being encoded on server render time, there are no hydration delays, no waiting for JavaScript to load before interacting and such. Just instant interactivity. And the best part? Everything I just said is happening automatically for us, so we don't have to even think about manually breaking it apart and adding dynamic imports everywhere and such. Qwik is handling all of that. Oh, and this instant loading benefit also helps improve your SEO ranking and conversion rates because your page loads faster than ever, no matter how big your app gets. And both Google and your customers love that.
And that, by the way, why this framework is called Qwik. So as you can see, this magician didn't use any special powers. It was Qwik and JavaScript streaming all along. And with that, this magic is fully debunked.
Damn it! You ruined my entire show! Okay, I cannot work in these conditions. I am leaving. Good luck.
Well, that was awkward. I just wanted to...
Shai?
Yes, Bonnie?
I have a question.
Go ahead.
So, Qwik is great for marketing websites, right? You know, SEO, conversion rates. But what if my app is like a dashboard and it's behind a login screen? Should I use Qwik for that as well?
Let me ask you a question. When you started your app, it was small, right?
Right.
And now it's bigger, right?
Yeah, Sherlock.
Yeah, but what I'm getting to is, like, your app is now bigger and you said it yourself. Like, are your users happy with the time it takes your app to load now when it's bigger?
Oh, I see what you did there.
Right, but seriously, our attention span as humans is getting shorter and shorter each year. So people are more likely to lose their patience and to start develop negative feelings about your product. With Qwik though, you get the best of both worlds. Whether it's a simple marketing site or a complex app, Qwik scales seamlessly, so your team only needs to learn one technology, and by that saving both time and resources.
Okay, but Qwik is still pretty new and risky, isn't it? Is it fine to start using it in production?
Well, that's a very good question, Bonnie. And you're right, Qwik is relatively new, but
we already have a great ecosystem around it. From Qwik UI, which offers both headless and style component libraries, to localization, authentication management, testing tools, and deployment integrations for every platform. And with time, our ecosystem grows as more developers and companies adopt Qwik.
But what if I need a certain component that doesn't exist in Qwik?
Well, you can always Qwikify it.
What the hell is that?
Well, Qwik allows you to take any React component and turn it into a Qwik component. And it's a temporary solution you can use until the component is natively built for Qwik. And that's why we have it, in case something is missing in the ecosystem.
Oh, okay. I don't know. I'm still afraid about, its stability and whether it will still be maintained in the future.
I hear ya, and it's a valid concern, so let me address it. Recently, Qwik has gone through some pretty exciting changes. It became a community-driven project, and shout out to Builder.io, our special sponsor who made that possible, and as a result of the transition, the core team grew to over 9 members. We're currently actively maintaining version 1, and soon we'll ship the upcoming version 2, which will reduce the amount of code sent from the server even further, meaning faster load times without any extra work. We also invested a lot of thought and time into building an amazing and friendly community where developers feel comfortable asking questions, helping each other, and at times also being fun and silly. We even published an RFC process, so now the entire community can have a say in Qwik's future. As for stability, we rolled out a new project management process to release versions more consistently, and we have a team of alpha testers that verify the upcoming versions are stable before they are released. Soon we're also planning to add an ecosystem CI, inspired by Vite, to make sure our ecosystem is stable as well with every new version. And thanks to our sponsors, we're making sure that the core and ecosystem continue to grow.
Okay, looks like you're taking things seriously, which is good.
Yeah, we're very committed to fulfilling our vision and our philosophy.
Which is?
Well, in 2 words, automatic optimization.
And in more words?
You see, our vision for the web is one where developers like yourself can stop worrying about these annoying manual optimizations because, everything will be handled by the technology itself and AI.
Oh great, here come the buzzwords.
Well, you asked for more words, right? But seriously, in the future we are aiming to add more and more automatic optimizations to Qwik's abilities. One example is predictive buffering.
Huh?
Well, you remember the lazy execution thing from before, right?
Yeah.
So Qwik can collect anonymous statistics about the execution order of functions, and it can do it automatically. These stats can then be fed to a model that produces instructions for Vite and Qwik on how to bundle these segments together and in which order to buffer them to produce the most optimal buffering experience. This leads to users never experiencing any delays, because Qwik can predict which code to buffer based on actual real-life usage. And hence, predictive buffering.
Oh wow!
Yeah, and guess what?
What?
It already exists in beta. We call it Qwik Insights, and it's currently running on the Qwik docs and more apps in production.
No way!
But wait, there's more!
Ha! You sound like an infomercial.
What if these statistics could be used for other things? For example, since we already know the average user journey, we could train an AI model to create end-to-end tests based on that data automatically. And with the same statistics, we can identify code that isn't being used at all, and another AI model could remove it, like actual dead code elimination based on real users and their behavior. But it doesn't stop there. Imagine automatic refactoring, A/B testing, and much more. These are some of the automatic optimizations we would like to see for all web developers in the future. And we believe that Qwik's innovative foundation can lead to that future faster. That's why we believe in Qwik's philosophy so much, and also why we encourage everybody to give it a test run and see for yourself. And also, if you would like to participate in our community, this is the link to our Discord, where you're welcome to come, say hello, participate in the chat, ask questions, see for yourself how friendly our community is. And also, we encourage you to join and contribute PRs for bugs, going over docs, proposing fixes, triaging. This is a truly community-driven project, and would love everybody to participate in our community. And by the way, a great place to start is our Qwik introduction course, which is taught by both Mishko Hevery, who created Qwik, and yours truly.
Are you truly mind shy?
Always, Bonnie.
Kiss me, you fool.
Wait, before you do that, want to see some real magic this time?
Of course.
Watch this. It was me all the time. There is no shy Resnik.
Oh no, who should I kiss now?
Watch the course to get a quick start.
Hi folks, my name is Chris Manson and I'm here to talk to you about Ember.js and how we are unblocking our future with the help of Vite. So let's first off start with a bit about me. My name is Chris Manson. I am a senior software engineer at MainMatter. I'm an open source fanatic and I've been using Ember for about 13 years next month. I have 2 dogs, 2 kids, and I live in Dublin, Ireland, where it rains most days, so I have extra time to stay inside and hack on open source. This talk will have to do a little bit of work on the history of Ember before we even touch on why Ember using Vite is an interesting topic. But once we cover the history, I'm going to jump into a tiny code example that should help to illustrate how Ember and Vite working together and why it is even a challenge in the first place. So first things first, what even is Ember.js? Ember is a 13-year-old battery-included front-end framework. 13 years, that is positively geriatric if you consider the pace of new frameworks coming out. And though it's been around for a long time, that doesn't mean it feels old when you're using it. We have managed to innovate pretty deeply over the past 13 years in such a way that's not really sacrificed your stability of your apps. And what do I mean about innovation? So first of all, we had classes. Classes in JavaScript actually happened with the help of Ember. Ember core team members were working with TC39 at the time that they were being added. Also, ES modules, we were using them as part of our authoring format before they were even added to JavaScript. And Ember CLI, our baked-in build system, was so ahead of its time that there were very many arguments about whether frameworks even needed a build system at the time that it came out. And since we're all here at ViteConf, I guess the team build system won that particular battle. But with all these firsts, there were a few problems, especially because we care so much about the stability and not leaving anybody behind. Our pre-class class object was the basis of all of the major building blocks of the framework. We've cleaned up most of those, but not all of them quite yet. Our module system, well, it started out as a fake module system where you would import something from @Ember something, and it would essentially be rewritten during build time to Ember source, the name of the package, /something/index or whatever. That is not the biggest foundational system that is relevant to the story of Vite, though. The biggest piece is Ember CLI, our actual build system, and the underlying technology that drives it. Broccoli.js. Now, I'm not here today to dump on Broccoli. I actually loved it as a build system and built a whole bunch of tools and projects on it, but it had some fundamental assumptions that were not really compatible with the needs of modern build systems. Broccoli at its heart was just a file layering system. It came out in the days of Grunt and Gulp and was actually really sophisticated compared to those other build systems. Sure, it was sophisticated for its time, but Broccoli had a core assumption that your files are represented as a tree, essentially the same way as your operating system looks at them. The cool thing about the Broccoli tree system was that you could create a pipeline and files could be changed, files could be added or removed, and it was really quite powerful. But I wonder if any of you watching can see the issue with a system like this. It doesn't really match modern build system concept of starting with an entry point and walking your module graph. With Broccoli, you have to work on whole trees at a time, and you have very little knowledge about which modules are actually being used. So you can't really make the build any more efficient, you can't do any code splitting or tree shaking. So how do we marry these two worlds? How do we bring Ember into a world where you need to understand the module graph? Well, Embroider is our answer. Embroider is like a semi-magical glue code that bridges the gap between the old way of doing things in Ember and the new way. It allows you to use all of your existing Ember concepts like add-ons, like strange fake modules that I described, automatic file discovery and all that, but it essentially pre-processes all of your Ember CLI-based Broccoli tree shenanigans and outputs a semi-pristine app that a bundler can look at and do its magic. So, woohoo, problem solved, let's ship Embroider to everyone. Not so fast. The previous version of Embroider only works with Webpack, and it wasn't all that big of a sell for people. It would work maybe 80% of the time, so most apps could probably use it, but when it broke, it would break in weird and wonderful ways, and they were kind of hard to understand. Some of this was because Webpack's errors can be cryptic at the best of times, but one of the fundamental issues that we were facing was that we were crowbarring a bundler into an outdated build paradigm of these Broccoli trees. Even Webpack wasn't designed to work that way. So we were stuck without a plan until Vite. Vite started being the new hotness, and people were excited to try and get Ember working with Vite, but oh boy, was it not so simple. A few things made it quite difficult. Firstly, Vite didn't really want to be crammed into this clunky Broccoli tree structure that I was talking about. For the magic of the Vite dev experience to shine, you really need Vite to be running the show. Vite needs to be in the driver's seat. Embroider needed to start taking a back seat and only answering some questions when Vite asked. We called this re-architecture inversion of control. So we would run Vite with an Ember or Embroider plugin rather than running Ember CLI with a Vite plugin. The second issue that we had was that Vite takes ES modules very seriously. Sure, we were pioneers of the use of modules in Ember, but that was mostly just the authoring format. Ember CLI actually rebuilt everything into AMD modules under the hood. Not so great, but what was worse is that even in the Embroider and Webpack was doing its magic, it all boiled down to a horrible AMD with Webpack eval monstrosities in the build output. Can't really see it in this example, but there's a bunch of AMD requires and defines in that eval script there. Not great. So if we were serious about getting Ember working with Vite, we needed to get serious about modules and clean up our act. So now we had essentially the bones of a plan. We know that we wanted to get onto Vite, and there was a ton of work still to do. It was going to take a long time for a fully open source community project like Ember if we didn't change the script. And we did change the script. I have had the absolute pleasure to work on the Embroider initiative, which was a coming together of a lot of the big companies using Ember to fund work specifically on getting Ember ready for this new wave of build systems. The headline deliverable of this year-long initiative was to get Ember apps building with Vite, and I am pretty happy to say that we succeeded. If you want to try out running an Ember app using a blueprint that sets it all up for you, you can run this script. We are currently in the process of making this so seamless that it's the default experience for every newly generated Ember app. And if you want to follow along on that process, you can find the RFC that covers that at this link. So now that I've gone over the history of Ember and the exciting future, I promised you a bit of a deep dive into how Ember does its work with Vite. So let's get into that. Here is essentially the heart of the Vite plugin, the Embroider Vite plugin. At first glance, the plugin isn't doing all that much. We have a custom resolver thing there that we pass a request into, and if it finds a thing, great, no big deal. What's fun is when you look under the hood of that resolver. the resolver loader there locates a temp folder near your current working directory, and that's where the Ember pre-build has output a bunch of metadata files that tells our embroider resolver what to do with a request. So I said a lot of words there. We might need to back up a second and ask what even a pre-build is doing. I mentioned that embroider allows you to use all of your normal Ember build shenanigans, Ember broccoli build shenanigans, but it still allows you to upgrade to using modern tooling. Well, that's because we convert all of your broccoli nonsense into real packages. So we have a stage 1 that converts all of your add-ons for you, and a stage 2 that converts what we need out of your app. And then we pass that off to stage 3, which is just passing it on to your bundler. And if you were thinking you might approach something like this by, emulating the Broccoli API and kind of mocking it out, I would say don't even try it. It's not even possible, because Broccoli is a strange, kind of slightly tangled mess of timing specific things that is next to impossible to pick apart without the whole thing coming crashing down. So what's the solution? Well, why don't we just run the strange broccoli stuff and save the output somewhere? Then you can clean up that output a little bit, make it look more like a reasonable package, and hey presto, you have created yourself what we call a rewritten package. This brings us to the first bit of metadata that we need to save. What packages were rewritten and where did we rewrite them to? I'm going to skip through these examples pretty fast. You see at the bottom of this example, there's this active add-ons array. In there is a package called Ember Test Helpers that has a root that, if you look real closely, you can see it's in the Node modules embroider rewritten packages folder. I think I can highlight this. Yeah, there we go. This example of how and why we have this rewritten packages is what I want to try and bottom out with less than 3 minutes left on the clock. So let's go back to our code example of the resolve ID. We now know that there's metadata that's automatically loaded by this resolver loader. We pass the request of the current import, the current thing that's trying to be resolved, we're passing that into that resolver. So let's have a look at what that resolve function looks like. This code might look a bit complicated, but it's not all that bad. We can summarize it simply as, let's check to see if there's anything that we need to do before we try and resolve anything. Then we'll hand it off to, Vite, Rollup, ESBuild to try and do a resolution. And if it doesn't find something even after that, then we might need to do some extra Ember specific fallback. We're trying to follow the example of rewritten packages. So using my existing knowledge of where things are, I'm going to jump straight to the before resolve to show you where that is. Again, we're zipping through this code pretty fast. So if anybody is curious and wants to know more about it, they can always reach out to me. I'll be happy to walk them through the code in more detail. The file that this comes from is a single 1500 line file. So it's pretty long and it's pretty dense. There's a lot of stuff to cover in there, which we don't have time for now. But the key takeaway of what we're looking at here is that the request is being passed through each of these functions. And each one of these functions has a chance to alter the request in some way. So, time to go deeper. We're going into this handle rewritten packages at the bottom. So, handle rewritten packages is a bit of a large function. This is actually quite a small one compared to other ones in the file. It's a little bit too small to actually look at on a single slide. So we're going to chunk it and see if we can walk through it real quick. Here at the top, we are accessing the package cache to see where this request is coming from. The package cache is essentially the metadata that was loaded from the config file that we saw a minute ago. If the request is coming in from somewhere that we don't know anything about, we just return the request unchanged. The same is true for specifier. So the specifier we call is the actual the import, the actual source, whatever you want to call it. If it's a relative request, we return the request without changing it. Next, we check to see if the target of the request is the same as where it's coming from. So in here you can see there's a comment, a non-relative, non-self request. So it's not, we're not asking for something inside the same package that we are currently in. So moving on, now we've got ourselves enough stuff to start asking more interesting questions. We have info about where the package came from and where the request is trying to go to. Then we have to ask to see if the requesting package or the target package is rewritten. And if they are rewritten, then we can start doing more magical things with altering the request in some way. So this slide is actually looking at how we change the request, but we are unfortunately out of time. So I'll leave this as homework for the viewer to pause the stream and see what's going on. I've only scratched the surface of what Embroider is doing under the hood. So we're in a pretty good place now to help older Ember apps transition over to using Vite without needing to rewrite your app from scratch. The future is bright for the Ember community. And that's it. Thank you for watching. I hope that you reach out to me in any of these places. And if you have anything that you want to ask about today or really anything Ember related. Thank you for watching and enjoy the rest of ViteConf.
Hi, I'm Ram from Vike. What is Vike? We believe Vike to be a next generation front-end framework. You can think of it like Next.js or Nuxt, but flexible with ejectable extensions. With flexible, we really mean flexible. You can use any UI framework. For example, we have a sponsor that is using React and Solid in the same app, which is something I don't think you can do with another framework. We also have a sponsor that is using Vue 2 and Vue 3 in the same app for progressively migrating from Vue 2 to Vue 3. Any rendering strategy, SPA, SSR, SSG. We have a sponsor that is using SPA because it doesn't need server-side rendering. Any data fetching, RPC, REST GraphQL. We have a sponsor that is integrating GraphQL Relay in a way that I don't think would be possible with another framework. Any server, we have a sponsor that is using a Ruby and Rails backend together with Vike in a way that, again, I don't think would be possible with another framework. Any deployment strategy, and in general, any tool. And not only can you use any tool you want, but you can also integrate them however you want. In general, we handle blockers with high priority. For example, if you create a feature request and you explain why it's blocking you, then we will treat it as high priority. We also quickly fix bugs because bugs are often blockers. You can also use extensions for a quick start. For example, if you use Vike React, then you get a quick start similar to Next.js or Remix. If you use Vike Vue, you get a quick start similar to Nuxt. You can also eject these extensions. So, for example, if you eject Vike React, then what happens is that Vike React's code moves from the node modules directory into your Git repository. It means that you get full control over the React integration, and you can then change it to be a completely bespoke React integration. Let me show you quickly how Vike React integrates with Vike Core. Basically, it's composed of two hooks, onRender HTML and onRender client. The onRender HTML hook, as the name suggests, generates the HTML here. The onRender client hook determines what happens on the client side. So for example, for server-side rendering, it hydrates the page, and then on subsequent page client-side navigation, it renders the page. So it's quite simple. And in general, these extensions are simple and very small. So you can think of Vike as being a car, and on top of it, extensions. It's a sturdy architecture. It's for you, and it's also for us. It's also for Vike, so that Vike can quickly adapt to the fast evolving JavaScript ecosystem. For example, there have been a lot of changes with data fetching approaches in the last couple of years, and there are probably going to be a lot of changes in the next couple of years. And Vike will be able to quickly adapt to these changes, to these new approaches. As I said before, these extensions are relatively simple and relatively small. This enables us to create a lot of extensions and to maintain them for a long time. This means we can support legacy technology for a very long time. For example, if you don't want to use server components yet, you can go for the classic React stack, and we will be able to support you for a very long time. These extensions, they don't exist yet, but it's very much our goal to create many extensions so that you have the choice. Yeah. The current release is already stable. You can already use it in production. Many users use it in production for mission critical applications. Our sponsors, for example, use it for mission critical applications in production. But there were a couple of essentials missing, and that's why we didn't release a V1 yet. But we're getting very close, and there's only a couple of things missing, lots of polishing, and then we will release a V1. And once we release a V1, we'll be very confident that Vike is an excellent front-end tool to create modern applications. Beyond the V1, we are focusing on making Vike extensions as powerful as possible. The JavaScript ecosystem has a lot of high-quality tools, but there's one thing missing. It's a Ruby on Rails or Laravel for JavaScript. And we believe powerful Vike extensions is the way to get there. But I don't think we can build that future. It's quite an ambitious future. So I think we need a lot of manpower. And I don't think sponsoring alone will allow us to get there. I'm very grateful to our sponsors. They have been a tremendous help. So I really feel grateful to our sponsors. If a sponsor is watching, then thank you. But the issue with sponsoring is that it's not reliable. You can imagine there's a major financial crisis, then the first thing that companies will cut is sponsoring. I don't think a sustainable business can be built on top of sponsoring alone. We need a proper business model. We've been thinking a lot about it, and we had a lot of internal discussions, and I think the holy grail here, what we all want, is we want code to stay 100% open source, so no compromise on what makes open source special. But larger companies have to pay. Now the question is, how do we get there? And I believe we found a solution that will work. So the code is 100% open source, 100% MIT license. Everything stays 100% free for engineers. Only companies pay. Companies who cannot afford it can apply for a form to get a free license key. The form is really simple. It's a small form, just 2 or 3 sentences explaining why it cannot afford a license key. We review it. If it makes sense, then we give out a free license key. Also, one thing we want to try, it's experimental. Let's see how it goes. We want to make it that companies pay as much or as less as they want. So it means the companies could be sponsoring, could be paying only $1 a month. Yeah, it's going to be an interesting experiment. Let's see how it goes. But if it doesn't work out, then we will actually enforce a pricing. But again, if a company cannot afford it, then it can apply for this form and get a free license key. 3 months free trial, so you can just try Vike and see if you like it. And the way it works is really simple. In production, it shows a pesky toaster, get your free trial license key at blah, blah, blah. And to remove that pesky toaster, you have to get your license key. So Vike stays 100% open source and 1% accessible. Everyone can use Vike. It's a win for everyone. Yeah, we're really excited to try this out. I really believe it's what we all want. 100% open source, 100% accessible. Companies pay a small amount, and in exchange they get a tool that is much more robust, much more sustainable, with a lot more features. Yeah. That's it. Thanks for watching. If I piqued your interest, then go to vike.dev, poke around, see if you like it. Reach out if you have any questions. We're responsive. Thanks for watching. See you around. Bye.
Hi, we're just back to check up on you, making sure you got your drink, you got your snack. There's been a ton of amazing talks so far to keep up with, and we are not done yet.
Yeah, it's getting late for you actually, and for me also. But the energy of the chat is what keep everybody going. So thanks a lot, like all the communities that are like interacting and chatting together and collaborating today. Yeah, let's keep it going. So we are going to a little break, and then afterwards we're going to have the ecosystem talks. And yeah, your talk is coming too, so I'm very curious about that one.
And I think this would also be a great time. We've been so happy to have you in the chat. Go tell your friends. Bring more people. Go to social media. Have you been enjoying it? Let people know. Tell people it's not too late to come join in, because there's a lot left.
Yeah, it's true. And for the people that are in the chat while we are in this break, I really wonder if somebody have solved the ViteConf postlet, like the pyramids. So if you go to viteconf.org, you can press like run code there and try to solve it if you haven't. So yeah, we can do that while we wait for the next talks. So yeah, let's go for it. Like for a lot of people, this is just starting. So yeah, see you around.
Hello everyone, welcome to ViteConf. Did you know there's a myth where if you say performance 3 times, your code will instantly get 10 times faster? Turns out I tried that, but it didn't really work. So that I wrote this talk up so that I could teach you some of the performance tricks that I learned myself instead of that weird myth. So let's get going to that. So I'm going to talk about some kinds of performance, ways to identify them, ways to measure them, and then to fix them. And I'm going to show some examples of the journey so far what I've learned. And to start off, the characteristics of performance, there are many characteristics. So identify one of them is making it efficient. So we do things directly and minimally. There's also doing things less, using less code to do the same thing. And there's also resourceful, which is using what's available in your runtime or environment to do the things that you need to do. So quick examples here, you have, instead of using .map, filter, and then reduce, you could just use a simple for loop and then externalize variable to do the same thing. While environments could optimize the .map, filter, reduce. Sometimes it's better to do things more directly and just ease the environment to do more what you need to do. Another example for less is that, if you're only using a subset of library features, maybe you only can use a different library, which only do that thing specifically. Or maybe you could implement your code if it's much simpler and you don't have to handle a lot of edge cases. So that's one example you could do. And another one is using worker threads to run heavy tasks in parallel so that you don't overload the single thread. And that kind of reminds me of this meme where, core one is doing all the work and then the other cores are not doing work. So this is the kind of performance that you could expect, and then sometimes they overlap between each other. And to identify the opportunities, I think there's many ways. One of the type of opportunities is something that's vague. So vague opportunity is something where the customers or your library users tell them that something feels sluggish, or something takes very long to do an action, maybe your npm install just too slow. So these are kind of vague opportunities where there is a clear problem, but you don't really know where to start. And then on the other hand, you have more specific ones where, an input causes an unnecessary re-render, the server takes a long time to process certain data, or you have a lot of large dependencies in your node modules. So these are specific things that you could nail into and to debug. So something that's actionable. And ideally, what you want to do is to turn these vague opportunities to something specific so that we can act on it. And there are many tools to do this. These are the kind of tools that I use myself. And there's probably more. You could check it out. So I have some screenshots here where this one is the Chrome DevTools. And this one is the Performance tab of the Chrome DevTools. This is the Firefox DevTools. This is perf.link. So the fourth one here. There's also some Node Inspect, PRK, and Chrome Inspect, which I'll show later in the examples, which is something I also use quite a lot. And there's also this one. This is packagephobia.com. And this is npm graph, which is very helpful for me to debug in the dependency graph in node modules. And there's many more here which I'm not going to show, but you could check it out and find what works for you. So the next thing is to try to figure out where you can improve your performance, which is probably the hardest part when you try to do this kind of work. But I'm going to show some examples here. So usually my flow is that I work with node projects more often. So with Vite apps, Astro apps. Sometimes if you're using a website or an app in the browser, maybe you have a different workflow, but most of the time it's going to be working similar like this. So I run the project with Node Inspect PRK, which is something I showed you. It will look something like this, where you start the Vite dev server over here, and then it's going to wait for me to listen. I'll open up Chrome Inspect. It will have an inspect here, which I'm going to click on, and then a DevTools pop up. It's going to show the performance tab. So this one is where I'm going to record the performance of the app. It's going to auto start the Vite dev server right in this terminal here, and then going to do some things and then record it and then end record, and then I'm going to download the profile, the CPU profile here, and then going to show in speed scope. So this is a website that I find very useful, especially the left heavy view here, which I'm going to show later on, that you can identify the heaviest part of code that's taking the most time. So yeah, this is one of the PRs that uses that flow. This is, I think, one of my first PRs where there is a package that resolves package.json files, but it is a very generic library that resolves any other files as well. So I realized maybe you could do it directly maybe something simpler, just like an idea. And then at the end, got out to 4 times faster performance. So it's efficient and less. And the way they debug it is something like this. So before CPU profile, I noticed that there's many like file system operations going on. You can see there's a lot of things going on. Overall, it takes like 1.5 seconds over the entire build. And then after that, after this, you notice that there's much less file system operations going on. Overall, it takes like around 600 milliseconds. So a lot of things are just trying to observe like things, something like before, things that are just weird and things that you think that you could optimize better to a specific task, and then just try to compare it and see that, you know, it improves performance overall. And this is just one way of it. There's another example here using worker threads. This is not a PR by me, it's from Safi, who implements using threads for processing CSS files. So if you have like a lot of CSS files in your app, you might be a bit slow. The processing will happen in the main thread will slow down. So if you offload it to a worker thread, you're gonna use more of your CPU cores. It's gonna be faster. So in some apps, Shopify found that it was 1.4 times faster. So this is pretty neat. In the end, this is like a very resourceful performance optimization. It's using all the cores in the app in your laptop. And this is probably one of my hardest optimization that I've done, which is to reduce memory usage. So this one, and it doesn't use the performance tab of the Chrome profiler, it uses the memory tab. So what I did in the past is just recording the memory, and then it gives a lot of entries for each object or strings that's taking up memory space. And just most of the time I'm just like figuring out what's going on. Why is it occupying too much memory? So in this PR, I realized that, you know, there's every AST in all the modules, when Rollup bundles it, including things in node modules, it keeps in memory altogether. So I realized that you could reduce it so that you don't have to keep everything in memory and only compute it dynamically. And overall, this is just quite of a difficult task, which is not always easy when you do performance work. But in the end, it uses less out of memory errors, which is awesome. And this is also quite a resourceful, using less memory so that you could have more memory for different operations. And then the last example I have here is something that not my idea. I think it was Chris and Emma was trying to figuring out. When you're doing static site generation, you don't really need like to stream the HTML to the file. So you pretty much only need the string and then just write to the file. So this is what it's actually doing. So in this case, it's not really about performance and benchmarking. It's more like an idea where you just think about this problem and just think about maybe like different ways to do it. And so performance is not always about measuring, but sometimes you need to put in more effort to figure out some ideas. But at the end of the day, the ideas pay off. It gives 26% faster performance, which is awesome. And makes things a lot more efficient without breaking everyone. And this is just one of the different ways to figure out like the performance when you're doing performance work. So at the end, there's some considerations when doing that. There's an ecosystem and community. So some considerations that, you know, every improvement compounds no matter how small. Sometimes you're gonna expect like 10 times improvement, 50 times, but sometimes you're gonna be like only 10%, which is a bit unfortunate. It happens to me quite a lot of times. But at the end of the day, this thing compounds. So you shouldn't really be discouraged if something is not as big as you hope. Because at the end, it might help in the future where you have maybe less memory usage. It's going to help in the future, so everything counts. And you should always compare the trade-offs. Make sure that you're not sacrificing a lot of maintenance or readability or the stability of your app if it's becoming like a big problem, if like someone else is working in your project as well. So this is something that you should take into account. You make sure use what works for you, and there isn't like a silver bullet for everything. And there's also the ecosystem community. So performance work like this is a bit difficult. Everyone who does performance work will try to share what they can, including I think Marvin here, who wrote out a blog, which is one of the first blogs that really helped me kickstart off doing performance work, because I wasn't really like familiar with the tools back then to need to do what to measure this. And this helped me quite well. And then there's also another blog here, which I linked to, is one of the performance work we did for 4.3, which I showed earlier as well, one of the Vite PRs, where you can dig into something more in-depth in how we figure out like, certain optimizations. So things like this are pretty helpful. So if you can share of that, that would be pretty good. Because because it's where I learned from as well. And then in the end, you can also join like a community of like-minded folks. So in the past few months, me, Patak, Anthony, and James created E18E, which stands for Ecosystem Performance. You can join in chat.e18e.dev. That's where we links to a Discord server. I learned quite a lot from there as well. There's a lot of many like very knowledgeable folks in there who was teaching, like giving ideas, giving like advices, which is pretty nice. So you could check it out as well if you're interested in this kind of work. And thank you. I hope you enjoy the rest of ViteConf. There's a slides there and a repo if you want to check it out. Thank you. Bye.
A strong, active community contributes to the health of any project, and especially an open source project. More people using your project means more bugs found, more user feedback, more content made, like videos, blog posts, guides, and tutorials, more word-of-mouth advertising, social media posts, and personal recommendations. More people using your project also means more potential contributors to fix those bugs, apply that feedback, build those new requested features, and make sure your project both is and appears actively maintained. If you want to grow the number of people who actively and happily use your project, help others discover, learn about, and use your project, build tools to extend and enhance your project, and contribute to the ongoing development and maintenance of your project, you need a community. And you may already have an untapped resource, your docs. I'm the docs lead at Astro, where I maintain a large, active, open source documentation project with over 1,000 community contributors. Today, I'll share with you why and how to use docs to build and grow your community. So why use docs to build your community? The barrier to contributing is low. These contributions typically don't involve adding tests or reproductions. They can often be made through a web UI and don't require forking or cloning your project. And it's easier to help someone through the process of contributing. Tasks like editing a README file are great practice making GitHub PRs. The cost of failure is low. Docs failures typically don't break the build, and reverting a mistake introduced to your docs may not require another release of your project. With these shorter feedback loops, you can be more forgiving with and take more chances on contributors. You can help them learn your contributing process and culture before they need to learn your code conventions and culture. And they can immediately see and show off what they contributed to your project in the form of content that will reach and help your entire community. Docs is the place that is easiest to onboard with the lowest hanging fruit. Have great docs already? Perfect! You're probably already set up for contributors to jump into an established workflow. Have not so great docs, non-existent docs? Perfect! The bar is low. There is zero risk, only huge, immediate benefits. Contrary to popular belief, docs aren't low-quality contributions at all, and they are so valuable when building community is your goal. A bug fix helps your current users. A docs fix can help you get new users, and that's because your documentation serves so many purposes, even and especially for people who haven't yet used or interacted with your project. Docs are your self-serve, education and awareness, support and reference, marketing and promotion, new user onboarding. Good docs work so that you and your maintainers don't have to, at least not 24/7. Better docs help other people use and promote your project, entice their friends, and convince their stakeholders. Sounds great. How do we get started getting contributions? There are probably already people in your community helping, answering questions in support forums, writing blogs, making videos. These are people who know your project well enough to teach and help others. And these are the people who might be helping because there is something missing or unclear in your docs. They are the ones that know this. Identify them. When you notice them in action, reach out. Acknowledge their knowledge and their willingness to share it. Acknowledge their identity as a helper, because helpers are potential docs contributors. I know this might come as a surprise, but contributing to docs isn't always top of everyone's mind. People often don't connect answering an individual's question in a live chat situation or stream to providing asynchronous, general purpose, official documentation. You can help them connect those dots. Create a process where they can get involved directly improving your documentation, even if they don't write you more docs, or even if they don't think of themselves as a docs person. When you see support conversations, ask whether there's anything missing from docs that could have helped here or prevented this conversation entirely. This is valuable, helpful user feedback, and knowing what needs improvement, what people are literally asking about right now, is the first step to a contribution that improves your docs. If they identify a problem or omission, ask whether they, or the person who just learned something new, would like to help fix it. People want to help, but they do need to feel comfortable, and they might need an invitation. At Astro, we encourage filing issues on the docs repo as a low-friction way to get people involved by simply capturing possible areas of docs improvements. Then, it can be the same person or someone else entirely who picks up the task and runs with it. Maybe enthusiastic, aspiring, open source contributors always on the lookout for good first issues. Okay, do you want to know how to really get a full inbox of contributions? Because no one reads your docs more closely than translators. They spot errors and unclear passages because they have to understand exactly what it means in order to convey it in their language. Astro's docs are an order of magnitude more accurate, more polished, and more accessible because our translators have pointed out clunky passages, vague explanations, or cultural references that don't work in their language. And there's a pretty good chance that means it wasn't really working in the original English either. So we fix it. they fix it. Having translated documentation opens your project to a wider audience. You can welcome more people into the fold and support them with resources in their own language. This improves everyone's experience and helps create a more inclusive global community. And it drastically increases the number of people who can and will get involved, stick around, and contribute. More docs contributions makes it easier to get more code contributions. Your existing docs contributors already know your project and how to contribute. You just need to onboard them to your code. And other potential code contributors will see, through the efforts and activities of your docs contributors, an active, healthy project with a culture of accepting community contributions. They'll see a project that is worth their time contributing to, in part because a culture of documentation demonstrates that you care about people being able to use your project. No one wants to spend their time building you a feature that no one knows about and no one knows how to use. When you have docs contributors who know your project and know how to contribute, it probably won't be long until you have good contributor docs that onboard the next generation. You can build yourself a little self-sustaining contributor generating factory. And soon, your contributors themselves will be handling the new contributor onboarding with the necessary experience, resources, and support to grow your community even more. Now that we're all on board that docs contributions are the way to build community, here are a few practical tips. Don't assume that people know how to contribute to you or to GitHub. Many experienced developers have never made a PR on GitHub or a contribution to open source. They don't know the interface for reviews and suggestions, and they don't know that LGTM means let's get that money. Make issues yourself instead of jumping to make small fixes. Many potential contributors are looking for small or easy contributions they can make to get started. Even your regular or occasional contributors often appreciate something small they can do with just a little spare time. The best way to have good first issue tasks they can take is to intentionally leave some fixes for them. I'll even create issues with the exact change I want, asking, will someone add this one line right here? These issues are so popular. People know what help is needed and they know what to do. They can make PRs that are quickly approved, and it's easy for me to welcome them to Team Docs. What might have been just one more annoying little thing on my plate becomes instead a contribution that can make someone else feel valued and appreciated, doing real project work. I was gonna do it anyway. Every single one of these interactions makes someone just that little bit more invested in your project and entrenched in your community. Turn complaints into contributors. You would be surprised how quickly an invitation to participate can turn someone from angry to enthusiastic. Negative feedback is always a little hard to take, and it's not always given gently or tactfully. But much of the time, a response like, "Thanks for bringing that up. Would you like to submit an issue to the docs repo so we can track that?" turn someone into my new best docs friend. When they realize that these are their docs too, and that they have agency, there's a problem with these docs becomes there's a problem with these docs that I can help fix. Nerd sniping is real, and it's not just for code. And be loud about it. Advertise that you're actively looking for contributors. People won't know if you don't tell them. Hold special events or participate in established activities like Hacktoberfest. Make announcements on social media and your community forums reminding people of the opportunities to contribute, and remind them of all the different ways they can contribute. There's more to docs than writing. There's translating, reviewing, proofreading, testing, fact-checking, researching, filing issues, leaving feedback, soliciting feedback, participating in discussions. Make sure your community knows what they can do that is helpful to you, even if it's only one small step in a larger process. And then recognize their effort and celebrate their achievement. People who feel valued, appreciated, and seen will keep coming back for more. Publicly acknowledging the contributors you do have advertises the opportunity to contribute and lets potential contributors know they will be welcomed. And do this for all contributions to your project, not just code. When it comes to open source, good docs is that one weird growth hack and that secret family recipe all rolled into one. An investment in your documentation is an investment in your project, your community, and its future. Plan for success. Plan for docs contributors. Thanks for spending time with me. Let's keep it going in the chat while we watch the rest of these amazing ViteConf speakers.
If you visit the ViteConf landing page, you probably notice this 3D puzzle trying to resolve itself on the top of the page. And you might wonder, how did they build that? But then you go down and you see that there is a code button that if you click, it opens an editor with all the code involved in the creation of this 3D puzzle and its resolve. So you can program yourself the resolver here and try to solve the puzzle. You can also see the Node.js components of the pyramid and the scene itself. And you might wonder, how in the world did they build that? That's what I'm here for today, because I'm going to explain you how the ViteConf pyramid 3D puzzle was created and built. A love story between Node.js and web containers. But before we do that, my name is Álvaro Sabu. I'm a developer experience engineer at Storybook and also a content creator. I'm the author of Node.js, which is the library that we're going to use today to create the 3D puzzle. You can find me in all my networks with @AlvaroSabu, and you can always say hi. So, how everything started. One day, I was chilling on Discord and I received a message from Patek, aka Matias, and he told me like, hey, sorry that is in Spanish, I'm gonna translate it. Will you have some minutes for a call? Yes, I'm just free. I'm in the airport and I have something interesting for you for the ViteConf to talk about. Ooh. So we have a half an hour call in the airport before Patek got into his plane. And the conversation went something like this. Hey, can we build a 3D pyramids puzzle with the ViteConf logo? Oh, sure, it's totally doable. I gotta admit, I had no idea how to build it in that moment. But challenge accepted. First, we needed to think about what in the earth is a pyramid, because in that point of time, I didn't know even that exists. So a pyramid is a regular I'm gonna read it. It's a regular tetrahedron puzzle that is similar to the Rubik cube, but instead of a cube, you have this pyramid kind of thing. So basically the pyramid version of the Rubik cube. So we went to the first step, that was the design. So in this phase, we had two options. We could download a pre-existing 3D model of the pyramids puzzle and just try to make it work with the rotations, or we could create two different models for the two principal pieces and then replicate them. We went for the second option. So we decided to create one octahedron, which is this one, and one tetrahedron. So the pyramid itself is made of 10 of these, which are the ones with 4 faces, and 4 octahedron pieces, which are the 8-faced geometry. So the next step was to build the puzzle itself in the 3D scene. And for that, we're gonna use Tres.js. So Tres.js is a Vue custom renderer that allows you to create 3D experiences as you were using Vue components and composables in a declarative fashion. The way you can install it is by using pnpm or your package manager of choice, add Tres.js core, and you have to install tree as a pure dependency. If you want TypeScript support, you install the types from tree. Then we create the wrapper or experience.vue. This is the Vue component that is going to contain the Tres canvas. So we import the Tres canvas from the core package, and then we add it to the template. Here I am also adding the suspense wrapper for the pyramids. Why a suspense wrapper? Because we are going to do an asynchronous operation in the pyramids to load the pieces inside. So we need to wrap it with a suspense. The next step is going to load the individual pieces. So to do that, we're going to use a composable called use.tltf that is available on the Tres.js CentOS package. Think of this package as the Vue use of Tres.js. So once we import it, we can use it passing the URL where the location of the 3D model is, and then it's going to return the nodes and the materials of the corresponding model. We're going to do the same for the octahedron. And then in the pyramids.vue component, we're going to iterate through an array of tetrahedron that we're going to see in the next slide. And for each one of them, we're going to pass the position, and we're going to pass the model. This is because we want to avoid creating new models whenever we are iterating. Instead of that, we're using the same model for all of them. Same thing for the octahedron. This is how the tetrahedron array looks like. We're creating a ref, and we're using a utility to center all the objects in the scene, okay, just translating the position. And inside of it, we're defining the position of each one of the different pieces because we needed to calculate where are located in the space. We also added some metadata that are the groups, and we're gonna see what the groups are about. This is a preliminary photo that I sent to Patek at the beginning with all the different groups and meshes created in the start. Then let's talk about the rotation, which was probably the most difficult part of all. So this is how the rotation groups of the pyramids puzzle looks like. And I know it's kind of difficult to understand, so I'm going to try to explain it as much as possible. So we have different groups. We have the L groups, which are this triangle here. And then L prime, which is just the tip of this side. Then we have the same notation for the upper group. So the upper group is all this pyramid in the top. And the prime one is just the tip. Same for the back part and the right part. So this is kind of difficult because I actually have the puzzle here. The rotation was tricky because as different as the Rubik cube, this one can rotate like this. So it's an inclined rotation. As you can see, like here, this one is easy. But then if you go to the sides, it starts to be more complicated. So rotating the pieces in the correct motion was complicated. This was one of the first attempts that I did, and you can probably notice why it's so wrong. Okay? Then a lot of math was involved, and I needed to learn new concepts that I didn't know before. So for the inclining rotations, what we end up doing is that, as I explained before, the pyramid process is not structured like the traditional Qwik one. So the rotation axis, where the thing is rotating, is different from the standard 90 degrees of the cube. So here we needed to define all the different rotation axes, and they are conformed by vectors. Okay, the vectors is the representation of the orientation and the magnitude of the axis. So in this case, we have the U1, which is the simplest one because it's just one in the y-axis, but the L1 and the R1, I just calculated manually, okay? And then we have the concept of the angle of rotation. So this puzzle works like this and like this, meaning that it can go clockwise or anti-clockwise. The angle of rotation for this movement, to maintain the same figure, is 2 multiplied by pi divided by 3. And if it's clockwise, it's a negative fashion, okay? So we needed to calculate the angle, and we pass it to the function if we wanted to do the movement clockwise or anti-clockwise. And then we add in the angle. Then we needed to grab all the objects of that group. That was the metadata that we included in the array. And then we use the axis map that we see before to get the rotation axis. Then we needed to calculate the centroid. The centroid is just basically this dot right here, which is the centroid of all the groups. Okay, so we calculated for each group where the center of all the objects was to do the rotation from them. And here we're going to use something called quaternions, which is quite complex to explain. But what we are doing here is calculating the quaternion using the axis angle. So we're using the rotation axis and the angle that we calculated before. And then we are multiplying it, we are multiplying the objects by that quaternion. And what are quaternions? This is quite complex to explain, so I'm going to try to do it as simple as possible. Quaternions are a type of math that is used mostly to make easy the rotations in 3D software, okay, to calculate the rotations because it doesn't have the same problems as Euler angles. If you want to research about it, feel free to search it because it's a complex topic. So to animate the rotation, what we did was creating a function for animation and request animation frame to do one of these every frame per second, okay? And the reason we get the incremental is that we need to calculate the current quaternion and then pass the new quaternion with a slurp. So this is a linear interpolation, but in this case, it's special for quaternions. So we are basically saying how much we're quantifying the animation between one quaternion and the next quaternion, okay? Then we needed to calculate like the time of the animation, and then we set the rotation from the quaternion to affect all the objects that are on that group. And we're setting it to the current quaternion. Then we're calling the request animation frame to run again. This is the result of the animation. So this was without the colors, and you can already see like how it rotates with the rotation axis. But there was an issue with that, and the problem was the consecutive rotations. Whenever we were rotating the pieces, the rotation axis changed. So the pieces now are belonging to a new group. And when that new group rotates, they go off, and the colors went wrong. So the way we fixed it was actually creating temporary groups instead of just adding the objects directly and rotate them. We were creating groups, like 3S groups, and then copy the position from the centroid and adding them to the scene. So then we're taking all the objects from the pyramid reference, and we were removing them from the pyramid and add them to the temporary group. Once we have it in the temporary group, we set the rotation from quaternion like we did before, and then do the animation, and after it, we get all the children of the temporary group and we remove them from it and add it again to the pyramid. So that way, we managed to create something like this. We were rotating all the different groups consecutive and everything was working correctly. Once we had our 3D puzzle working and optimized, the next thing we tackled was the web container integration part. And this is probably the most interesting part of the whole experience because we managed to embed a 3D puzzle into a web page with web containers and an editor, so you can actually edit the JavaScript that is running on this puzzle to complete the solving part, and you can modify it and try to solve it yourself. So how that was done? So the landing page first loads the Thrust.js pyramid as a view component. Okay, when you click the code button, what it basically do is it runs or configures a web container with the Vite dev server to run the pyramid code as it was in a repository. The way you can set it up is pretty straightforward. You have the instance of the web container and then you boot it with your name, so whatever your code is, and then you mount it with certain parameters. Then you can modify or you can set up the editor as you want. You can add the theme that you want to use. This is using Xterm and Code Mirror, okay? So we have a function that allows us to set up the whole thing, and we pass the web container instance that we just created. Then we can install the dependencies. So we use one method of the WC, which is the spawn, and then we are using as a package manager pnpm, and we are telling it, hey, install with this command. Then we're exiting the process, and then we just start the server. Okay, this is going to add the URL into the iframe where you see the pyramid moving around. Of course, there is more to it. So we recompile some tricks and tips that we learned in the process that will help you create a similar experience like this one. So the first one is that you can integrate the iframe for the web container with a transparent background. So the idea of having the transparent canvas and the smooth transition between the original view component and the new one inside of the Vite dev server, it gives it like a seamless experience that is actually the same component when it is not. Then you can pass the key press whenever you're using the keyboard to modify, like solving the puzzle. You can pass them to the parent window, to the iframe once the server is running on the pyramid. So you can transmit the messages up. We needed to implement like a custom hot model replacement to avoid reloading when the user was changing the solve.js. So we were using import meta hot asset under the hood. And to speed up the start time, because we are talking about 3D and this could delay or affect the performance of the page, the way of doing it was zipping, like creating or mounting two files. One, it was a zip with all the source code and everything that we needed, like all the Node modules pre-installed, and then a script to unzip it and load it. So we completely skipped the installation process of the whole thing. It was already installed, and I think this is something that the Svelte Kit tutorial team made it possible, so thanks for the trick. And also don't forget to configure the course in your Vite app. And with that, we can talk about the learnings of the whole experience. So as a takeaway, you can use Thrust.js to build immersive 3D experiences on your websites declaratively by using view components. You can also integrate it with web containers to run a Vite dev server in the browser tab. We can simply integrate an editor and a functional 3D scene in the same page and allow the user to modify the 3D scene. Projects are way more fun when they are done with friends. And last but not least, the web is amazing and is full of potential. Imagine all the cool projects that you can build after seeing this integration. I want to thank all the contributors of Thrust.js. Without them, this package wouldn't exist and wouldn't be possible to do with Vue. Thanks to our sponsors. I'm happy to see this list grow. So thank you to everyone that has contributed financially to the project in the last months. If you want to help us, at least with the coffee, because coffee runs our machines, please do it in the same link in sponsors GitHubs or in GitHub sponsors or in Open Collective. And thank you very much. See you in the next one. Ciao, ciao.
Hello everyone, I'm Akansha. I'm an independent full-time open source maintainer and I'm really excited to speak at ViteConf 2024. I'm one of the core maintainers of Excalidraw and last year we migrated from Create React app to Vite, which was not just a regular migration but a huge collaborative effort between the Vite and Excalidraw communities. And today in my talk, I'll be diving into this amazing collaborative journey and share the experience. So let's get started. Let's go a little back when Vite was at a very, very early stage. So on March 19, 2021, Pathak posted this on Twitter or X. He basically tried out integrating Vite into Excalidraw's dev environment and he shared that the developer environment time, the HMR time, reduced to half by 50%, which was really amazing to see. And this caught our attention and we were really excited to see that, okay, there is some interesting fast build tool coming up and we should be keeping an eye to it. So that's how we got to know about Vite. And 2 years later, Wes Braga, in one of his live workshops, chose Excalidraw to showcase migration from CRA to Vite and what are the steps needed to do it. And he also opened a pull request on the Excalidraw repository as well for the same. And this also gave us an idea on what amount of effort we needed if we want to migrate to Vite at some point of time. Few months later, we started considering this as a priority that, okay, we should migrate to some better build tool to improve the developer environment and the overall maintenance of the project. And we chose Vite to do so. Let's look at the reasons why did we go ahead with Vite. So the build time of Vite is definitely significantly faster than CRA, Create React app. And even the hot module replacement HMR is faster in Vite as compared to CRA. There were a lot of case studies available on the web to understand the time difference and how Vite is better. And a lot of articles as well. So yes, we were definitely excited to try out Vite for these reasons as well. And CRA, if you have used, it has this strict rule that you cannot really import anything outside the source folder. So all your code stays inside the source folder. And this was at times an hindrance for us because being a monorepo, we wanted to decouple the source code and move files outside the source folder as well. But this was not possible due to this limitation, and since we didn't have this any such strict rule, that was really good news for us. And CRA was no longer maintained and not recommended by the official React docs as well, so we wanted to move away from CRA at some point. And the most important point, Vite is growing and has an amazing community. The amount of community has been insanely high, so that was a really great news for us, and we really wanted to try out Vite. So the next step was to come up with the to-do list of how we can go ahead with the migration. What are the tasks needed for us to migrate the entire project to Vite? So this was the entire list of the to-dos. As you can see, migrating to Vite variables, the dev build, the production build, the NPM package which we have, the service workers, the PWA, the tests, everything we wanted to migrate to Vite. We didn't want to take it as small steps and then leave something for later. So we wanted to take some time and migrate the entire project to Vite. And it started very smoothly. The documentation has been great in Vite as well as Vitest, all the other plugins as well. But still, there were certain tasks which where we needed some support and help from the community as well to help us resolve it. And those were migrating the test to Vitest, service worker, and PWA. So all these plugins, all the Vite related plugins were at a very early stage. All the plugins were at 0.x version. Even the Vitest was, I think, at 0.3.x version. And service workers and PWA, everything. So now we started migrating the test to Vitest, and it was running smoothly. But there are a couple of issues we faced when migrating the test. And I'll be diving into all these 3 tasks and how we were able to resolve it with the help of support from the community. So let's first understand migrating the test to Vitest, what were the issues we faced. So since Excalidraw is a canvas-based editor, we often have to mock the canvas to write the test. And for this, we use this library, just canvas mock. This basically helps you to mock the canvas. And there was, since we were migrating to Vitest, we came across this library Vitest Canvas Mock, which is basically a wrapper over the just Canvas Mock, and it is compatible with Vite. So we migrated to this library, but there were some errors which were throwing up when we tried to use this library. And one of the issues was this. If you see this, notice this error which was being thrown, basically prototype of undefined. This was some unhandled error rejection. And I opened an issue in the Vitest Canvas Mock repo to understand and discuss how we can actually resolve this to unblock the migration. And on further debugging, I realized that, okay, this error is not really coming from the Vitest Canvas Mock repo library, but from the just Canvas Mock. And since Vitest Canvas Mock is a wrapper over just Canvas Mock, the error is being thrown from Vitest Canvas Mock as well. There was an issue created in just Canvas Mock as well for the same. And it was being thrown from 2.5.x. And sooner, in few days, Robert Soriano, creator of Vitest Canvas Mock, released a patch version with downgrading the just Canvas Mock to 2.4.0 so that we are not blocked on this. And sooner, even the just Canvas Mock released a patch version 2.5.2 fixing the issue. And a few days later, Vitest Canvas Mock also released a patch version 0.3.3. So everything was in place. Everything was working well, and this issue was resolved in a very smooth manner. And a lot of people were involved, if you see. So yeah, ultimately, this issue was resolved. Now, there was another issue which we were facing when migrating the test. The best thing was that the Jest API and the Vitest API was very similar, kept very similar, so that the migration is very smooth. So there is this API called require actual. Basically, when you want to mock some utilities or some functions of a file, or basically a file partly, not entirely, you basically require the actual file and then basically mock that particular utility or mock that particular function. So in this case, I am trying to import the scene/export file and mocking the export to SVG. Now, similar to require actual, there was this import actual in Vitest, and the syntax is very similar as well. So I tried to migrate the syntax, and unfortunately this ran into some infinite loop and the test started hanging. So I went ahead and opened the issue in the Vitest repo regarding this. This took some time to resolve. But in the meanwhile, we were able to fix this with a combination of spying and mocking. So instead of using the Vitest mock API, what we did is import the entire file and then create a spy on that particular utility and then just use the mock implementation API to update the implementation as per your needs. And this helped us as well. And later, in few months, this issue was resolved as well. So this particular mock and spy thing was not needed. So yeah, and with this, all the issues related to tests were resolved and all the test cases passed. Everything was great. So yes, we were able to successfully migrate to Vitest. All the tests were migrated to Vitest. Awesome. So now I would like to share the next task, which was service workers and PWA, progressive web app. This is essential part when it comes to Excalidraw because we offer offline support and progressive web app as well. So now, again, this was very smooth with the help of Vite plugin PWA, which was again at a very early stage as well. In CRA, if you have used, you basically have a lot of, you might have to write some custom code. You have this workbox dependencies as well. But in Vite plugin PWA, it was all, concised to just a small config. You basically give the config and it will take care of it automatically. You don't have to write any extra code. So we were able to migrate it, but there were certain issues which we were facing. And there were two issues which we were facing, to be precise. Now, number one is we create this runtime cache for locales. So Excalidraw supports internationalization. And for that, we create a runtime cache for locales so that we don't want to pre-cache it in the service worker because all the locales will be pre-cached at once. Instead, as the user switches the language, as the requests are fetched from the network, we want to create a runtime cache. So only those languages will be cached which are being used. And similar for fonts and font.css. So we wanted to basically create a runtime cache for locales, fonts, and the fonts.css file. So we, the way you do it is you basically, with the help of, since it's all config, so basically create a config for runtime caching. You tell the URL pattern. In this case, I'm basically creating a runtime cache for fonts. So it's TTF and ODF and WFF2. You specify the type of handler, the caching strategy. Cache first is basically it checks first in cache and then it fetch, if it's not present, it fetches from the network. You name it the cache, in this case it's fonts, give it the expiration strategy, max entries, and what is the maximum time you want to keep it. So it's 90 days in this case. So this works fine. But for some reason, it was not working for locales specifically. So I went ahead and created an issue in the Vite plugin PWA repository, explaining the issue. As you can see, all the locales are being pre-cached in the service worker pre-cache. And there was this, in the documentation, I came across this navigate fallback deny list attribute, with the help of which we can actually avoid pre-caching certain files or folders. But it didn't work out. So I created this issue so that we can discuss and understand how we can take it further and get unblock on this, so that we can migrate to PWA with the help of Vite plugin PWA. Now the interesting part here is this was not a straightforward resolution. It didn't have a straightforward resolution. We've had a lot of back and forth conversations. If you notice, it has 59 comments in this issue, so there were these many conversations. And after a lot of back and forth conversations, we were finally able to resolve it with the help of custom rollup config. So what we basically do is we have this manual chunks. We go through all the chunks and basically check the path if it is package Excalidraw locales, which is basically the locales path. And if it doesn't have these two particular files, which is en.json and percentages.json, because en.json is basically the English file, we want to load it always by default. So we don't need to keep it in the runtime pre-cache. And same for percentages, that is not needed at all. So if it is in package Excalidraw locales folder, excluding the en.json and percentages.json file, then let's just push it to the locales chunk. That's it. And this actually helped us to create the runtime cache and successfully have those chunks as we wanted. And yes, after this, all the PWA queries were successfully resolved, and PWA was possible just with the help of config. No custom code was needed. No workbox dependencies were needed. And the interesting part is debugging was much more easier. So in CRA, the debugging was not that smooth. Whenever there was something we wanted to debug in local, making the service worker run in local was a little bit difficult. But in this case, the service worker, the PWA was very much easy to debug stuff in the local, and that was really great. And huge thanks to Oxc and Sanche for this, for helping us throughout and supporting us throughout for resolving all the PWA queries related to Vite plugin PWA, because it wouldn't have been possible without the support from Oxc and Sanche. So yeah, and yes, we deployed to production on July 26, 2023, and everything everything went as we decided, but not really. We had to revert the migration within few minutes because we came across some issue which was a big hindrance for us, which was a big blocker for us, and that is the developer experience got impacted to a great extent. So what happened is, in a dev environment, when you are basically editing some huge file which has like thousands of lines of code, and we have a couple of these files in Excalidraw, and when you edit these files, the HMR gets very slow. Basically, it takes around 8 to 10 seconds in Mac and around 15 seconds in Windows to load, and even it shows blank and started showing blank screen. So this was a very big impact on the developer experience. So we had to immediately revert the PR. And then we started debugging the issue, and Joaquin again started looking into profiling, that how can Vite profiling can help us to understand where is the time getting consumed. And then we had been having internal discussions as well. And then finally we were able to resolve it. We removed the Vite plugin ESLint, and we were able to reduce the time from 8 to 10 seconds in Mac and 14 seconds in Windows to just 3 to 4 seconds. And we also integrated Vite plugin checker. This was really fast, and it as it runs behind a worker thread, so it was really fast, and it also shows these errors in browser, which is great. So you just don't have to just look at the terminal, you just look at the browser. And yes, and then next day, 27 July 2023, we were able to deploy to production, and since then it has been working awesome. So a huge shout out to the whole Vite community, without whom this wouldn't have been possible. And also congratulations to the Vite community on crossing the 1000K contributors milestone. That's really a big achievement. And yeah, kudos to the whole Vite community. And thank you so much, Partha, for inviting me. And I had a great time preparing the talk and sharing this experience as well. And thank you to the audience for listening to my talk. If you have any feedback, any questions, please reach out to me. You can scan this QR code and we can connect on socials. I would love to connect with each and every one of you. Thank you so much. I'm really looking forward to the rest of the amazing talks which we have in this conference. So yeah, goodbye. Thank you so much.
What's up, y'all? B-Dougie here, and I'm super happy to give another talk at the ViteConf. So last couple of years, I've given different types of talk around the same subject, which is looking at open source data, and this is going to be focused on the culture of the Vite ecosystem. So I only have 10 minutes, so I'm going to kind of rush through a few slides, and everything's recorded, and would love for anybody to hit me up if you have any questions after. But did want to point out, earlier this year, I did have a conversation with Evan about the Vite ecosystem, and would love for everyone to listen to the whole 40 minutes of this conversation. But what we were focused on in the conversation was like, why is Vite everywhere? Like, why is it the cornerstone of so many front-end tools, really just generally in front-end tooling? It's actually very interesting. And we cover that in the podcast, but I'll focus on a small portion of that. Also wanted to point out, of the day of this recording today, I saw Vite actually, I thought it would be useful to put in my slides, but Vite, 15 million downloads per week, which is absolutely amazing. Wanted to point out my trajectory personally building open source started around this point, around the Vite, I think 1.0, 2.0 days. Actually, I already forgot what the actual version was that launched early 2021. But at that point is when I started using Vite, and we started using it in a small project, side project for open source, where we were building our own meta React framework. We never launched it or productized it or anything like that. It just sort of existed. We don't still maintain it, but it got me really involved in Vite on the earlier days. So I mentioned open source. This is the product that I work on day to day and talk about all the time. So bear with me as I use open source to share some of the storytelling and data as well. And then also should say I'm B-Dougie as well. All my links, Chief Software Officer, you can find here. So going back to why is Vite everywhere? So Vite has 61,000 stars. And I think sometimes we could always fall over of like focusing on stars as the best, I guess, a metric to identify success. And I think actually stars is not one of the best metrics. Like anything over 15,000 stars, honestly, anything over 1,000 stars, you're good. Like you don't have to focus on stars anymore. There's other things you could focus on, which in particular, a year ago, or actually last fall, we focused on trying to develop this sort of metric called confidence. And it's not even sort of, we actually have this in our application today. And the idea is like any folks who stars a project, forks a project, should have like basically what we call confidence, a confidence rating to approaching a project for a contribution. Now, this is the URL. I showed that before, but I'm going to highlight the confidence in particular on what we call repo pages. So this is freely available. You can search for any repo. I'm going to focus this conversation around Vite today, but you could search for any repo and see the same data. But 70% in the last 6 months of all folks who interact with the Vite repo have a chance of making a contribution or have made a contribution to open source. This is actually really fascinating because when we sort of crunch the numbers, on average, you're going to look at 15 to 25%. So Vite's above, like right within the average mark, but high is like 30%. 30% is going to be pretty high. And like we've seen for more projects that are more like plugin based, like where you're just adding plugins to an ecosystem, like kind of like the VS Code repo or similar projects like the Nix OS projects, those tend to have a higher confidence because you're going to interact, you're going to add a plugin directly to that repo, and it's like the lower bar imagery. Also, Markdown projects are going to have like a super high confidence as well. But thought that was super fascinating because Vite itself is pretty approachable. Now, early days, I went back to old PRs for Vite, and I saw one of the earliest ones, PR number 12, Docs PR, got merged by Evan. Earlier days, you're going to see a lot of this. Here's PR 41 from Underfin. PR, another little low effort, not even low effort, like a couple files changed, get merged by Evan. Early days, PR number 41, only a month later, 4x the amount of PRs. But when you look at a year later, same person, Underfin, 3,800 PRs later, you have more structure. You have Patak now approving PRs and merging them. You have governance set up within a project. And you find that there's now a centralized team, a core team that's kind of pulling more people from the outside, which is going to be the second metric, which I'll talk about, which is why is Vite everywhere? It's really the outside contribution, eventually that sort of rates of self-selection. And I studied statistics in college. Actually, I learned how to code while getting my MBA and learned a bunch about stats and statistics and business calc and stuff like that. And rate of self-selection is pretty common of like when you have a core team, how much folks come back to the inner circle or have opportunity to even make a contribution in the inner circle. And the way we represent this back on the repo page is through this chart where we can identify things like outside contributions. So in the last 6 months, 177 contributions, 125 of those came from the outside. Now, this is not inclusive. These are basically inclusive of PRs. So if anybody YOLOs directly to the main branch, like we're not counting that. If your releases happen through a different process, we're just counting purely outside contribution in PR form. Pretty fascinating. I think projects like Nix OS or projects like VS Code, they take contribution on the outside, but they're all specifically high confidence, add plugins directly to that repo. Different sort of pattern, but yeah, I would say like this is very interesting to look at. And I point this out because the way we sort of identify outside contribution are folks with merge access within the project. So here we got folks who we can mark as maintainer because they have merge access. Other folks who don't have merge access, not maintainers. That's how we identify those. Another thing I would want to point out is like engagement. Now, when I used to work at GitHub, and I don't think I mentioned this already, but a lot of people know this already about me, but worked at GitHub, we identified top 100 projects not based on stars, identified that with unique issue authors. And having unique issue authors is a really good way to identify engagement. Also with PR commits and collectively of issue comments and alongside of reviews makes a really good formula for engagement. We have a little more complicated, but the way we identify this is here in our workspaces. So I've actually dropped in a bunch of repos in a dashboard what we call workspaces called Vite Ecosystem 2024. These are all projects that are dependent on Vite. And you can see across the board, super high engagement, what we call it activity here. And I thought that was fascinating to also point out where you're seeing a lot of, even 4 years into this game, you see a lot of vibrancy and a lot of energy coming from not just Vite projects, but projects that depend on Vite as well, which is pretty cool. Now, one thing I'll point out is the lottery factor. And lottery factor, you'll see across the board, some are high, some are pretty low. The idea of lottery factor, like folks end up winning the lottery, there's a chance they might not come back and make a contribution. And I bring that up because you might hear this as bus factor, but in the context of being a little more positive spin of why people maybe not come back to make a contribution, lottery factor is it. And it's pointing out, like, we've got folks, we got the Nux team, which has a very core group, but then we have a moderate lottery factor for folks like Vite. And then we've got high for across the board for other smaller core teams. Astro's pretty unique, where they have a pretty good distribution of contribution. Like, and again, I would say lottery factor, whether it's high or low, it's not a good or a bad thing. It's just more of an observation for folks to react to. There are good reasons for why you would not have tons of outside contribution. There's great reason for why you would. Cool. And then the other thing I'd point out is in this table where you make a workspace, you can see the confidence across the board. So like analog is a 23%, but Vitest is actually really interesting, which is a 35%. So the barrier of entry, the opportunity for folks to make contributions to Vitest, completely different than any project across the board. And then the last thing I want to mention is, like, we've been spending a lot of time, like we as an open source, looking at this type of data, kind of understanding, like, okay, and we had this hypothesis of, like, there are clear, like, strategic players within the Vite ecosystem, folks building the movers and shakers. I call them tastemakers in particular, who are like building the sort of future of this ecosystem. And we wanted to build like a thing called Star Search. And Star Search is there's a show in the 90s where you would Ed McMahon would discover people like Beyonce and Justin Timberlake. And I wanted to find developers who are on the up or up and coming, very similar to like early days in the Vite ecosystem. Sort of find like an Anthony Fu or Batak as well. And so we put this together. It's basically just like everyone else is doing AI. We've got a bunch of agents who are going through structured data, specifically in pull requests and with issues, and basically providing a very quick search and lookup across a ton of data to answer questions pretty quickly. So I'll move myself over to the right a little bit, because Star Search itself, it's going to be a pop-up on top of that same workspace. We have other iterations. We're actually open to a ton of feedback on this, because we don't know what the perfect interaction of this. It might be just like generating reports rather than chat interaction. But the idea is, I'm asking a question like, who has been working on relevant contributions within this workspace? And I can get really quickly folks like Toby from the Redwood project and folks like Dak and what they've done recently within the projects I'm looking at right here. So a lot of times I don't know what's happening, or I don't know. Actually, I didn't know the entire Vite ecosystem what I sort of made up of. So I was able to sort of query and find out more thoughts on being able to display folks like Anthony and seeing his profile and seeing that his Oscar is a metric, a combination of personal metrics of contribution quality and confidence, and sway, which is your ability to add commentary and conversations to repositories. His Oscar is going to be a top 1%, 262. Brandon Roberts, who specifically works with me on open source, but also maintaining and building the analog project, which is built on Vite, kind of bringing Vite into the Angular space. And then we also have Toby, who I called out before, who I discovered from doing Star Search, who is bringing Vite into the core, from the core team into Redwood.js. So why is Vite everywhere? Answer that question with like a clip and a quote from Evan Yu. I won't play it here because I don't have time, but like, great contributors make a great ecosystem. And it really comes down to that. Vite does a really good job of providing a path and like really just giving you enough of the deal up front so you can be dangerous and really solve problems within your own ecosystem. So whether you're building a framework or you're just trying to improve performance of really improve developer experience, I think that's really at the heart of like why Vite is winning and in so many different areas. But I wouldn't even call it winning. It's just Vite's just doing a really good job and remarkable in a bunch of different areas. So that's it. I did show off these dev cards in a couple slides ago. If you want to check it out, you can see your data. If you have any questions or feedback, would love to talk about the data you saw. And I'll be around I'll be around. Find me on the internet. All right. And then remember, if you don't got sauce, then you lost. See ya.
I'm Jason Miller, and I'm going to talk to you today about scaling Vite at Shopify. I work on Shopify's largest React code base. It was bundled with Webpack. It's about 5 million lines of TypeScript and 800 routes, and historically it has been too large and too slow for us to run on our very fast local machines. And it's also been too large for us to build in CI on pull requests. And in general, it's just been painful to work on. Last year, we converted this app to Vite, and it is effectively now a Remix single-page app, still the same size, but now it's actually faster to work locally on it than it is to use our cloud-based IDEs we were relying on before. And it's fast enough to run a production build that we actually not only do the build in CI, but we run it, we smoke test it, we had extra time. And in general, it's just nice to work on. So what did we do? Obviously, we migrated from Webpack to Vite. This was a combination of hard work and code mods and also a lot of custom Vite plugins. And in general, there was a process of getting rid of custom transforms. We had a hard and fast rule. We were not going to have custom AST transformations in this bundler configuration because that way we could avoid the whole Babel parse cost in Vite. We found that Vite plugins were sort of a superpower for this migration. Some examples, we wrote a plugin to enable CSS modules for all CSS imports by default, still leveraging Vite's CSS modules implementation, but just by default. We wrote a plugin to do our bespoke translation loading. We wrote one for our GraphQL TypeScript type generation stuff, and then also one to preload the module graph, which is now actually a feature that Vite provides out of the box. There were some really interesting knock-on benefits of these. The CSS modules by default one, we actually just went to production with. We only got rid of it recently. Translation loading enabled us to kind of trivially turn around and do hot module replacement for translations, which was novel and fun. The GraphQL plugin that we wrote actually ended up giving us a foothold and making everybody aware that it was a thing to optimize what ended up being hundreds of kilobytes of JavaScript output from TypeScript transpiled enums that were in our production bundles. And that cut the size of those bundles by 80%, which was fun. And then the module graph preloading, ours is quite aggressive. By the time you open Chrome, we've already loaded all the modules in Vite and you're just hitting a cache. So when we first cut over from Webpack to Vite, we were in for a little surprise. When we loaded the homepage, we were sending 18,000 modules to the browser. It took 30 seconds, that's being generous. It might have been more like 60 seconds to load. It was not actually that much slower than our initial load in Webpack because of some other reasons. And we did have 1 second hot reloads, which is great. But also there was definitely a head scratching moment. Some of the plugins we wrote cut this down. So we were already at about 15,000 once we did some basic optimizations. But we were left wondering like what was going on. And the answer to that question is barrel files. If you're not familiar with barrel files are basically JavaScript modules that re-export other JavaScript modules. We were using them to sort of make directories feel like packages and give a bit of structure to the code base. This was pervasive. We used them everywhere. We had rules for it and the whole shebang. But we found a lot of harm caused by barrel files. The first harm that we found is a form of dead code. So if you're not familiar with dead code elimination, basically, if you assume we have some sort of an export down at the bottom where there's a constant scenario, we can dead code eliminate the thing that is now constant. We're in production, so we can delete the development thing. And you could just follow that up through the graph. So we can delete devs that's unreferenced, dev queries unreferenced, DQLs unreferenced, and you end up with just no op. If you wrap that component in react.memo, so just basically take the function declaration, make it a function expression, and everything else held constant, now you can't dead code eliminate it because the bundler doesn't know what memo does. And so what we found is in Vite, we would end up with dead modules. This was happening in Webpack. We just didn't know. But when we switched over to Vite, this became more apparent to us. And so how this happens is, say we have a module like the one on the left that's re-exporting some stuff and has its own export, and then we have just a module that's using it on the right. It's only importing usefoo, so right away we can go and we can delete the unused exports. That's great. We cannot delete the imports that it has because we don't know what those are. They could be setup functions. They could assign something to window. Can't just remove whole modules. So we can go and we can delete the export of foo context because it's not referenced by foo/index.ts anymore. That's all fine and great. But its value cannot be elided because its value is a call to create context. We don't know what that is. And it passes it heavy.defaults. We don't know what heavy is. We don't know what defaults is. And we don't know what either of those two imports are. They're all going to stay in the bundle. Dead code elimination will not fix that. The second problem we run into is reduced clarity from barrel files. This really has nothing to do with Vite. It's just painful. So say we have a case where we're importing A from something called lib, and lib is a barrel file. It's doing wildcard re-exports of these three modules. We have to go through, and for TypeScript or Vite or a person, have to go through and figure out, using a mouse and keyboard or a compiler, where A comes from, which might involve traversing its entire module graph. And that's because if you're thinking, oh, it's fine, if the first thing exports A, then that's good, that's what A is. That's not true. It's actually the last re-export to export A that produces the value of A that we get on the left. So if all three of these imported re-exported modules export A, we have to load and run them all and all of their dependencies. Another one that we ran into is accidental import cycles. This actually really bit us. So in the case here, we're importing usefoo from this module called usefoo, but the problem is usefoo, which is re-exported from this barrel file, is referencing the barrel file. It's trying to import context from the barrel file. But if we're getting to usefoo from the barrel file, it can't refer back to us. We haven't executed line 2 of the barrel file yet. We can't go there. And so it's going to try and reference the return value from this create context call that we cannot have run yet. And actually what happens is at runtime, that value is undefined. Another thing we found is this puts some strain on infrastructure in Vite. Sorry, I get some stuff in my way here. Basically, this increases the number of files and modules you're going to have to read off of disk. So that's memory usage. It's serving time. You're sending these to the browser. It increases the overhead of the file watcher because you're looking for changes in all these files. Another one is test code shipped to production. We actually found this when we switched over to Vite. So thanks Vite, that's cool. Somebody would write a test helper imports faker. They would re-export the test helper from the barrel file because, for example, our linter told them to. Now faker's in production because dead code elimination is sort of a lie. Another one that we ran into is what I'm calling bin files. I made that up just now. Basically, this is something that is sort of a barrel file. Maybe it started out life as a barrel file, but now it's not really a barrel file. It's just JavaScript. So even if we had some magic tool that could dissolve barrel files, this isn't one anymore. For us, this happened a lot because people would take imports that were static and make them lazy using React.lazy and a dynamic import, which is great. And we should be encouraging people to do that in cases where it's warranted. But it has the unfortunate side effect of making this thing now, this is just a real JavaScript module. This is not an alias of any kind. I've been asked many times if linting can help here, and the sad answer is not really. Linters get exceptionally slow when you try and abuse them for whole program analysis, like import analysis. When we were starting this project, before we had cut over to OXLint, which reduced our linting times by 100x, we were still on ESLint, and we did an analysis of our custom lint rules, and the import rule, of which there was one, was responsible for 50% of our CI time spent linting. So what can we do if linters aren't going to help? One thing you could try is installing the debarrel plugin we wrote. This is a Vite plugin that implements a on-the-fly form of tree shaking that we're calling debarreling. And basically what this does is, as your modules are being served to the browser, it processes every import statement, pre-processes it, and turns it into the final locations of all of the identifiers that you've imported from a given specifier. So if you imported 3 things from a barrel file, you're going to get 3 imports instead of 1 import. And the import URLs will be the final URLs. So the barrel files are gone. They are no longer referenced when your modules are then handed over to Vite. In our code base, this reduced the number of modules that we were serving and also the size and time that it took to serve our initial page load by more than 50%. I think it's 58%. It is the single largest optimization that has gone into this code base in the last year. You can also enable tree shaking. This version of it will probably break your app because it violates a lot of JavaScript semantics. This version of it is way too specialized for you, but maybe pick and choose some stuff. We do something like this where we basically say like, hey, those imports for GraphQL files, those are going to be JSON when they're served. So yes, feel free to consider those as non-side affecting and tree shake them. We use this in combination with the debarrel plugin. And the last thing you do is just delete the barrel files. I think I've made a good case for them not being worth their trouble. And the benefit that you will get out of this that the plugins can't provide to you is that you will probably find dead code when you do this, because when you delete the barrel file, you will find that there was modules that were referenced via re-exports in the barrel file. And the only way they were referenced is by those re-exports in the barrel file. We certainly found this. Okay, so with that all in place, we're getting better. We are down from 15,000 modules to 6,000 modules. Some time has passed. And our initial cold page load in development is about 15 seconds. Like a lot of React apps, we were basically doing a thing where we loaded most of the app up front, load the entire JavaScript and then say like, hey, React, render the app, which immediately deops out to rendering a skeleton screen and triggers critical data fetching. At this point, we've already downloaded, a meg or 2 of JavaScript, all of our UI frameworks and tooling in order to render a skeleton screen that we sent to the HTML anyway. We just re-rendered it for no reason to get to critical data fetching. We're basically doing all the most important stuff last, which is backwards. The problem we had was all the most critical things that we were doing were entirely dependent on our UI toolkit and the UI framework we're using to render it. And so the only way for us to move forward with this was to disentangle those 2 things. So we created a space in our app called app context that is the new root of the module tree. React is not at the root of our module tree in this app anymore. This is actually quite similar to how React Router 6 works. We may have stolen the idea from them, just saying. So app context is basically just an object that exists outside the React tree that we instantiate. It's a place where we hoist our global concerns to, and then we just pass it into the React tree once that stuff loads. That also means that it's initialized before React and our UI toolkit stuff and all of our routing, and it runs independently of it. So while we're going to the network downloading those heavy things, we're doing this critical thing. It has the same API everywhere because it's just vanilla JavaScript. We use preact signals for reactivity there so that we can have reactivity without having it being bound to a given UI framework. And basically the way that we built this is it's just factory functions that construct properties on an object. Now our data loading actually happens pretty much right away, right? We ship the minimal amount of JavaScript and then we're off to the network doing data loading. It's kind of like a little bootloader type thing. And it happens in parallel with our heavier UI related code being downloaded and executed. So we're doing the most important steps first and also in parallel with the less important steps. So our module graph at the root sort of looks like this. We've got the entry chunk, and then it has dynamic imports for our rendering chunk, which is the React-related stuff, and our router chunk, which is the route definitions, and then that has dynamic imports for every route and every route loader. We hit a snag with this, though, a Vite/Rollup snag. Because we had one entry module with a bunch of dynamic imports for the rest of the graph, the bundler very much wanted to push common dependencies up into that module. And it basically, if we had a logger that everything was using, the logger was going to end up in entry because it knows that entry was guaranteed to already have been loaded by the time you hit router or hit render. And so it's just going to move common stuff into that chunk, which seems like a good thing, right? You bloat that chunk a little bit, but hey, why would you send 2 modules? The problem is this creates import cycles. And so we use hashed URLs for long-term caching. And so say I go in and modify the loader for a given route. I change the API URL or parameter that it's accepting. That bundle now gets a new hashed URL because its contents changed. And the router has a dynamic import of that bundle in it. So now the router's contents have changed because it has the new URL in it. The entry chunk has the dynamic import for the router. So now the entry chunk gets a new URL because its contents have changed. But unfortunately, all the routes have static imports for the entry chunk. And so they all get new URLs because their contents have changed because they have the URL of the entry chunk in them. So does the render chunk. And really what happened, like our entire graph would get invalidated pretty much every time we changed anything. It had nothing to do with route loaders. Everything imported the entry. We had this giant cycle. The whole graph was a cycle. How do we fix this? This took us a long time to sort of come up with the right methodology, but where we landed is the entry chunk can never be imported by any other chunk, full stop. If that happens, explode. And so we use manual chunks to basically each module that comes through manual chunks. If it would be in the entry chunk in that it is very broadly shared, we put it into a second chunk called common. And so the effect that this has is if I change the route loader again, it gets a new hash. The router gets a new hash because it has a dynamic import for the route loader. And the entry gets a new hash because it has a dynamic import for the router. And then it stops because nothing ever imports the entry. We've terminated the cascade. We had to go to some efforts to enforce this. Obviously, we did the manual chunks work, but then we needed to make sure that none of the changes that were going into our code base would break this. Because again, manual chunks is a very sharp sword. And so we started to iterate on a Vite plugin that enforced bundle constraints. Basically, just before Vite was about to flush the bundles to disk, we go through all the bundles and we look at the modules that are contained in them and the code that they contain, and we find cases where nonsensical things have happened and we explode. If we ever find UI-related or rendering-related dependencies in the critical chunks, like in the entry bundle or the common bundle or the router bundle, which are definitively things that should not be waiting on those things to download, we explode the build. Another one is we identified the scenarios that can cause the cascading hash invalidation via cycles thing that I just showed, and we'll explode the build if we detect those. We're down from 6,000 modules to 2,300 modules just by reorganizing the root of the app. This is actually pretty good. So we're serving these over HTTP3. We're actually serving them locally now. And so this loads in about 4 seconds, which is really not that much slower than production, right? The rest of our journey for this it's still very much predicated on stuff we're building on top of Vite. But it is actually a lot more just about having an engineering culture of code quality and minimalism. Speaking of which, there have been some interesting culture impacts of this at Shopify. One that I'll highlight here is in the environment that we had before, where there was like a slow startup and an upfront build, and you had to stand up the backend to reference it via this Webpack dev server. We had this culture of spinning up a bunch of throwaway hosted VMs to run VS Code remote sessions against, just to do multitasking. And now we have like a 15-second dev server startup and no upfront build. And we actually built tech that uses Puppeteer to launch a Chrome instantiation that it opens our production app. But when that app sends the JavaScript and CSS, we swap it out for the Vite dev server JavaScript and CSS. And so you can actually just work on production, but with your local files, but with production data and hot module replacement. It's actually extremely weird the first time you do it, but it's like 10 times faster than what we were doing before. Okay, so I'll leave you with a demo. On the top is our Webpack setup from a year ago, and on the bottom is our Vite setup from today. So you see I've just hit save on the top. On the bottom, I've hit save like 5 times already. On the bottom in our Vite setup, HMR takes 5 milliseconds. It's all local. On the top, you see I hit save. It's about 12 seconds for hot module replacement. And this is literally editing the same file just 1 year later. So again, this is not just Webpack versus Vite. But Vite was super instrumental in us enabling these things. And with that, I leave you.
Hey, my name is Arina. Welcome to Using Vite Ruby. Ruby is powering some of the main applications that you're using every single day, including GitHub, Stripe, Figma, Shopify, Intercom, and of course, StackBlitz. And it's not just those big existing companies, but also a bunch of startups are choosing Ruby and Ruby on Rails every year. And this is just a small selection that I spoke to in preparation for my RailsConf talk this year. But people, they choose Ruby and Rails as the language and the framework specifically optimized for developer happiness and developer productivity in building web applications. But this productivity and this happiness has to include frontend, right? So in terms of the frontend, Rails has a few different options. One is dual stack, or the API-only mode of the Rails application that then integrates through this API with the front-end application, React, Svelte, Vue, Astra, etc. In recent years, in the search for productivity and efficiency, people started using this new Rails full stack HTML over the wire technology, Hotwire and Turbo, Stimulus. And there's its own component systems, its own component approach to components, vComponent over Flex. Now, there's also a mixed approach where many companies find that it's nice to be able to build simple CRUD-style UI with Hotwire and maybe vComponent, but then they also want to be able to add React or Vue when they want it, when, let's say, the data model on the front end becomes more complex. And this is when they want to either substitute just one view with React, or they just want to kind of plug a single or a couple of React components into a Hotwire frontend. And people use Inertia.js or similar technologies, and we built a Turbo Mount for that. So this complex frontend comes with a complex set of build tools, of course. And this is the talk from this year's RailsConf by Marco Roth, where he was reminiscent about looking at all the different build tools that we've been using in Rails community over the years. And I'm going to say all those tools are definitely still used by a bunch of Rails applications this day, because we're not only starting new projects, we are maintaining and growing and developing existing successful products and in existing successful businesses, right? I also remember when I was learning Rails myself, problems with asset pipeline and Webpacker were the hardest, something where I could have died probably. A little bit about myself. I'm Irina Nazarova. I run this company, Evil Martians. We are a consulting company for startups, and we focus on a few areas: products for developers that we love to design and build, startups on Rails that we love to grow and help scale, and then real-time and collaboration-heavy apps or tricky collaboration features that we help build, and finally local-first apps. I see our role in this community as the company that is building the missing tooling specifically for startups and specifically in open source. And this is how many people know us as authors of PostCSS and Autoprefixer, but also image proxy, left hook. We open sourced our Martian mono font. We built OKLCH color picker, and a bunch of two big WebSocket products, AnyCable and Logax. Now, the asset pipeline is hard, but it's it was definitely a red flag for me when inside of Martians, people would say something like, hey, we need a front ops engineer here. So like a normal Martian frontend is not enough. We need a special person to fix kind of asset pipeline problems. So it kind of means that we're not helping ourselves as an industry, don't you think? The author of Rails, David Heinemeier Hansen, definitely agrees, so much that last year he announced that no build is going to be the new mainstream for the new versions of Rails and the new applications on Rails. And yes, no build is definitely faster than any build tool that exists or going to be existing, but it's just a great illustration of how much people are fed up with the problems with the build tools and asset pipeline. And, well, you could say, who am I to contradict or disagree with the author of the framework? But we just have a different experience at Evil Martians. So this is just an example, a story from last week. Somebody reached out saying that, hey, I was not able to deploy my application to Heroku because import maps, no build, are not loading properly. And the problem is hard, and I can definitely relate to that. Now, we believe no build is not the solution. And what does the ethos of Rails tells us about this problem and how to solve it? So there's a bunch of build tools, and we see that the innovation here is not stopping, that probably there are going to be new tools, and migrating every single time is just too hard. It's not possible. So the ethos of Rails says that, well, there's a missing layer of abstraction here. There has to be an abstraction that provides amazing developer experience to the application, but then handles all the hard work of integrating with particular build tools on its own, kind of hiding this complexity from the application so that we also don't have to migrate to a different build tool every time something new is built. So, and this is what Vite is for us. And Vite and Vite Ruby are the technologies that we advocate for because we believe, yes, this is the right solution because, yes, we have the best developer experience and we also abstract from having to integrate with each tool, with ES build, rollup today. And tomorrow is going to be something else. So let's use Vite, and we are building turbo mount and inertia.js generators as part of this Vite plus Rails ecosystem because we believe in it. And here, of course, I want to give a shout out to the author of Vite Ruby, Massimo Mussini, who's been speaking at ViteConf a couple of years ago. Check this out. He's done an amazing job in integrating Vite into the life cycle of assets inside Rails. So back to that story from last week. Of course, we are consultants and we could have charged money for helping this person, but we just said, look, take a look at Vite Ruby. You might be able to solve it. And the same day we got this message. Hey, I was able to solve it in just a couple of hours. Thank you so much. Yeah, and this is what Vite Ruby is for us. And I'm just gonna share a few more stories, a few more quotes from our customers at Martians who chose Vite and Vite Ruby, and specifically Vite Ruby, and why they did so. Power Home Remodeling Group is a huge $1 billion revenue Rails company. And they chose Vite because they needed faster compilation of their assets, and at their scale, it's definitely makes sense. It's super important. ClickFunnels, another big, like over $100 million revenue company doing marketing SaaS. The guys have very complex setup with different front-end technologies, different front-end approaches, and they use both Vite and Vite Ruby. And the main thing they say, or we're not thinking about it anymore because it's just works. This startup summit says that Vite brought them the hot reloading for stimulus controllers for Rails full stack, which is great. Recognize said, yeah, Vite combines the best of Rollup and ES build. And at Evil Martians, we also love the ability to build plugins. So when we have a particularly complex situation, something like, okay, we have to load assets from inside certain gems or something complex like that, we can always write a custom plugin and use it. And it's just going to be a maintainable solution. And finally, Evil Martians, our customers, and just people in the community say that Vite and Vite Ruby are a joy to use. And this says everything to me. Now, I'm going to share a little bit about, I was asking what's missing. And I got to say, there's not much, but there's something. So first of all, incremental builds and build cache out of the box. This exists as a plugin, but this company said they would appreciate this being available out of the box, or maybe a more clear guidance. Somebody said they had problems or issues with setting up 2 different entry points. The integration with Vitest between Vite Ruby and Vitest could use some love, somebody said. And finally, somebody pointed that the updates of Vite Ruby gem sometimes are a little bit delayed. But that's that. And I'm going to say we, again, love the developer experience of Vite, and we believe it matches the ethos of Rails really well. And it's kind of a missing piece for the productivity that we want to see for startups building with Rails. So that's it for today. Thank you all who's building out the Vite ecosystem, Vitest, and thank you for having me today. Thanks so much.
Hello, I was just playing Athena Crisis here on my Steam Deck. Today, I want to talk to you about game development with Vite, because Athena Crisis is all built using JavaScript, and it's using Vite to bundle all of the code. I'm Christoph. I work at Nakazawa Tech. And if you're interested in the video game aspect of this, check out this talk about how not to build a video game from last year's React Summit. Athena Crisis just shipped in its 1.0 release on Steam a few weeks ago. You can play it on any device, on your phone, on your desktop, on your Steam Deck. It's all built in JavaScript. It has seamless crossplay, so you can buy it on one platform, play it on another platform, and play multiplayer with or against your friends. If you like what you're seeing here, if you like web development and game development with JavaScript, please give it a try and share your feedback. I would love to hear it. What is Athena Crisis? I'm just going to give you a quick demo of the game before we jump into some of the more technical aspects. Athena Crisis is a modern retro turn-based tactical strategy game. You can check this out here. I turned off the sound. There's also music and sound effects and everything. But basically, you have a bunch of units, including like this dragon. You can see the unit stats, what they're good at. You can even learn about Coco, the leader of the dragon faction. And then you can use those units to go around and like attack units around you. You can also create units or hire them at like different buildings. And that's basically Athena Crisis. There's a whole campaign to it. But today I want to show you an actual demo of what makes this interesting and why I'm talking about this at ViteConf. This is the actual code for Athena Crisis. And you just saw the game is here running in this presentation. Let's just change the color of one of the factions. Check this out. Hard reloading in like 30 milliseconds. That's all powered by Vite. The way I have set up my VS Code is that it autosaves as I type. So let's, for example, check out the outline around these units. You can, if I zoom in here, you can see these units, they get like a red outline, means that I can attack them. What if I want to change that to yellow? I can just change the color and it immediately live updates in the game. That's basically the entire development cycle of Athena Crisis. This is just how the game is being developed. Let me get rid of VS Code here. All right. And this is really fun, right? Like you can just develop a game with JavaScript and ship that to all sorts of platforms. Let's have a little bit more fun. The game is not just in the presentation is actually in the game. So we can just jump here into the actual game, and then we can play this map right here. This is the actual campaign. We can even go in here, check out the list of games. Let's see some community maps. Oh, this looks interesting. This user created a map. I could just create a game. Let me set up a skill and then play against a bot. All right, let's see what I have to do here. There are no unit restrictions on this map. All right, there's some dialogue and tells me what I can do. Maybe let's just build like a train unit here. All right. Put this train unit there. All right, no, let's jump back into the presentation. So the actual video game is running the presentation, and then the game is running in the presentation. How does any of this work? It's all just JavaScript. To be exact, it's about 214,000 lines of JavaScript that was all handwritten. That's first-party code. That's all written just for the game. There are obviously a lot of third-party packages as well. But the interesting thing for you, if you're listening to this at ViteConf, is that it's all bundled using Vite. The front-end builds, the back-end builds, the open source docs, the landing page, the slides are using ReMDX, which is a Vite plugin to build slide decks like this. It's using Vite plugin PWA for notifications and for offline support, so you can play the game offline while you're in an airplane, for example. And it also bundles together the offline screen for the Electron app. If you have never even used the game and like started up for the first time and you're offline, it tells you what to do. So end to end, that kind of means there's a JavaScript client with full offline support. There's a JavaScript server bundled into a single file with Vite. That is then packaged up using Docker and deployed on our servers. I know Vite is usually used for bundling client-side code, but I found over the last few years that it works really well actually to bundle Node applications, and it makes the entire deploy process so much simpler. It makes your Docker containers much smaller because you don't have Node modules. And if you just have Node or Bun or any other JavaScript engine and one file that you run with it, it's really portable. I'm using Vox, which is like a Vite-based React static site generator to provide open source documentation for Athena Crisis, because the game is actually mostly open source as well. And then I'm using it to bundle some files inside of Electron. And the great thing about all of this and using Vite is that I can deploy this game to everyone who is playing it within 3 minutes. And actually, it would only take about 20 to 30 seconds, but it takes about 2 minutes to run all of the tests to make sure nothing is broken in a change. Let's check out offline support. Let's go to the production version of Athena Crisis. Okay, I've showed you something similar. Let's just jump in here. Okay. So I'm playing like an online campaign here. Not really interested in continuing this right now. So this is actually the online game. We can even jump in here and look at what other people are doing. Oh, wow, that looks interesting. There's somebody actually playing the game right now. Now, let's go back here to the main menu. Let's see what happens when we go offline. All right. Oh, the game seamlessly changes to offline mode. We can jump here into the campaign. We cannot continue those right now, but we can just start a local campaign. As you can see, we're offline right now, but the entire game works. And you can see the dialogue is happening again. All of this is seamlessly handled with Vite plugin PWA. So what you're seeing here, it's not just the art, the code, it's also the music. So every time when you access Athena Crisis, it updates in the background and then asks you to reload the game. So for example, here, now I'm offline. Let me go back online. I did actually just deploy Athena Crisis. So you should see that it's going to show an update banner here. Oh, Athena Crisis was updated. Tap here to reload the game. All of that was just handled by Vite plugin PWA. And then there's this really cool plugin called Vite plugin single file. I was having this problem where I wanted to bundle a bunch of JavaScript, a bunch of assets, some sounds into my Electron app, but I really didn't want to add a complicated build process to that system. So I found Vite plugin single file, which you just add with like a single line of code into your list of plugins for Vite, and it like bundles all of your code, all of your fonts, all of your images, all of your JavaScript into a single HTML file that you can just put into your Electron app and load when you need it. That's been really useful. I've been saying that Athena Crisis is open source, and there's this tool called Vox to create static sites using React and Vite. This is the actual docs page embedded here in the presentation. The docs site even has like a demo of the game as well. But then the cool thing is that because it's all Markdown, it's all JavaScript, we can just jump in here. There's an explanation. Okay, here is how the core systems work in the game. Here's a core data structure. You scroll down, you read it. It's kind of boring. The great thing is then, oh, okay, here, how do we compose this data structure? Okay, there's like a bunch of data here. We add a bunch of units, whatever. But then the cool thing is we can just embed the entire game into the open source website using Markdown. So we can jump in here and even play the game right here in the documentation side, all powered by Vite. And then I was talking about ReMDX, which is the static site generator. Let me just bring back my code editor. We have everything right here. It's all Markdown and MDX. And we can just type here, and it live updates. And as I said, I'm saving right when I'm typing every 30 milliseconds, and it updates instantly. So this is going through MDX into a Vite plugin, and then renders this presentation directly within the video game. So we can also just like, where do I have this? I have a map. Okay. Let me go back to MDX. Okay, we're right here. Just drop this in. Okay, and now the game is right here in the slide deck again. So as I was saying, Athena Crisis itself is open source. About 75% of all of the code of the game you can check out. It's under MIT license, so you can learn how to build web games using Vite and JavaScript. ReMDX is also open source, so you can check that out to build your next presentation using React and MDX and Vite. There's a bunch of other stuff that we have open sourced as part of developing Athena Crisis. And there's also even a Vite starter template that I've been using for all of my projects that I've been creating for the last several years. There's even more open source stuff. If you like it, please consider sponsoring the open source development at Nakazawa Tech. And that's basically it. If you like Athena Crisis, if you like what you saw, if you like this cute modern retro art, please check it out at athenacrisis.com. The demo, again, is all bundled with Vite and directly playable on the website. Thank you so much.
Hello, ViteConf 24. I'm Zhao Jinjiang, a software engineer from Vite, also a Vue.js core team member. Today, I'm very excited to talk about the Node APIs in Vite and Vitest, and how we practice them in Vite. Since all the practices we'll introduce are based on Vite, you might wonder what Vite is. In a nutshell, Vite is a platform for building, sharing, and collaborating on components. Every big component has its standalone code, docs, test cases, dependency informations, and the toolchain setup we call DevEnv. Users can publish their components onto the Vite cloud and debug any one or multiple components in a local Vite workspace together. Recently, we have done a DevEnv migration from Webpack and Jest to Vite and Vitest. In general, we prefer Node APIs plus inline configs rather than the CLI commands plus config files for better flexibility in the integrations. So all the practices we'll share today are based on what have been through in this migration in Vite. Now let's dive into Vite first. Vite is an amazing dev server and build tool. It's super fast, flexible, and friendly to all kinds of modern web projects today. Vite provides 3 Node APIs for the 3 main use cases respectively: create, server, build, and preview. And for each of them, you need to pass in a config object, of course. The workflow is quite simple. Get the Vite config and start the Vite dev server or build or preview. And finally, for the build process, you can analyze the result necessarily on the return value, which is actually a rollup output object. Some details you might also need to pay attention to. First, the root path and entries config, just in case your project is in a special directory. Second, the load and merge config files, just in case you have multiple config layers in your program. And third, don't forget to listen and close the dev server properly. Now let's see how we practice these Node APIs of Vite in Vite. First, in the Vite DevEnv, we have a dev server interface. Here is a core code snippet of integrating the Vite dev server. It's quite simple. Get the Vite config, then create the server, and finally start to listen. For more details about the config, it includes the basic part, which is common for all the use cases, and the extra part, which could be customized by upper levels or by users. For the extra configs, it can be an inline object or a configuration file path. Here we use the load config from file and the merge config APIs to do the job. One more thing. Sometimes you might want to watch some Node modules and at the same time avoid them from the pre-bundle ahead for dependency optimization. To support this, you usually have to set 3 different config paths in Vite: server.watch.ignored, optimize steps.entries, and optimize steps.exclude. Now we have made a plugin called Watch Packages plugin to achieve this in just one step, passing a package name list in. Now let's see a demo of the Vite dev server in Vite. Here we have a Vite local workspace with a view component which includes source code, docs, and a code example for preview. After running Vite start, a Vite dev server will start under the hood. Then you can open the browser and click on the component to preview the docs and examples. That's all for the Vite dev server. Next, we also have a bundler interface in Vite. It supports you to build your docs and examples. And if the component itself is also an app, it will also build and deploy the app as well. The code snippet is here. Just call the build API with the config object and get the build result, such as asset map, from the returned value. Now let's see another demo. This demo is actually the slides app that I'm presenting now, which render a markdown file into slides. You can see after running Vite tag, the Vite bundler will start to build the app, and then the program will find the build files by the returned value and deploy them onto Nitrify. Now you can open the Nitrify URL in the browser to see the slides. That's all about the Vite Node API's practices. Now let's move on to the Vitest. Vitest is the modern test runner for JavaScript. Besides the just compatible test API designs, it's also powered by Vite, which makes a perfect match for our migration. Vitest also provides a Node API for the test runner. Just call the start Vitest API with the test command at the first argument and some following configs. We usually just use the fourth argument for the Vite config and the fifth argument for some actual Vitest options. The workflow is also simple. Get the Vitest config, then start Vitest tester, and finally output the test results. In terms of the details, besides all the Vite similar ones we have mentioned before, you also need to clearly specify the test files by include and exclude. And the result collection is also important. Now let's see how we practice those APIs of Vitest in Vite. Last but not least, we have a tester interface in Vite. It supports you to run your component tests and collect the results. Here is how we integrate Vitest. Get the Vite-config, then start the Vitest tester, and finally collect the test result from the returned value. Here, we didn't customize anything on the second and third arguments. All the config setup is inside the fourth argument, which is the Vite override config. For the Vite config, it has an extra test field for Vitest, which is the same as the normal Vitest config file. However, you have to specify the root necessarily. For the result collections, you need to check the failed cases, the errored cases, and the errors out of the cases separately, via 3 different places in the testing result. Don't forget any of them. One more thing, when integrating something into your program, sometimes you might be noised by an interactive on-hold prompt or an exit signal by third-party libraries. Vitest also has such a design in special conditions. For example, Vitest will ask for permission to install some additional npm packages when running Vitest UI, generating coverage reports, etc. To handle this, we have created a custom package installer and pass it in at the 5th argument. Now let's see the last demo of the Vitest tester in Vite. Here we have a component with the test case. After running Vite test, the Vitest will start to run the test case and collect the result. One last thing, all the Node APIs we have introduced above are just the tip of the iceberg. You might need to dive into them for further details. In this case, the TypeScript DTS files in Vite and Vitest packages are your really good friends. Just go and find them in the Node modules when you get anything wrong or need to know more about the APIs. That's all for today. I'm really honored to be sharing our practices on Vite and Vitest in Vite. And thank you all for listening. Have a wonderful day. Cheers.
That was amazing. We've just finished 12 hours of fantastic talks, amazing discussions in the chat. How are you feeling, Matthias?
Incredible. Like this to me, it always shows how much all our projects are growing. Not only like the Vite ecosystem, but like every one of the projects. Like if we see the first ViteConf like 2 years ago, all our projects were still like in beta, and now what they are showing and how much they have grown, it's just incredible to see.
Now, we're not going to spoil too much because for some of you, this is the start all over again. We've just finished 12 hours, but there's another 12 hours to go. The content, the talks will play again, but the chat is still live. Matthias and I will still be there. So join us there if you're just in the middle of the stream somehow.
Yeah, that you have a very good point. And so let's wrap it up. If this is the second half, so thanks a lot, everybody. Again, thanks for the speakers, the community, especially the community partners, everyone that made the conference possible. Thank you, Sarah, for being here with me and being a speaker again and being in the chat so much time. And thanks for everybody that participated, interacted with the speakers, with the community, and made this special. If, as Sarah said, if this is the first half, then Sarah, we just should introduce ourselves because we are the first one introducing the conference.
Yes, if you're just joining us now for the second 12 hours, you have a lot to look forward to. Even though we've seen it, we are happy to welcome you again to ViteConf.
Yeah, so enjoy ViteConf 24 or see you next year in ViteConf 25. See you all. Thanks a lot.